चेक वन। हेलो। 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 1 2 चेक।
हेलो हेलो चिक हेलो हेलो चिक माइक टेस्टिंग हेलो 1 2 3 4 हेलो चिक हेलो 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 चिक हेलो 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 सेम सेटअप कल था वही है। हेलो हेलो चिक हेलो 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 चिक हेलो 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 चिक माइक टेस्टिंग हेलो 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 चिक हेलो 1 2 3 4 हेलो हेलो चिक हेलो 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 चिक हेलो 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 चिक हेलो आ गया। हेलो 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 चिक हेलो
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 हेलो हेलो टेक इधर भी आ रहा
आ रहा है ना।
हेलो हेलो हेलो
बाहर जा बाहर बाहर देखा आवाज क्लियर आ रहा है कि नहीं बोल रहे हेलो चिक
हेलो
हेलो हेलो हेलो चिक हेलो 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 चिक हेलो
हेलो
क्लियर है।
हाँ क्लियर क्लियर हमारी क्लियर है
क्या चमका दे तू
हमारी भी क्लियर है
क्या
हमारी वॉइस क्लियर आ रही है
हेलो 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 हेलो
अरे
हेलो हेलो चिक हेलो
हेलो सर प्रणाम
कैसे
नहीं अभी नहीं पीछे पीछे
ढोकला साला कुत्ता हो तेरी हेलो 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 ठीक है भैया चेक हो गया। एक्शन पे करो।
हेलो हेलो
पे करिए।
हेलो हाँ हेलो हाँ हेलो
हेलो हेलो हेलो चिक हेलो
हेलो चेक हेलो 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 आ रहा
अब क्लियर हो अब क्लियर हो गया। ढीला है ना जो पहले लगा जो कल लगा था वही थोड़ा सा ढीला करके लगाइए चाहिए ना इनको। हेलो 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 नहीं नहीं हमारी थी हमारी देखो हेलो हेलो चिक हेलो ओके भैया। नहीं हो रहा है काफी गाना है हेलो हाँ पीयूष भैया ये आज तो हम फंक्शन के साथ बात नहीं कर पाएंगे कल ही करेंगे फिर शाम पूरा कल
हाँ, अगर आपको भी चाहिए एक एक्स्ट्रा सोर्स ऑफ इनकम। नेक्स्ट दोस्तों, मैं ऐसे बहुत
हेलो 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 वॉइस क्लियर है ओझा जी हेलो 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 माइक चेक हो गया?
dignitaries, esteemed faculty members, honored speakers, and all our distinguished delegates. I, Abhipsha Pal from the Department of Microbiology.
I am Dr. Divya Preeti from Department of General Medicine.
It's our immense pleasure to welcome you all to the second day of the scientific program of National Conference on Artificial Intelligence in Healthcare and Education. AI is no longer the future, it's the present, transforming diagnosis, treatment, research, and patient care. With this thought, we begin today's academic journey filled with learning and innovation.
To begin with the first session of today's scientific program, I would like to respectfully acknowledge and welcome on the dais our esteemed chairperson, Professor Sandeep Kumar Sir, Department of Pathology, IMS BHU, Professor Ankur Singh Sir, HOD, Department of Pediatrics, IMS and Deputy MS BHU, and Dr. Devesh Prakash Yadav Sir, HOD, Department of Gastroenterology, IMS BHU.
Good morning to all of you. Today I welcome you all in today's conference, AI for VIKSIT Bharat. So on this conference, I would like to welcome Dr. Survankar Datta, radiologist and AI researcher. He MD from the AIMS New Delhi, MBBS from JIPMER. He is a currently faculty fellow and the group lead and crash lab affiliated to the Quetta Center of Digital Health, Ashoka University. And he has the numerous work in the AI and he had a lot of achievements to his credit. Welcome to you, sir, for the today's morning talk. Dr. Survankar Datta, over to you.
Thank you, sir, for the kind words. And thank you, everyone who could come at 9 a.m. for the early morning session. A brief background about me. I did my undergrad at JIPMER and then I did my MD at AIMS. I worked there for a couple of years. Then I realized that I want to do full-time AI and I moved to AI research. And currently I lead a small research group of around 50 to 60 clinicians and AI engineers called the Center for Responsible Autonomous Systems in Healthcare, which is better known as Crash Lab. And I'm also a Simons Ashoka Early Career Fellow based out of Ashoka University in India, and I'm co-advised by Dr. Nigam Shah at Stanford and Pranav Rajpurkar at Harvard. So today I just wanted to give you a little bit glimpse into the kind of research which is happening all across the world and how if India wants to really be a leader in the space, what kind of research we will have to really leapfrog into doing so that we are at par with the research labs in the US and of course China. Before I move into my core topic, how do we define medical superintelligence? So you will be hearing a lot of terms these days called AGI, superintelligence. But in medicine, when we look at superintelligence, we mean that the AI models can do certain tasks which is beyond human capability. And three most common tasks which AI is really good at doing is integrating huge amount of multimodal and multi-omic clinical data, reasoning longitudinally across time, across patients' records since their birth, vaccination histories, and all the illnesses which has happened to the patient in the last couple of years since his birth, and also predict certain outcomes, not just the disease, which often we really struggle to do. Also, these agents will almost semi-autonomously work within our clinical workflows, where you as a clinician would be the final say in signing of the reports and the drafts which your AI agents will be making. And we strongly believe as a group that medical superintelligence will not come from a single model from OpenAI or from Anthropic as Claude, but it will come from an orchestrated system of models, each of them specialized in its own task. In the last few years, a lot of buzz has happened and a lot of research has happened around foundational models. And foundational models are these base models which are trained in millions and billions of data points, and then you fine tune these models for your own task. The first phase came almost 5 years back when we understood the concept of something called as multimodal medical foundational models, and after that, through different multilinguistic capabilities and access to specialized tools, the final phase, which is coming up now, are autonomous workflows, or which many of you know as agentic workflows. In fact, a huge amount of our work, which we do as a group, as well as all across the world, is based on open source medical foundational models, which in fact is being led by Frontier Labs. In fact, MedGemini, which was released by Google, has a multimodal medical foundational model powering it, but they also have released for researchers models like MedGemma, which are actually deployable on your phone or on your laptop with no internet requirement, and they can automatically run on your system. What has been happening in the last couple of months, in fact, these are like the two really famous works in the last few months which has come out, is that X-ray AI has taken tremendous leapfrog. I'm sure many of you might be using that, and there are multiple startups and research groups who have already figured out the best way to do X-ray AI. But CT foundational models are now coming up in a really big way, and these are three papers which came up in the last few months, in which they are now not only building these models, but they are open sourcing them, which means they are putting out these model weights publicly for anyone in India or Africa or Bangladesh to use and fine tune for our tasks. This is tremendously important because the kind of diseases which we see in India are very different from what we see in these places. So CT rate actually came from Israel, Tangerine came from Spain. Um, these models are trained on diverse data sets from all across the world. But when we want to use these models, what we would do is we will take these models, we will fine tune on our data sets. We give them some CT scans of Indian patients, some reports of those CT scans, and then it automatically figures out a way how to generate those reports. And this has been happening at a very, very fast pace. Chest X-ray models had come just a few years back, and now each and every week we are seeing new AI models, and each and every year we see multiple foundational models being released by large research groups who have access to a lot of digitized data. In fact, a very milestone achievement in the space happened this year when one of the world's first CT foundational models by IDOC was cleared, which could not only do a very specific task. So, for example, to give you some perspective, usually we have even Indian companies like Cure AI and Deep Tech who have AI models which are FDA approved for doing a specific task, which can be tuberculosis detection, pneumonia detection, detection of endotracheal tube. But this was for the first time FDA went a step ahead and allowed one single foundational model to do 14 set of predictions. And this was one of the world's first, but this now has opened up the entire field for different companies, different research groups to start creating their own foundational models and apply for FDA approval. And they would not need to run behind 5 to 10 different vendors for getting the best AI models for each task, because they have one vendor who is giving them one model which can be fine-tuned for your setup. Before I get into what we are doing in India and how the regulatory field is moving, I want to talk a little bit about a few of the landmark papers in the space, which you can read, very easy to read, even and these are all written in a way that anyone who is just at entry level into medicine will be able to understand. This was the first paper in which the Rajpurkar lab proposed foundational models for generalist medical intelligence. And what do we mean by that? Now, and I showed you that these companies now have CT foundational models and X-ray foundational models, but we also envision that going down the line, just like ChatGPT today can take any kind of input and give any kind of output, that will be the case for generalist medical AI also, which means that a patient comes to you, and this might be a reality even just in 5 years. A patient might come to you with the entire signal data from their Apple Watch or their whoop ring which they are wearing, and they might have their entire digital records. They might even have their genomic sequencing done. As a doctor, it's very difficult to be able to analyze also all those kinds of data which we have never been um, shown during our medical training. But AI models are really good at that. But today, a different AI model takes a different signal and gives an output. But that is not how the field is moving now. But we are now creating models which can take in any kind of input for the patient, and based on that, it can give you an output. And this is not just heuristics also, this has been happening. This is the work from my colleagues at Google, led by Vivek's group, and everyone is now moving towards building generalist biomedical AI. In fact, this was a work which we did last year. I think almost a year has passed since we started the work, wherein we created a generalist foundational model along with the group of Eric Topol and Pranav Rajpurkar. I was at AIMS at that time, and Subhatra was there at JIPMER, and we created a generalist model in which you can give any image to them, and you can get any kind of output. I want to show you a glimpse, and this is not yet published, but it's an archive. You can always go and read the preprint, but the final publication is coming out this year, probably next month. So this is where the interface looks like, and you can essentially, just like ChatGPT, upload any image, give the context of the patient, and you would ask it any question which you want. So you saw that first we upload an X-ray, we ask some questions, but after that we give the patient's image of the skin lesion and ask it to segment where that lesion was. And we can also put in details like CT scans and ask whatever questions you want. So essentially it's like ChatGPT, but a better version which is fine-tuned for medical purposes. So sorry. Yeah. So I just wanted to show you like where the entire field is moving now, and it's not just our lab which is working on this. All the global tech giants like Microsoft, Google, all have their foundational models like this now, and everyone is trying to build generalist models which can take in any kind of data. But that also happens when the individual foundational models for each of these specific tasks are well organized. So a very interesting trajectory which has come up, and in fact this was a problem also when first these large scale AI models were coming out, was that it can analyze a patient's X-ray once you put it there, but AI was really bad at telling you whether let's say you are in the ICU, you have a patient who is on ventilator support, and whether an ARDS or a pneumonia has worsened or whether it has improved. That was something which AI models previously struggled. But now in the last couple of years, we are seeing that that is changing. We are getting longitudinal foundational models, which means that these models not only learn to look at a single time point information, but also they learn to reason beyond what is currently there. They learn to reason that if, and they are trained on data like a patient who has probably seen disease right from his birth till his death, and all this data which is already available and digitized in the Western world, these are used to feed into the training of these models, so they know that what kind of trajectory millions of patients have. So once they see that pattern in new patients, they also can tell, okay, probably this person would benefit if you give them this drug instead of that drug. And this opens up the entire field of simulation medicine, in which you actually can, and this is especially useful for trainees, because often at night older faculty might not be there, but your resident who is a JR1, he or she might be looking at a patient without a lot of experience, right? And for them it's very useful to have a AI tool which can tell ki probably if I do intervention A, it might be better for the patient more than intervention B. and then of course he or she will be reading up about it, but it can immediately help them, and then next day morning the senior doctor can come and tell, okay, this was correct or this was wrong. So this is what is happening, and a lot of very high impact papers have come out in Nature and Lancet portfolio journals regarding these models. A very interesting paper which came out very recently was, can AI predict when we can die? It seems that they can, and better than a coin toss. So a coin toss would be predicting at 50% accuracy. These models were reaching almost 70%, 80% accuracy to predict the year in which a patient might die. But again, these are all retrospective data. Till we prospectively prove this, I think it's very early to say. What's happening all across the world, but also in India, where we are actually seeing adoption in the real world, are ambient scribes. And ambient scribes are essentially voice scribes. And the reason why we feel, both from the research side as well as from the policy side, voice scribes being game changers is because, till the last few years, we had absolutely no data. The reason why China and US have been building some fantastic models is because they have huge amounts of data of their patients, and they can use that digitized data to get insights which we are losing every single day in billions of data points in India. So to change that, government is now focusing very strongly on capturing those data, and the easiest way to do that without overburdening the doctors is ambient scribes. So what we do is we go ahead, we keep a device there, or we even use the doctor's phone to record the doctor-patient conversations, and then it automatically digitizes, just like you would want to capture those in your CSV file or an Excel file. And we have been seeing a lot of real world studies now coming out, not just accuracy, but also whether these are improving the physician and doctor experience. In the US, yes, because in the US previously 30% of the time was spent by the doctor in typing things. In India, it has not even started. So we are still doing actually a couple of studies in the implementation regime with ambient scribes, and some early findings I can tell you are very controversial. What we have seen is that while ambient scribes definitely help in digitalizing more than 90% times the data which you are otherwise losing, it really does not help a lot in saving the time, because in India, we were anyway not using these records previously. And now something which is again coming up is agentic frameworks. I think many of you who are aware of the AI space, they know Claude bots and different autonomous agents now running the internet, writing blogs. But where does it lie in a medical domain? Specialized foundational models are being developed not only in radiology, which is my domain, but I also wanted to give a glimpse of what is happening in the other domains. In fact, two of the really, really well-known foundational models which came out in the last couple of years, one is ECG FM and ECG Founder, in which what the models are doing is that they're clustering different diseases in the very high dimensional space, and then using that to see another rhythm which you are feeding and predicting which among these clusters this disease might fall. And these have shown really great promising results now, and these models can actually be used by fine tuning on your data set and predicting the diseases for your patients. Why it's really interesting for India today is because all of these models are now being put in the open source, which means provided that you have enough servers or GPUs, you can actually take them, host them on your server, fine tune on your data, and you can do plethora of studies to see whether these models are actually useful in our patient population or not. And this has opened up a field of research immensely. And most of our work with our collaborators, the clinical collaborators, are in this space. Alongside knowing when we can die, it can also find out what is wrong just in your sleep. And this is a huge amount of data which was used to train one of the world's biggest foundational models on polysomnography from Stanford. So in Stanford, they had data since the last 25 years, and what they found out was that, and many of them had actually like passed away and had different diseases over the course of time. And what they found out was that there is enough statistical and clinical significance of certain rhythms which we can find out to predict cancers, complications in pregnancy, and different circulatory conditions. Cancers probably is a very like bold claim, but what we as a group are looking into is whether we can use these sleep models to look at pregnant patients to predict the complications which might happen, because we know that pregnancy has very different physiological changes, and is it possible that by tracking those changes during sleep we can predict that a mother might have a higher chance of a let's say preeclampsia or other complication which we might miss otherwise. Another area where we are moving gradually is in the opportunistic screening space and preventive wellness space. As AI continues to do a lot of our diagnostic tasks, um, what we see is that while the diagnostic workload will keep on increasing, the time to generate a report will significantly decrease because AI agents will be creating the reports for us and we will just be signing off. So the free time which we get will be used for screening a lot of these patients who come to our centers, and doing things which are not done today. Like coronary artery calcium scans are very common in Western world, but we don't have that. But what can we do for India is that we can use ultrasounds and chest X-rays, which are available at every single district or village, to predict certain diseases which otherwise might be missed, and they can be sent after triaging to the higher centers. This opens up a very big problem: that does India really have the capacity to attend to these patients who are getting increasingly triaged? And that's a different problem to ask. But what we also see is that previously, even till last year, we did not have a single model which could be used and proven for screening. Now, what OMA Found has come up with is that now simultaneously both the breast cancer and the lung cancer screening can happen from a low dose non-contrast CT, and people actually found that when OMA Found is used to assist radiologists, it helps them in picking up both lung cancer and breast cancer as well without compromising specificity. Um, it started from radiology because we had a lot of organized data, but now as the organization of the data is happening in the other fields like cardiology for ECG, or in any other field where you are getting your data recorded, these are now starting to come up. And the future of healthcare is, I mean, this is a question which I often get asked since I'm very close to the medical students in terms of age and the residents, is that is it really worth pursuing a career in medicine today? And initially, when we saw the initial papers coming out during COVID, was that AI really helps in augmenting capabilities of clinicians. There was also a case for replacement made, in which people showed that if you replace the radiologists for triaging of mammographies, or replace the first reader, so in the US, there's a trend of having two readers do mammography instead of just one radiologist, which we do. They found that if they remove just one reader and replace it with an AI agent, it actually reduces, it shows the accuracy without reducing any detection accuracy by using the AI model. And there's a lot of cases which has been made, and so to come to what's relevant for India, our data is extremely fragmented. And so first question which we wanted to ask was, does India really need to build its foundational models? We did a study, we tested the foundational models on an Indian data set and found out that the sensitivities of the best performing model, this was Lavarat from Stanford, was just 60%, which is very low. This is the console in which we tested this model, and this is our really large scale initiative where we are going across India to find 100 sites from where we can collect 1 lakh chest x-rays and build India's first medical imaging foundational model along with the help of NUS Singapore. We have done a couple of works in the previous years, and we have published a couple of landmark papers last year. We have built a lot of AI models, CT models when they were not so common. And this is our next step to build India's radiology AI foundational model, which will soon be announced by the government. But what after radiology report generation? Can we also predict stuff in our patients? And this is the second question which we asked, was can we use chest x-rays to risk stratify coronary artery disease in our patients in a low cost setup in Indian healthcare setups? We worked with JIPMER and KMC Manipal, and I'm very happy to say that just last month, in December, we got an approval from the ANRF to go ahead with the study. And alongside that, when we are trying to achieve super intelligence, we need to really know where these models currently stand. So we keep on building metrics, we keep on benchmarking frontier models to show where they stand, and we try to stay at the cutting edge of research. This is my lab, and we try to compete with at least USA and China to see whether we can really do cutting edge research at par with what they are doing. These are the four pillars. We are now building the data commons. We work with Nimhans, Tata, Ames. We are building the benchmarks alongside working with our colleagues at Google. And the final goal is to build the AI models for India. We have a lot of decent recognitions of our work. But the final thing is, will we be missed once we achieve super intelligence? Will we need doctors? The very tricky question, and probably the answer is from a macroeconomic perspective. This is a very interesting paper which came out which told that we won't be missed. The requirement for human labor will be significantly less. Um, Today we are far away from that. But what happens after 10 years when everyone, as the Andhra chief minister just 2 days back said, he wants to give an AI doctor to every citizen of Andhra Pradesh? What happens the doctors at that time? So one thing is that as we become increasingly important and dependent on compute, your value will be how much compute can you save, because compute costs will be determining how much cost a patient needs to pay. And if you are a really great clinician and expert in picking up those edge cases which AI is missing, your value will be tremendous. But the really mediocre, below average clinicians might not be relevant 10 years down the line. And people say that these are all predictions, right? But then we have often made a couple of predictions, which most of them have come true. And even surgery is not really immune. In fact, just last week, Johns Hopkins did a autonomous robotic surgery on a lifelike model, not a person yet, but it has been shown both in pigs and other animals that this can be done autonomously. And once we achieve super intelligence, your role will be to determine, as researchers, whether these models are actually performing on your patients as well as they were supposed to do. After deploying those models in your setup, whether because of the change in your patient population over time, these models' accuracies are decreasing, and what you should do to keep on the accuracy, and finally create these benchmarks. So this is our landmark paper which we published last year, in which we showed in September that today even the best models, GPT-5, was really behind radiology trainees and radiology trained board certified physicians. But in December, when we again ran the same experiment with Gemini 3.0, we found out that Gemini 3.0 now has beaten Indian radiology trainees in detection of cases. We are definitely keeping up a lot of guidances, and we are already having the ABDM ecosystem, which is the blueprint for all the AI work. And these are the policy exchanges which are having at our center and all across India in 4 different places to build the AI strategy for India, and which will be announced in the India AI Summit in Delhi. So thank you. And again, I'm happy to take questions probably later if the time is already over. And but I'm open for comments.
Thank you for elaborate display of AI for the radiologist. So in House is open for questions. Be limit 1 or 2. Yes.
See, we talk so many things, hi-fi things, AI, so many. Don't you agree with me that with all this developed technology, conventional method is the best? I'll give an example. In OG, hysterectomy and conventional method, conventional method has got more points from the patients. Likewise, surgery also. Do you agree with me? Or?
I mean, see, I'm a scientist. I have to look at evidence to say that if I can agree or not. If there's a real world study which shows that this is better than this, I have to agree.
Real world only, I'm telling. See, we talk in this kind of conference, all big things, but never works 100% perfectly as compared to the conventional one. I will give one example. You have got so many PPT, that kind of representation. But will it be equal to a person writing on the board with a chalk piece? A subject knowing person only can write on the board. A subject not knowing person can write, even Sanskrit they can do with PPT. This can you compare with the medical work?
I mean, we can have a debate on that if you want, but what I can assure you is that even today in MIT and the best places which are known for training, there is chalk and board training which happens and which helps in retention of the students. At the same time, the amount of information which you can give to the students in a PPT, sorry, yeah. The amount of information which you can give to the students in a PPT is much, much more than what you would be able to do using a traditional method. You might feel that your average student might learn better because of the slow pace at which you are understanding, but you are capping the capacity of your best student to learn and gather information if you are just looking at traditional methods. AI augments your capacity. You cannot use conventional method, at least as of now. Maybe I'm not aware of that. You cannot have one single doctor analyze signals from your Apple Watch or your EEG signals and do everything which our body is giving those signals out. Probably someone who is I mean, I don't know. There are a lot of spiritual stories, and we are in Varanasi. Probably there are people who can do that. But in medicine, at least where I have practiced, I don't know a single person who can do that. But I know AI models which can do that.
A very nice blueprint to the road to the artificial superintelligence. But as of now, the current AI is on stage 1 itself.
Yeah.
Stage 2 is still evolving. And on this current development, that is stage 1 only, there is a lot of threat and lot of speculations regarding AI replacing the doctors and all. Barring the political rhetoric of 10 years and all, whenever the artificial superintelligence will achieve the stage 3 of AI development, which is by definition far superior to the best of best humans capability. And it will be self-aware, it will be self-defensive. So after development of artificial superintelligence, as you are a radiologist, how will you save yourself from the artificial superintelligence at that point of time, which is superior than you, which can prevent you also from controlling its artificial superintelligence? So how will you shield yourself after the development of artificial superintelligence?
Yeah, so two things. First of all, when this was coming up, I saved myself by shifting from clinical practice to research. Now, what we are also seeing is that a lot of the research also is getting automated by ASI, right? And once artificial superintelligence comes, there are two views. One is a very utopian view, one is a dystopian view. The dystopian view is that few top companies like Google, OpenAI, and other people who have huge data centers and the countries where the compute is located, they control the entire system because these models are so superior that people will get dependent on using these models for anything and everything, and they will control the entire system. The utopian view is that these governments step in early. The compute is distributed across different countries. Like India is going to announce a very big compute cluster, which we are doing in India. And almost upwards of $150 billion has been committed by companies to build data centers in India. And from a macroeconomic perspective, once that happens, we shall be able to control the amount of automation that we will allow certain companies to do. If today a company is employing 10,000 people, let's say Infosys or TCS, almost 80% of the work can be done by AI agents. If not today, tomorrow, right? But when that happens, your people will get laid off, economy will collapse. Then who will be the people who will be paying for those AI agents? You need to have a market which is in equilibrium, right? So in that sense, governments will need to step in and tell that you can only do this much of automation and not full automation. And the other thing is you give universal basic income to people, which is another school of thought. These are all economic theories, I think not for this particular session, but happy to discuss after the session.
I have one question. When we are reading or we are in very traditional type of teaching, so everything's end up with the differential diagnosis, and we have certain points regarding each and individual differentials. So how to differentiate this, how to differentiate this, with this, and at last we come to a provisional diagnosis. And then we again confirm before final treatment. At the same time, in the pharmacology classes, we have taught that we should have this type of indications, this type of contraindications, this type of interactions. So these AI tools are using these things because we are reading, we have taught these things for the betterment of the patient's correct diagnosis and to avoid any complications.
Yes, of course. I mean, these AI tools are trained on these drug-drug interactions, and they also know that if you have a certain CYP, some drug might not work. So the AIs which are used for clinical decision support are actually trained on all this information. And as a human being, you might often forget what you read in pharmacology some years back, unless you see that patient regularly in your practice. A very rare patient or a rare case, right? But AI doesn't have that forgetting problem. So as a decision support tool today, if you have an AI on the like beside your EHR which you use, you can actually use it as a second check to ensure that you are not giving a drug which might not work for your patient. But the problem with India is that we don't have EHRs only. So how do we use that?
So doctors are a very suspicious mind of person. Any doctors are very suspicious mind of person. So first of all, if he or she advise anything, he want doubly sure whether we are correct or not. So if we see this type of evidence in the AI mode, so we and in book mode we doubly check with our textbooks.
Yes.
So this is available with this AI.
Yes, it is. It is currently. Yeah.
Okay, thank you. Thank you.
Thank you.
Now session is over. Quick question, quick.
I, Dr. Suvarna, I very good talk. I just want to understand your role in your institute. You are working, you are a qualified radiologist, and you are qualified radiologist, and you are working in the Koita Digital Health Center. So, what is the your role in this development of these models and like so?
Right. The reason why I shifted and left radiology practice was because we wanted to build the foundational model for India, and no one else was building that. And I felt that it's better that a clinician takes it up rather than leaving it to the engineers who often used to come to us with AI models which were very narrow and often did not work in our own setups. And what we are doing right now is to see.
No. I want to understand your role, not your entire team.
Oh, my role. Yes. So I lead the lab. I code myself. I can build models also.
Concept comes from your mind, your team.
For my team, yes. I mean, we work at KCDHA, so we have a like large physician scientist team there. So my lab works specifically in the responsible AI domain, focusing on imaging and foundational models. There are other labs who looks at ICU repository, synthetic data, and there are labs which look at EHR digitization. So we all work together as a team, and we decide which problems are to be looked at.
So you all physicians decides, or what is specifically your role?
We can discuss this individually.
I can tell you in detail. I mean, I lead the group, so.
Okay. Thank you. Thank you. Thank you.
Thank you.
Thank you so much, Dr. Sukarna. This is mesmerizing to listen from you regarding your views in AI. Now, I would like the chairpersons and the speaker to come to the selfie point for the felicitation and distribution of mementos. So we have to proceed to the selfie booth. Next, I would like to invite Dr. Lalit. He will be speaking on harnessing. I would like to invite the chairpersons as well, Dr. Bhartiya sir for the session, Dr. Sarita ma'am for the next session. We are proceeding to the session 2. The chairpersons are Bhartiya sir and the Sarita Parihar ma'am. we would like the chairpersons to introduce the speaker.
Thank you. Good morning, you all. This session is, the speaker is the Dr. Lalit Kumar. He is the assistant professor in the urology, IMS BHU. And his area of interest is minimal invasive urology in the uro-oncology. And he have the many multiple fellowship in the robotics and reviewer of the 13 index journals. And he got the talent award first in the NJDU SI Con and best paper in the UC Con in the young urologist, and 40 presentation and talk in the various conferences, and more than 60 research publications, including the 4 meta-analysis. He has the ICMR guideline prostate and bladder cancers, the area of interest. I would like to invite the Dr. Lalit for their talk.
Thank you, sir. Thank you so much. And good morning, everyone, respected chairpersons, and my all colleagues. Today, I will be talking on harnessing AI tools for a smarter future in medical education, research, and healthcare. As we all know, we are living in the world of AI. So AI can impact our research outcomes, then break through the research, can transform health outcomes. So how we can practically use these AI tools? I will not focus more on theoretical parts. So disclosures, there are no financial disclosures and no conflict of interest. I'm a urologist with my specialization, especially in laparoscopic and robotic surgeries. I usually prefer to do my clinical work as get the times I have interest in AI, especially in research part. So way back in 1955, McCarthy coined the term artificial intelligence in Dartmouth conference. And a famous quote by Eric Topol that artificial intelligence won't replace physicians, but physicians who use AI will replace who don't. So we all know what is the AI, what is the machine learning, and then subset of machine learning is the deep learning. There are various challenges nowadays. जैसे कि हम स्कूल क्लासेज में पढ़ाते हैं कि there is no fit formula for all the students. किसी को समझ में आएगा, किसी को नहीं आएगा. So how AI practically can play a role? So there is no one size fits all teaching. So AI can identify each student's learning and can give feedback according to that. So can correct that. It have no recalls over reasoning. जैसे students ने learn किया वो फिर भूल गया. अगर if we are using some AI apps, we can refine our learnings. There are limited feedback loops in current teaching patterns. So that's our education policy has also changed, and we are currently adopting AI very fast. आज ही हमारे यहाँ दिल्ली में अपने प्रधानमंत्री जी AI Summit 2026 का भी इनॉग्रेशन कर रहे हैं. So I also want to congratulate our organizers to organize a conference on AI so that we can learn from that. AI have a role in education in diagnosis to identify the specific knowledge gaps. So there are various apps I will discuss. AI can adapt also to specific needs of particular person or research. We can reinforce our learning, we can assess our limitations, and so that we can improve. There are various AI chatbots available like ChatGPT, we all are using. सर ने जो क्वेश्चन पूछा ना कन्वेंशनल सर्जरी से रिलेटेड, मैं जस्ट बोलना चाहूंगा जैसे कि कन्वेंशनल सर्जरी है, ओपन सर्जरी. सर आपसे ही मैं जस्ट बताना चाहूंगा, सर पीछे देख रहे हैं कि जैसे कन्वेंशनल सर्जरी है, बनारस में बोलते हैं अगर बच्चेदानी निकालनी है तो ऑब्वियसली दूरबीन से क्यों कराओगे, बड़े दरवाजे से निकालिए. तो ये होता है ओपन सर्जरी. बट ग्रेजुअली वी मूव टू द लेप्रोस्कोपिक सर्जरी एंड रोबोटिक सर्जरीज. मैं रोबोटिक सर्जरी के लिए फेलोशिप में गया था यूएस में. आप मानेंगे नहीं, वहां पे नोबडी इज यूजिंग लेप्रोस्कोपिक नाउअडेज. So it's time when we change from keypad mobile to smartphones, and now it's the time of AI. जितनी जल्दी हम टाइम के साथ इवॉल्व होंगे, that is the need. So coming back to the AI chatbots like ChatGPT, Perplexity is free by Airtel, Claude, Gemini. There are various AI tools. There are various notes like Enkai, Quizlet, even Notebook LM for students learning. We have also adaptive learning models like Osmosis and Embosys. Now comes to the this is main of idea about the education. अगर हम बात करते हैं ट्रेनिंग की, रेजिडेंट्स की, खासकर सर्जिकल पॉइंट ऑफ व्यू से, कोई भी पेशेंट हमारा नोन, हम चाहेंगे कि जूनियर रेजिडेंट डॉक्टर या जो भी ट्रेनी डॉक्टर है उस पर सर्जरी करे डायरेक्टली, नहीं. तो एआई का रोल उसमें भी आता है. ये वेरियस सिमुलेशन, even in our urology practice there are more than 15-20 robotic simulation are available, so that can minimize risk to the patient, that can also improve or enhance their learning, and obviously their accuracy and efficiency will increase, so that will decrease the patient's complications. These are various simulation models like body interact. I will not go much in details. We can see how we can do this simulation labs. I will give a take-home message also what we want from our institute to improve on this. There are various simulation skill training lab centers available at different institutes. We are still lacking in this. Now coming to the role of AI in literature search. So AI कैसे act करता है? AI, we need a data. Like based on the data that will recognize the hidden patterns. So जितना अच्छा डाटा होगा उतनी अच्छी आउटपुट होगी. जितना बड़ा डाटा होगा that will analyze the small effect size. Right? So it's like Gigo. If there is garbage in, garbage out. Data poor है तो results भी अच्छे नहीं होंगे. So that's why we see कि बाहर वाले कई बार AI मॉडल्स हैं, हमारी प्रॉब्लम्स अलग है, या कुछ AI मॉडल्स हैं वो जो उनकी एक्यूरेसी रिपीटेबिलिटी नहीं होती है. So that's also very important. And with the help of AI, we can do the rapid analysis of large data set within minutes or maybe in seconds. जो बात होती है ना, अभी एम्स दिल्ली में चेस्ट एक्सरे का लगा है, ऑब्वियसली एआई 200 चेस्ट एक्सरे मुझे लग रहा है 5 मिनट में एनालाइज कर लेगा, और रेडियोलॉजिस्ट होगा तो मे बी पूरा दिन लग जाए उसे. Similarly, we can accelerate the hypothesis generation, pacing up studies requiring complex analysis. These are all the small list of AI tools. We cannot use all the AI chatbot tools. Especially for literature review, few tools are available like Semantic Scholar, Elicit, Research Rabbit, Jotero. These are few tools. There are many tools we will discuss later on. We can do the AI for data extraction and evidence synthesis. I will talk about the meta-analysis, that I will show the video also, how we are with the help of the AI tools that is reducing the meta-analysis time. There are few meta-analysis software like Covidence, Ryan, Site. We are using EGSLR. So how we do the meta-analysis? We first do the title and abstract screening, that is by the Covidence. So we can see the 1592 references. So here comes the role of AI. As Dr. Survankar Datta has told, पहले ये होता है ना, जैसे वहाँ पे तो यूएस में चेस्ट एक्सरे भी रिपोर्ट करना है तो 2 रेडियोलॉजिस्ट को रिपोर्ट करना है. On the basis of same, अगर we have to do the title and abstract screening, तो at least 2 persons have to do. Why the AI is useful? Now one reviewer is reviewing 1500 article. It will take near about 7 days. That I have done. But when we are applying the AI, it is screening only in 10 minutes, right? And the accuracy is almost same as reviewer, and third person can resolve the conflict. This is the EGSLR software, Indian made software for meta-analysis. Very good software. We have generated a research project on meta-analysis for upper tract urothelial cancers. Here there are various title and abstract screening, full article screening. We have done the 2,800 articles after duplication. Initially there were 4,000 articles, more than 4,000. And when we see the duplicates and then remove the duplicates, so there were near about 2,800 duplicates. Is it possible to do it manually? We cannot think of. So after removing the duplicates, there were near about 1,400 articles. We can see those, and then we were doing the manual screening. Even we can do the data extraction with the help of AI. We can write the PICO with the help of AI. We can generate the graphs, tables, all those things can be done. Obviously, you have to doubly cross check, they should be reproducible. We are writing a paper on also on different AI tools. We will share. It's not published right now. So there are various tools for writing and publishing, various for literature search and management, and for reading and summarization. This is like word-wise AI tool for writing the research papers. Cite. This is like LitMap, Cite AI. Have you heard about the LitMap? So here we can see if we have uploaded the one good article like from Nature, NAJM, then we can see what are the related articles to those. So we can identify the good articles based on the circle size. Like if its circle is big, it means it is having maximum number of citations. So we can read those paper and analyze the research gaps. We have app also like chat PDF. So in that we can upload our downloaded research paper and we can ask all the question or queries. जैसे कि हमारे जनरल जर्नल क्लब में होता है कि व्हेन वी डू द क्रिटिकल एनालिसिस तो हम उसे अपलोड कर सकते हैं, पूछ सकते हैं कि इस ग्राफ की फॉरेस्ट प्लॉट की क्या इंटरप्रिटेशन है. I am not understanding the methodology, what should be done. But all teachers don't agree to it. हमारे एम्स में ही है यूरोलॉजी में. आई विल नॉट नेम द प्रोफेसर. ऐसे ही रेजिडेंट आया, उसने जर्नल क्लब बना के क्रिटिकल एनालिसिस एआई से करके ले गया, तो उसको 6 महीने के लिए क्लास से बाहर कर दिया. तो ऐसा नहीं है कि हमें खुद से पढ़ना भी आना चाहिए, बट वी कैन टेक द हेल्प ऑफ एआई, राइट. दिस इज अ वीडियो. देर आर वेरियस टूल्स. अभी डॉक्टर हर्षित ने भी स्मार्ट क्लास ली थी एआई वर्कशॉप पे. प्रॉब्लम ये आती है कि जब हम एआई से रिसर्च पेपर लिखते हैं, पहली बात तो उसका डाटा एक्यूरेट है या नहीं है. दूसरी प्रॉब्लम आती है कि जो वो रेफरेंसिंग दे रहे हैं वो सही है या नहीं है. अगर आपने एआई से पेपर लिखा तो पता चला जितना आपने पेपर लिखा उसे एडिट करने में उससे ज्यादा डबल टाइम लग जाएगा. तो यहीं पे मेरे पास मैंने जेनी एआई लिया है एंड आई हैव गुड एक्सपीरियंस विद जेनी एआई. वी कैन सी आई हैव टाइप like factors affecting the percutaneous nephrolithotomy bleeding, मतलब स्टोन रिमूवल की जो सर्जरी है उसके क्या फैक्टर है. आई हैव क्रिएटेड द न्यू डॉक्यूमेंट, then done the copy paste, what are the factors, then select the option standard headings and then start writing. So that will come in IMRAD form and AI will start writing for you. It has started and they have given the reference. ऐसा नहीं है कि हमारा पूरा पेपर आ गया और फिर हम चेक कर रहे हैं. तो अगर हमें चेक भी करना है तो we can check on this stage and that references are usually right. So this Jenny AI is very good. So I think everyone is getting bored. Yes or no? So what is the name of this scientist? Anyone? So as I belongs to the robotic surgery field, the first successful tele-robotic surgery, obviously robotic surgery also involves the AI, was performed on September 7, 2001 by Professor Jacques Maresco. It was done from New York to France. So way back, we are using AI. There are various softwares for meta-analysis like CMA, Revman Web. These are various forest plot. These are few publication or meta-analysis which we have done, though they are done without the help of the AI. We are doing right now 6-7 meta-analysis with the help of AI. Why AI matters today? We have exploding clinical data. I don't agree कि हमारे पास डाटा नहीं है. हमारे ही हॉस्पिटल में देख लो, हर चीज में डाटा है हमारे पास. प्रॉब्लम ये है कि हमारे पास ईएमआर नहीं है, पैक्स नहीं है, ये सारी प्रॉब्लम है. हमारे पास हेल्पर नहीं है. अगर हमें 300 पेशेंट की ओपीडी देखनी है और हम सोचें कि उसमें कंप्यूटर से भर भी दे सारी चीजें, तो इट्स नॉट पॉसिबल. सो दैट एट बेसलाइन वी हैव टू फाइंड आउट द सॉल्यूशन. So that's how the clinical burnout happens. In those scenario, AI can reduce our energy, can make our life easier, and can also improve the outcomes. So there are no lack of clinical data available nowadays. Just we have to adopt the AI technology and use those. Why AI entered medical field? They can identify the pattern recognition. Even they can identify the rare anomalies. हो सकता है हम चेस्ट एक्सरे देखते हैं ओपीडी में, हम यूजुअली ट्यूबरक्लोसिस या लंग कैंसर को ही डायग्नोसिस करेंगे, बट कुछ अनकॉमन पैथोलॉजी भी होती है जो हमारी आईज कई बार वो भूल जाती हैं, क्योंकि आवर ब्रेन आल्सो फॉरगेट्स. सो हियर आल्सो द रोल ऑफ एआई कम्स. देयर आर कंटिन्यूअस ऑपरेशंस. अच्छा, कोई भी आदमी 24 घंटे काम कर सकता है? नहीं, बट एआई और कंप्यूटर कर सकता है, चाहे वो रिपोर्टिंग हो या ट्रीटमेंट हो. Even AI is designed to support the enhanced clinical decision making. I am not saying it is replacing the doctors right now, but obviously, if we are having some doubts in our mind regarding diagnosis, and if we are taking AI opinion, obviously, we can improve our accuracy. There are various clinical trial challenges also. There are good trials, usually multicentric trials are done abroad, not in the India, because they have strict eligibility criteria, rising developmental costs, delaying patient access. In all those things, AI can help. So they can reduce the time of trials from 10 years to 2 years. They can impact efficiency of the trials, rapid patient matching, enhanced diversity and predictive outcomes. AI is used at all places, not in the medical at all places, even in the medical, in evaluation of chest x-ray, CT, evaluation of the ICU, prediction of mortality, prediction of cancer. There are various bracelets available for prediction of heart events, helmets available for prediction of epilepsy and seizures. And gradually they will come in practice down the line 5 to 10 years after. Radiologists are the most, radiology is the first department which is where the AI is used most, because there is a second reader support, higher sensitivity and reduced variability with the use of AI. This is a recent paper published in Scientific Report with the use of AI in reading chest X-ray. Findings are very interesting. The AI system accurately detected chest X-ray abnormalities with AUC of 0.97. One more important finding was when the physicians, I am not opposing the radiologist here, if अगर जनरल मेडिसिन का डॉक्टर भी है, उसने एआई का यूज किया चेस्ट एक्सरे से सिंपल लैंग्वेज में, तो उसकी एक्यूरेसी, डायग्नोस्टिक एक्यूरेसी वाज सेम एज रेडियोलॉजिस्ट. तो मे भी हो सकता है जनरल फिजिशियन ही नोज मोर अबाउट द पेशेंट्स. So I don't know what is the future of radiology here. AIMS recently starting deploying AI tools for evaluating chest X-ray imaging, though they write at the end correlate clinically, because AI can also have some errors. हो सकता है कि कोई चेस्ट एक्सरे रिपोर्ट जो नॉर्मल ना हो वो AI नॉर्मल दे दे. So AI will replace 80% of the doctors by 2040. That is the prediction. And I think obviously AI will reduce the job opportunities for the doctors. And maybe it is useful in the terms of government policy. जो भी डॉक्टर्स गांव में नहीं जाना चाहते हैं, हो सकता है कि जो स्मार्ट डॉक्टर्स नहीं होंगे, जो जो AI यूज नहीं कर रहे हैं, they need to move them. So we don't have to fight with the AI. We have to live with the AI as a friend, as a assistant. So AI should not be pilot. We have to make AI as a co-pilot. Coming to my field, AI in urology diagnostic, AI improve risk stratification of various malignancies and various other diseases also, especially for prostate cancers. We can fill clinical details, PSA and other MRI features, and that can predict how the survival of the patients will be. So now question to who owned the ChatGPT and when was that company formed? So ChatGPT खुद में एक कंपनी नहीं है. ChatGPT just like a tool. ChatGPT is owned by OpenAI. And ये अभी से नहीं है. It is from 2015 and there were 11 co-founders. Clinical decision support, AI help in early prediction as discuss risk stratification and escalation. This is a robotic surgery videos just to give an idea to the audience how robotic surgery acts. Robotic surgery means it's not robot who is doing the surgery. It's the man who is taking the help of the robot in doing the surgery. तो ये सबसे पहले क्लियर होना चाहिए. रोबोट ऐसे नहीं है कि आए और पेशेंट पे सर्जरी स्टार्ट कर दी. So with the help of these AI tools, we can predict even cancer research, precision medicines. और बात करते हैं robotic surgery में, तो now there is a tele robotic surgeries also. 5,000 kilometers with high data speed we can do the robotic surgery. There are various simulators available for research training. अभी हमारे यहाँ लगा भी था. अभी इंडिया में नियर अबाउट मोर देन 300 रोबोट्स हैं. बात कन्वेंशनल सर्जरी की हो रही थी, तो 5 साल से पहले हमारे पास 50 रोबोट्स भी नहीं थे. मोर देन 300 रोबोट्स, और उसमें से दा विंसी जो बेस्ट रोबोट है, दे आर मोर देन 200. And I think more than 50 to 100 tele surgeries has also been done. There are various urologists which are doing telesurgery. Future advancement, there is a real-time clinical decision support needing to reduce our OPD workload, our OT workload, and especially to help management of the emergency settings. There are digital twins virtual patient models available from individual clinical imaging and laboratory data, allowing clinicians to compare treatment options. अभी चाइना में एक हॉस्पिटल बना है, वो पूरा एआई बेस्ड है. वहाँ पे कोई डॉक्टर नहीं है, वहाँ पे सारे रोबोट्स हैं. वहाँ पे डायग्नोसिस, पेशेंट की डिटेल, ट्रीटमेंट, सब कुछ रोबोटिक से होगा. वो अभी ट्रायल पे है. इट्स नॉट यूजिंग ऑन द पेशेंट्स. There are learning systems also, healthcare systems that continuously learn from real patient outcomes, refining guidelines, alerts, and workflow from time to time, improving safety, efficacy, and quality. I'm not saying AI is 100% accurate. Human are also not 100% accurate, but when human will use AI, that will increase the accuracy of both. It will help in preparing clinicians for AI literacy. There is an issue of governance and guidelines. There are no clear-cut regulatory guidelines at a now, though there is a DPDP Act, Data Privacy, Data Protection Act is there. But we have not clear-cut guidelines whether AI can be used independently and which settings, in ICU setting, OPD settings, that is lacking, because the reproducibility and validation of AI tools, especially in Indian setup, is lacking. We are growing fast, so there are various limitations available, but with those also we have to move on. There is also one question of transparency. जो AI मॉडल्स हैं, जैसे हमने कुछ भी जेमिनाई पे टाइप किया, किसी पे भी चैट जीपीटी पे, उसने कुछ रिजल्ट दिया, है ना, बट ये हमें नहीं पता कि वो रिजल्ट कैसे आया है. हाउ इज द प्रोसेसिंग, व्हाट इज द मैकेनिज्म बिहाइंड. और अभी मानेंगे, मैं एक पेपर लिख रहा था एडिटोरियल, उसमें पेपर लिखा 200 वर्ड्स का, 10 के 10 रेफरेंस कर, उसमें लिखा प्रोस्टेट कैंसर का सर्वाइवल 50% है, और वो कहीं स्टेटमेंट ही नहीं थी, ना वो साइटेशन था, ना वो जर्नल था. तो कई बार एआई कैसे काम कर रहा है वो हमें नहीं पता होता है. देयर आर वेरियस चैलेंजेस टू एनकाउंटर दोज. वी हैव गुड पेशेंट डाटा, देन एआई मॉडल synchronizing with data. There should be regulations also to routine clinical use. So key takeaways: current transformation, value and efficiency, and human eye synergy is required. This is the famous quote by Satya Nadella that AI is perhaps the most transformational technology of our time and healthcare. It is the perhaps AI's most pressing application. So healthcare is a big boom for AI. This is just, I have given few days back to our authorities what AI tools we should purchase. So these are few AI tools that we can especially purchase from institution level. I will request to authorities. We should also have a AI task force. बात सिर्फ थ्योरी की नहीं होनी चाहिए. हमारा कोई एक एआई टास्क फोर्स बने, चाहे हमारा क्लिनिकल है, ओपीडी है, आउटपुट है, हमारे खुद के एल्गोरिदम जनरेट हो, जिसके बेसिस पे हम वर्कलोड कम कर सकें. एंड वी हैव टू आल्सो अडॉप्ट एआई प्रैक्टिसेस, लाइक वी शुड हैव आवर सिमुलेशन लैब फॉर ट्रेनिंग ऑफ द रेजिडेंट्स. So my take home is work as a team, collaborate using the guided help of AI. We can use few AI tools what I am using, like Perplexity, ChatGPT, Jenny AI, Paperpal, BioRender, Grammarly, Revman, EGSLR. At last, we have to disclose the use of AI after writing the research papers. हमें लिखना है कि हमने कौन से AI tools यूज किए हैं. इवन ग्रामरली हमें डिस्क्लोज करना है. कोई बायोरेंडर से इमेज जनरेट की है तो कब जनरेट की है, कौन सी डेट को की है. So these, I have few thoughts in mind to write a review paper like barriers and challenges in writing high quality research paper and updated narrative review, and then meta-analysis or comparing methenamine, hippurate, and low-dose antibiotic prophylaxis in recurrent UTI. So I invite my friends who want to collaborate on those. So with the quote of Tim Cook, I want to end my talk that what all of us have to do is to make sure we are using AI in a way that is for the benefit of humanity, not to the detriment of the humanity. Thank you so much.
Thank you, Lalit, for very nice talk. In one slide, you can quote the AI can replace the more than 80% of the doctor,
Yes.
physicians especially. Can it is true? House is open for.
Sir, that is a humorous slide. That is not a genuine data. I will claim.
Till yesterday, everyone
Yes.
told it will not replace, it will only aid. But that slide, please don't show anywhere. AI cannot replace doctors.
Yes, I think so.
Yes.
Not that.
Agree. Maybe AI will take out some job opportunities from the doctors. That may happen in futures. Like it has happened in various companies like Google has sacked our 15,000 employees. So ऐसा नहीं है कि ये नहीं हो सकता है, मे बी हो भी सकता है अगर हम टाइम के साथ नहीं चले तो.
AI can assist. AI can be
Yes.
our co-pilot. Yesterday talk, which is a very loud message is from this house. AI can act as a co-pilot, not a autopilot. It never replace the doctors.
This is a very interesting piece of discussion which is going on whether AI can replace doctors or not. I just want to add here, it is not that it is black and white. Everything is black and white. AI can or but what he 80% of the doctors, can you say all doctors are very efficient, very good, and they are doing so? Whatever doctors, as
Yes.
Dr. Datta mentioned, that whatever doctors who are not adopting AI, who are not adopting latest technology, who are not using this technology as their companion, may have a chance of getting replacement.
Sir has clarified my opinion. Myself, Dr. Lalita Agarwal, not Dr. Datta.
You said कि it's not only replacing.
Right.
अभी आपने बोला there are shortages of doctor also.
Yes.
I mean, quicks are practicing,
हाँ,
and that too
obviously.
in rural areas, as you know, I mean, government setup तो वहाँ पे भी है. तो I hope, sir, it's not replacing definitely. It's like 80% जो यहाँ पे doctors नहीं है, it will act as a pilot where quicks are practicing there.
मेरा just
Especially-
message ये है कि we should learn AI and we should use AI. I'm
Yes,
not
yes.
saying it will
Sir,
replace
like
the
in
doctor.
foreign countries,
Obviously, I don't want that. I'm also a doctor.
नहीं sir, in foreign countries, after every 10 years, irrespective of which specialty you claim, you have to give the examination again to renew your license. But in India, is no such criteria, as he has no key regulatory.
India
But
also have
without
the regulatory
examination,
criteria.
without exam- हाँ,
Yes.
it's not there, but it's not like that. मेरा बस लास्ट क्वेश्चन है बस, लाइक हम लोग 2 दिन से डिस्कस कर रहे हैं, रेफरेंसेस कैसे क्रॉस चेक करना है, दैट आपने पूरा बताया.
मैंने उसी के लिए बताया ना, देयर आर वेरियस एआई टूल्स फॉर राइटिंग लिटरेचर रिव्यू. मैंने भी काफी यूज किए, बट मुझे लगा जेनी एआई इज अ गुड एआई टूल, जिसमें अभी मैंने वीडियो, इसलिए कल ही मैंने वो डाउनलोड की वीडियो, खुद से ही चेक करके लॉगिन करके. अगर हम जेनी एआई यूज करते हैं तो वो इंट्रोडक्शन का जैसे 3 लाइनें लिखी हैं, उसके बाद वो तुरंत रेफरेंस देगा, तो हम वी कैन क्रॉस वेरीफाई दैट. अगर हमारे पास पूरा एक पेपर लिख दिया, उसके बाद 25-30 रेफरेंस देख दिए, पता चला हमने उसे एडिट कर लिया, फिर चेक कर रहे हैं कि रेफरेंसेस सारे गलत है, डाटा सारा सही नहीं है, तो दैट means increases our efforts. So Jenny AI is a good tool that, in my experience only, I have no financial conflict there.
I must add something to
Yes, ma'am.
this reference style, because there are many style of many. There are style,
Yes.
Vancouver style, Chicago style, and you can get reference style from there. And one more thing, NCBI is a great data, big database. You can go to that also, and there is a continuous updation of requirement of manuscript submission in biomedical journals. You can, I think, refer to that
Yes,
also.
just I want to clarify further जैसे कि एआई टूल्स में है ना, ये रेफरेंस स्टाइल, हमें जस्ट क्लिक करना है, पूरे सारे रेफरेंसेस उसके अकॉर्डिंगली अरेंज हो जाएंगे। बात आती है सबमिशन चेकलिस्ट की, पेपर पाल वी कैन यूज। हमने अपना पेपर डाला उसमें उसमें दे विल गिव ऑल द सबमिशन चेकलिस्ट कि आप ये भूल गए हैं, ये डिस्क्लोज नहीं किया है, आपने कीवर्ड्स नहीं लिखे हैं। तो देर आर टूल्स अवेलेबल सबमिशन चेकलिस्ट के लिए, रेफरेंसेज के लिए। जस्ट वी हैव टू अडॉप्ट दैट।
Even for the plagiarism also.
हाँ, प्लेगरिज्म ऑथेंटिकेट वी आर यूजिंग फ्रॉम आवर यूनिवर्सिटी।
मैडम जस्ट एक इंफॉर्मेशन ऐड करनी है। अमेरिकन एसोसिएशन ऑफ मेडिकल जो आपकी है बॉडी, उसने प्रपोज करा है वी शुड नॉट यूज द टर्म एआई एज आर्टिफिशियल इंटेलिजेंस, वी शुड यूज द टर्म ऑगमेंटेड इंटेलिजेंस।
यस यस,
दैट कैप्चर्स द एसेंस व्हाई वी शुड बी यूजिंग एआई। एक और मैडम डिबेट बहुत चलती है, मैं आई एम फ्रॉम आईसीएमआर, इंडियन काउंसिल ऑफ मेडिकल रिसर्च, whether we should use chat GPT for literature search or not। बहुत डिबेट चलती है ये। आप में से जो लोग बहुत पुराने हैं, जिन्होंने, जैसे मैं बहुत पहले रिसर्च करते थे, पीएचडी करी, तो हम लाइब्रेरी जाते थे, 5-10 जर्नल सर्च करते थे जो हमें पता है, उनके एब्स्ट्रैक्ट पढ़ते थे, बैक में उनका टेबल ऑफ कंटेंट पढ़ते थे, फिर वो लिख के लेके आते थे, फिर उसका फोटोकॉपी करते थे और फिर उसको पढ़ते थे। जब पबमेड आया उसने ये सारी चीज को बिल्कुल ट्रांसफॉर्म कर दिया। पबमेड में हम रादर देन रेस्ट्रिक्टिंग टू 10 जर्नल्स, हम थाउजेंड्स ऑफ जर्नल्स को सर्च कर लेते हैं। पर सिचुएशन अभी भी वही रही कि हम वो 1000 जर्नल से जो एब्स्ट्रैक्ट आए उनको पढ़ते हैं, अंडरस्टैंड करते हैं, प्लस माइनस देखते हैं। विद दिस चैट जीपीटी और पबमेड को हमने एक्सेप्ट करा एज अ स्टैंडर्ड वे। चैट जीपीटी जो अभी आ रहा है ये उसके फर्दर बियॉन्ड जा रहा है। वो पेपर को पढ़ता है, पेपर की समरी बनाता है, उसका मेन की पॉइंट्स निकालता है और आपको प्रेजेंट करता है। सो आई थिंक इट इज अ ट्रांसफॉर्मेटिव फेज दैट वी आर गोइंग थ्रू। चैट जीपीटी में अपने फ्लॉज हैं, बहुत सारे फॉल्ट्स हैं, बहुत सारी हेल्यूसिनेशंस हैं, बट इट इज इम्प्रूविंग। स्ट्रेट अवे रिजेक्ट करना विल नॉट बी feasible। So we should take this as a technology and use the technology as technology, कोई भी हो, न्यूक्लियर रिएक्टर हो, both plus and minus है। We should take AI or generative AI as a technology, not as something as a gold standard. This is what my submission is, sir.
Yes, thank you.
Chat GPT 5.1 is good. I will just say to the student directly पूरा पेपर मत लिखो AI से, just have your idea of title, rephrase that, write your pico on your own words. You can get the subheadings, in what subheadings we have to write the papers, and then write yourself.
I think time is running behind. We very quick.
गुड मॉर्निंग एवरीवन। यूपी की अगर बात करें तो 48 के अराउंड मेडिकल कॉलेजेस खुल गए हैं। एमबीबीएस की तो बात छोड़ देते हैं, पढ़ाई का स्तर क्या है हम सबको पता है।
That's why AI is very important.
नहीं सर, लेकिन क्या इससे ये होगा कि डॉक्टरों की जो क्वालिटी है वो कम नहीं होगी?
Quality कोई focus नहीं कर रहा है. This is a clear cut. That is a matter of debate also.
नहीं, क्वालिटी की हम बात कर रहे हैं, मतलब हम ऐसा तो नहीं है ना कि अपने सिस्टम में या अपने स्टेट में या अपने देश में गधों को पैदा करने के लिए।
नहीं, वो मुझे लग रहा है अलग टॉपिक है।
I think this topiक is not pertaining for that.
अभी गूगल
We are moving from the conventional to the evidence based. Then now we are AI based. ठीक है, we are moving by the technology, but not like that. That is the policy problems.
इसमें भी स्टूडेंट के लिए काफी एप्स हैं, मेडपाम 2 है, गूगल की, या फिर नोटबुक एलएम है, जिसमें स्टूडेंट आपस में डिस्कस कर सकते हैं और वो लर्न कर सकते हैं।
Thank you, Lalit.
Thank you, Dr. Hello. Thank you, Dr. Lalit, for a very informative talk. Now I will take the privilege to introduce our next speaker, Dr. Arpit Gupta. He is additional professor, Oral Health Science Center, PGIMR, Chandigarh. His area of interest is screening and early detection, preventive dentistry and risk assessment, global tobacco control, school and geriatric oral health programs. His achievements: he is a head National Resource Center for Oral Health Care of Children and Elderly under the National Oral Health Program. He is a member of National Steering Group on Oral Health, Ministry of Health and Family Welfare and Government of India. He is a fellow of International College of Dentists, Section 6, and he is also fellow of International Association for Dental Research IADR India divisions. So I welcome you, sir, on the dais.
Many thanks to the chair and a very good morning. At the outset, I would like to thank the family BHU for having given me this opportunity to stand before you today. Special mention of Dr. Naveen for allowing me here. So through the next 20-25 minutes, we would be dealing one of the most deadly and a very prevalent diseases in India, which we know as oral cancer. And we would be talking about certain challenges which we as a country whole is facing as far as oral cancer is concerned. And we will be talking about some diagnostic options which are available, what we are using, how we are using, and how AI can assist. We'll be also reviewing certain tools which are available globally as far as AI is concerned. And then we would be very shortly covering up what we are trying to do in India and how we are trying to augment the public healthcare delivery system based on AI. Oral cancer, as we all know, India is the capital, and globally we have more than 4 lakh cases every year. And the 5-year survival is, it depends at what stage are we really diagnosing. So if we see if the cancer is being diagnosed at an early stage of, let's say, stage 1 or 2, the 5-year survival may rate up to, let's say, 80%. But in our country, most of the cases being reported at the stage 3 or 4, so the 5-year survival is even lesser than 40%. So all it indicates is that early detection, early identification can lead to better outcomes. But once oral cancer has set in, some amount of morbidity is inevitable. So that's going to happen because cancer has set in. So may it be 5-year survival, if we look at 10-year survival, it will further come down. But a very beautiful thing about oral cancer is that it is generally preceded by certain changes into the oral cavity, which are easily identifiable, which we know as oral potentially malignant disorders. So that's a very beautiful thing about oral cavity. India, we have more than almost like 1.5 lakh cases every year, which is accounting to almost 40% of the global burden of oral cancer. So 40% of oral cancer patients are from India. And almost 80,000 deaths, so 42% of the deaths globally are occurring in India because of oral cancer. Men, it's almost like 12% or 11.28% of the most prevalent cancers. Women, it is relatively less. And yes, the 5-year survival in India is somewhere around 60%. Now, if we look at further some more burden data from India, which we know as the economic burden of oral diseases. So the economic burden of oral cancer in India pertains to somewhere around 2,500 crores per year. So that's an estimate. A recent study from TMC has suggested that. And this estimate of 2,500 crore per year is expected to rise by 10x, tenfold. So that is 25,000 crore per year by 2035. So in a decade's time, we are going to 10x, 10 times multiply the amount which the country is losing because of oral cancer. Now, what does this lead? It is catastrophic expenditure. We understand that. We see indirect cost is much higher, right? And how do we deal with it? As a public health professional, how do we deal with it on a national basis, on a national platform? So the only key is early detection. So if we detect it early, so even before that, the first key is prevention, right? We attribute most of these oral cancer cases to tobacco. So the first point is prevention. But I am not exactly delving into prevention. Yesterday, Dr. Vikrant gave a very broad understanding about how we can prevent tobacco use and how we can promote tobacco cessation. So my step is what to do next. Okay, there are users. We know that. Now what to do next? We have a healthcare delivery system existing. We have NP-NCD program in place, which is detecting oral cancers, breast cancers, and cervical cancers. But again, there are challenges involved. The workforce is in place. We have ASHA in place. We have ANMs in place. We have multi-purpose health workers in place. Now we have CHOs, the community health officers at Ayushman Arogya Mandir in place. everybody has been assigned some task of doing some sort of visual screening for tobacco, for oral cancer. But we just have to look into, are our teams geared enough? Or have we built sufficient capacity of these grassroots level workers in early detecting oral pre-malignant or potentially malignant disorder? So that's the question in mind with which many of the initiatives have been done, and we have also initiated certain work in our country, which I'll be talking about. So the challenges of screening and early detection: we have low community awareness, very well, we know that. Frontline capacity gaps, which I have just spoken about. Asha is a community member, may or may not be even graduate. I mean, she's not entitled to be a graduate. She is just like a very normal community member. Our multi-purpose workers, CHOs are generally trained nurses or Ayush professionals who have been upgraded to this level. So there is a gap as far as their capacity is concerned. Then referral mechanism. Do we have a robust referral mechanism? If a case is being detected at a household level by an ASHA or by a community health officer, do we have some system or some registry available? For cancer, yes, some registries are there. For oral potentially malignant disorders, we don't have any registry which is existing. So any patient with a potentially malignant disorder is generally lost. Even patients, reporting with very much reduced mouth opening, they are lost. And they report back to tertiary care facilities, may it be at BHU or at AIMS or at PGI, maybe when they turn out into stage 3 or stage 4 cases. So we lose a lot of time. A lot of time is lost only because of the reason that there is low awareness, there is poor capacity building of our frontline healthcare workers, and there is a poor referral mechanism which is in place. So now what to do? So we need to strengthen the screening pathway, which includes community mobilization. We need very dedicated screening process to be in place, prompt referral system in place, and then once the patient is referred to a medical officer, we just leave it to the medical officer to follow the patient for other diagnostic aids. So this is what we know about oral cancer. Visual screening, a sensitivity of almost like 68%, which is a low cost, but it is widely available. Adjunct technologies like brush cytology, chemiluminescence, it has variable sensitivity, and biopsy, which is a gold standard. But this biopsy is generally available at maybe like a tertiary care facility only. So we have to exactly rely on visual examination, but we need to look into how best we can augment or how best we can use artificial intelligence to augment the ability of our healthcare professionals and our healthcare workers in better or improving the sensitivity of visual examination. So that's the whole idea what we have been working for some time. This is what WHO looks us like. So WHO has set a target of 33% relative reduction in premature mortality from oral cancer by 2030. So 5 years from now, if we really need to reduce premature mortality by 1/3, it means a lot. That's a big target. And they have laid down certain areas, and which includes screening of risk population, timely diagnostic workup, early referral, and comprehensive treatment. So that's the way how WHO is suggesting us to move ahead with. Okay, this is one of the studies which says that early detection and follow-up can improve the 5-year survival, and the study very well say it can be improved maybe up to 90%. So if we detect early, if we follow up the patients well, so the 5-year survival can be highest to be around 90%. So these are certain studies which talk about this. If we talk about our healthcare system, the first referral units, they are actually overburdened. Not just oral cancers, they have to look up to NCDs, which are like, they have to look up to vector-borne diseases and many more. There are many more diseases, right? It's already overburdened. So we have to look into how AI can reduce the burden of screening at the secondary or the tertiary level by activating disease screening at primary and secondary level. So there has to be a shifting of tasks, that the screening part be done by the primary level or maybe at the community level by the ASHA itself. so that the healthcare system at the secondary, tertiary level is not overburdened with these kind of things. So AI-powered solutions to help medical practitioners efficiently screening oral cancer is the need for the hour. So if you look at oral potentially malignant disorders, the oral lesions, which I just talked about, so oral cancers are almost every time preceded by certain changes into the oral cavity, which we know as oral potentially malignant disorders, largely being classified as some benign lesions and some malignant transformations. So we just want our AI to detect these, to classify this, to do some basic grading, whether it's a benign, it looks like a benign lesion, or a normal variant, let's say, right, which will go away, or whether it is a normal variant or whether it is a potentially malignant. So we have some deep learning models available in AI. I'm not an expert into AI, so I'm not going into those details. But all I'm trying to say is that there are some neural network models which have been built and which have shown an accuracy of almost like 85% in detecting, or let's say in categorizing these lesions. So this is one of systematic reviews and meta-analysis on diagnostic performance of AI in detecting oral potentially malignant disorders and oral cancers using medical diagnostic imaging. And if you can see, there are certain studies, and a couple of them are from India as well. So they have used various type of images. So many of them have used histopathological images, and there are certain studies which have used photographic images as well, and based on which they have tried to build up a model. But if you look at the image set, the total number of images, so the maximum I could see is almost like 1200. So that's the maximum which I could see right now. And here we have certain images, certain models which have been built on maybe 5,000 images or so. So that's the maximum data set which the globally, people are working on and trying to build a model on. But if we look at the burden in our country and the availability of patients in our country, we can build a model on huge data sets. But it is rather challenging as well because we are a very heterogeneous population, right? So an oral cavity, how it looks like at Chandigarh may look like the same how it's at Varanasi, right? So there are regional variations, there are what I call as racial variations, genetic variations. So there are so many issues, so many concerns, so much of variability which is involved. So those who are experts into AI, so there are certain classification networks available with the name of DenseNet, ResNet, SqueezeNet, Swin. So there are various models, or let's say classification networks which are available, various algorithms which are available. And there had been some studies, so there had been some studies making some comparisons on these algorithms, and they have found that DesNet works well for oral cancer, ResNet works well for OPMDs, but all these things, there are permutations and combinations. It depends on your data set, and based on that data set, when you validate your data set, you might come across and you might decide which one of these methods suits better to your data set. Okay, so a normal workflow of AI solution for OPMD, oral potentially malignant disorder detection, would be a preliminary analysis where the user, a healthcare worker or a practitioner, fills a patient history questionnaire, basic few questions, maybe 5-7 questions, basic history about the patient. A trained healthcare worker takes the pictures of the oral cavity using a smartphone camera. An AI model is processed with these images to provide a risk-based classification. And then, since the AI model process, the patient is classified based on the risk, low risk, high risk, medium risk, or whatsoever. Accordingly, referral is made, and after the referral, continuous monitoring and the treatment is being taken care of. So that's a broad structure or the workflow. This is in line with the workflow which has been advised by the NHSRC Common Framework for Management of Common Cancers. So both these workflow work in synchronization. So developing AI solution, there are certain design principles. So we all know we have been talking about the scientific approach, scalability, continuum of care, human in loop. So we had been trying to take care of all these core design principles as well. So there are many initiatives which have been taken in our country, some of them by AIMS New Delhi. ICMR has been partnered to some of the initiatives, specifically the MIDAS project, and IISc Bangalore is also initiating one of these initiatives. But most of these initiatives have done the pilot work. They are into the testing phase or the validation phase at this point in time. But we don't have any ready to deploy model as far as oral potentially malignant disorder is concerned. The challenge which we have largely seen is most of these models have been prepared on clinical data. And when we gather data from the field or we ask a health worker to click an image, let's say, so there is a lot of noise which comes into the system. So these models might sound good, look good in a hospital setup, but do we really need AI? We have a specialist sitting there who can easily take a biopsy and send it for lab analysis. So we probably don't need an AI, or maybe we are far-fetched from that. I prefer using this AI in empowerment of my healthcare workers who cannot really understand how does the oral cavity look like or how does a lesion look like. So some of these models which are available, if we try testing them in hospital scenario, they are still better. But in a field scenario, there are questions, there are concerns. So deployability of an AI model is really important. So the message I would like to throw across is whenever you generate an AI model, please keep the end user in mind. A model which works well in your clinic may not work well in the field. A model which works well in the field may not work well in the clinic, right? So those things have to be kept into the mind. And with this idea at PGI, PGI being a National Center of Excellence on AI in healthcare, we have initiated this work a few years back on development of an artificial intelligence-based predictive model and assessment of its diagnostic accuracy for oral cancer risk assessment. So if I talk about this model very quickly, so we started with almost 1600 clinical images, 1600 images of intraoral images. And those images, we have annotated those images. And after annotating those images, we have identified our workflow, we have identified the risk-based stratification, and then we have come out with an algorithm. And based on that algorithm, we plan to do a large-scale training and validation. But the problem was same. These 1600 images were largely images from the hospital setup. So that was the challenge which we thought. And then adapting this model to the country as a whole was another challenge, because again, I just told you that there is a huge variability as far as our population is concerned. So this was the initial work which we have done. We have used this standard process of using data collection, model training, then testing and benchmarking, then computing and oncological accuracy standards fitting, then filtering, training, and determining the model accuracy. So that's the broad flow of our model. And the large idea was that once an image comes into the system, we grade it. So image comes with the noise. It could be a blurred image. It could be an image of a textbook, of a pencil, of a paper, of sun, moon, birds, anything. So we find whether the image is relevant to us or not. So we determine image into gradable and non-gradable image. So if it is a gradable image, then we wanted the model to classify whether it's a safe zone, the individual is into the safe zone, a watch out zone. So watch out zone means if individual has a lesion which is less than 2 weeks. So any ulcer less than 2 weeks might heal. It has chances of healing. So that's kind of a watch out zone, whereby the health worker is entitled to only follow up. That's it. Wait and watch. Give health education, wait and watch, follow it up again. And then if it is a risk zone, whether it's a low risk zone or a high risk zone. So to my health worker, I don't want to tell them, I don't want our model to be that specific to identify the lesion. So if you know it, there are various kind of lesions. There could be lichen planus, there could be leukoplakia, erythroplakia, varicular. There are so many variations as well. So I don't want my model to exactly pinpoint and diagnose which lesion it is. No. At a healthcare worker, it's just a triaging concept. So whether the patient is in a safe zone, watch out zone, or into a risk zone. So based on these zones, we wish to build up this this model and augment the map, and we need to follow up the patient, seeing okay, the lesion size was, let's say, 5 mm 15 days back. Now it has turned out to 8 mm 6 mm. So whether the lesion is progressing, lesion is regressing, whether the color was different, it is changing in color. So that kind of follow up is what is being also supported by the model. And this is the present status of the model. Starting from those 1600 images, we are right now on 60,000 images, in which I would say more than 50,000 images have been collected from the field area. So that's the present status of our model. We are working on 60,000 images, which include images of OPMDs, oral cancers, and non-pathological oral conditions. And we have also gathered the metadata. So only image is not sufficient. You need to get some data. You remember, हम हमेशा कहते हैं ना, you need to have the history of the patient as well. So the metadata, so we are collecting this metadata as well, and this is how we need to build into a better model, augmented image augmented by this metadata. And per patient, we are collecting 3 questions on sociodomography, 10 clinical metadata questions, 19 standard intraoral photographs, and then we are annotating these images, and we are the validation process is currently in progress. But again, this is probably half the work done, because most of this data collected is from a particular area of the country, particular geographic area of the country. We need to spread our arms, and we need to include, we need to gather more heterogeneous data across the country. So that's our next step. So there is a requirement of heterogeneous multi-center data sets, and this is how we will improve our sensitivity, specificity, the predictive accuracy, and the external validity. And we are working on clinically deployable, or let's say field-based deployable and scalable AI solution. So we are right now in a phase of planning an expression of interest from people working across the country on similar initiatives, and we know many of us are working on them, so that we join hands in sharing our data sets and the metadata which is available. So that, because this solution is probably going to be, this is an initiative under the e-health department of the Ministry of Health. So we look up to this solution which can be deployed at the grassroots level. So at this stage, we wish to invite multicentric participation from regionally diverse areas across the country to improve the robustness, generalizability, and external validity. And we are looking up to some partners, maybe the Ministry of Health or ANRF or ICMR for that matter, for some support as well. So the way forward is, this is an initiative we are trying to build something for, let's say, inching towards nation building, I would put it that ways. But scaling to the national level is what is required. We are inviting technical participation, data sharing, and collaboration from all across, and it is going to be a big academic and a research partnership. And the objective is to expand our data set, strengthen the model validation, and establish a deployable AI solution for early detection of potentially malignant disorders. So I think that's it, which I have to say. Just to end my talk, early detection is not just diagnosis, it is an opportunity to save lives. Thank you.
Thank you, Dr. Arpit, for a wonderful presentation. And do you have any multi-centers, any other centers included in your study?
So right now we are working with Ranchi. We have a center based in Ranchi. And
BHU?
Not yet, not yet. So I think we are open to invite collaborations, and because at times collaborations are really tricky. They are like easy to talk about and very difficult to get into. But yes, we are open to that.
Okay, thank you. Any questions from the audience?
Sir, I would like to congratulate that you have very pinpoint the gap, and you have well designed your study, and you have identified the problem and you have doing in the perfect way. You have included a very large data, so 60,000 images, and I think it will be more than 1 lakh. So basically, in AI, there is one more issue, that computational load and computational time. How we are addressing it?
I think you have raised a very pertinent point, but we haven't delved that far. I mean, we are not into that phase of quality improvement that we reduce our computation time as well. Right now, our first focus is coming down with a model which is acceptably accurate for field deployment. So that's our part one. And maybe part two, we need to sit with our partners. So we are working with Vadhvani AI as far as this solution is concerned. So they are our technical partners providing support. So I think those technical people would better give us certain solutions on reducing our computational time, but we haven't really ventured it out as of this stage.
I am from the Rajkot, Gujarat, and Rajkot is one of the center. You must be knowing that it is common known for the oral malignancy.
Yes.
Tobacco chewing is very common there. Yes. So we like to collaborate with you.
Oh, that's wonderful. We would require more Rajkots and more BHUs and more institutions, because everybody is sitting on some data set. Everybody is sitting on some data set. So for academic purposes and for nation building purposes, can we pull on this data set and we can do it really quickly? I mean, we have been doing it for past 3 years, believe it or not. But if we get data sets which are easily available with all our partners, we'll bring more and more people on board, like-minded people on board, and I think we can do wonders. Thank you.
Can you hear me, sir?
Yeah.
So how does the AI model is affected by socio-economic demographic data? Does the socio-economic data is AI model is categorized into safe zone or watch out zone or high risk zone? The AI model is categorizing that data or not?
No, so AI model is not categorizing that data. We are recording that as metadata. Socio-demography is one thing which we are recording. More than socio-demography, there are other things, some clinical signs and symptoms, some practices, let's say tobacco usage. There are other questions as well. So socio-demography is just like one basic thing which we are entering into the model, but right now we are not using it for making any kind of categorization. So we are including this data so that tomorrow, maybe not today, tomorrow we may make some better predictions based on certain data which is available.
I think it should be correlated with the clinical images also to categorize into the safe zone and watch out zone.
Clinical image is definitely there. So clinical image supported or augmented by these metadata will help us in better categorization. This is how we are trying to take it.
Thank you, sir.
I think this is very helpful also for catering the early cancer to the hospital also. This is a very good steps.
Yeah, I think that's important. So if we talk about social
Early
demography,
detections.
social demography is important to track that patient and ensure the referral and then the follow-up later on. So, that's why social demography plays an important. This has a power of acting as a registry for OPMDs and oral cancer, a population-based registry. So if it is done in a beautiful way, if we come out with this solution, so this in itself can be a registry for oral cancer and OPMDs as well, which largely is missing. We have some cancer registries. Most of them are hospital-based registries. And OPMDs, we don't have any registry. So this in itself can act as a registry as well. Yes, please.
Thank you, sir, for the talk. So you mentioned ongoing model validation and how the model performs poorly sometimes in actual real life deployment settings as compared to when it was trained or looked upon from the hospital datasets. So I wanted to understand how we can, during the model development phase, incorporate that by probably incorporating the feedback of both the clinicians and the model development people. So I wanted to understand your views on how we can incorporate that from the start of the project itself.
So Dr. Khanna just walked in, and I would just like to echo down what he said yesterday, Gigo, garbage in, garbage out. So at the time of model development, and not just the model development, at the time of this data collection itself, so we have to look into what is going into the model, right? And annotations. So there are images available. Somebody has to sit down and tell what does it look like. So that annotation is important, right? And then accuracy of annotation. Just like somebody was talking about systematic reviews and meta-analysis, at least we make sure it's done by 2 people. And if there is a conflict, it goes to the 3rd one. So similarly, we are following this model where annotation is done by 2 experts distant, two distant experts, right? And in case the system sees that there are some discordances, then it goes to the third person for validation. So all I'm trying to say is, one is good data set which goes into the system, right? And the annotation being done in a beautiful way, or in a let's say in a more accurate way, will improve the outcome of the model.
But now that the model has been developed, let's say,
No, so
when you validate the model,
so model can be developed, model can be redeveloped, and again it can be redeveloped. So if you have the data set available with you, this model development and redevelopment, okay, this way it's not working out, maybe some other way it works. So it's a computational process. So computational process may you will take maybe few days more. Your IT guys or IIT guys or whosoever is working on AI, they will sit for few more days, develop a new model. But you should have the data set with you. That's the key. So data set in a standardized format is available. The model can be developed and redeveloped. It would take some time. That's fine. But that's more of a computational thing.
Thank you, Dr. Arpit. It needs validation. The question is this: it needs the validation further on. Thank you very much.
Thank you, sir. Thank you.
Thank you to all our speakers and chairpersons for this enriching session.
Now, I would like to request the chairpersons and our speakers to kindly move to the selfie point for facilitation. Felicitation. Sorry.
Now, let us proceed to the third scientific session of the day. I would like to invite on stage our esteemed chairperson, Professor Deepika Joshi ma'am, Department of Neurology, IMS BHU, Professor Pradyut Prakash sir, Department of Microbiology, IMS BHU, and Professor Abhishek Pathak sir, HOD, Department of Neurology, IMS BHU on the dais.
So it's thank you organizers for giving us this opportunity to be a chairperson in such a wonderful, I mean, gathering among the experts of AI, and hopefully we are going to take some key takeaway messages from this short gathering of experts. So without wasting much time, I would like to invite our next speaker, Dr. Chirag Kamal Ahuja. He's additional professor in Division of Neuroimaging and Interventional Neuroradiology, Department of Radiodiagnosis, PGI, Chandigarh. His areas of interest are endovascular treatment of brain stroke and neurovascular disorders, and obviously artificial intelligence in neuroradiology. And he has multiple achievements, including RSNA International Young Academic Scholarship 2014. He has more than 250 publications with more than 150 guest lectures. So the stage is all yours, Dr. Chirag.
Thank you, Chair. Thank you. So thanks, BHU, for having me here. So in the next 30 minutes or so, what I'll be dealing with you is, it's not projecting. So a bird's eye view of how AI can be used, has been used, and will be used in the field of neuroradiology per se. And so because neuroradiology is a combination of both diagnostic and interventional neurointerventions, so how AI can be deployed in both diagnosis of neurological diseases as well as treatment component. Can I have the slides, please? So, so we've been talking about AI, and AI almost has been used in every field. What is important is the use of AI with NI. Unless we use our natural intelligence to utilize the availability of these codes, these algorithms, it'll be very difficult to actually leverage and use the AI for our use. So can we have the slides? So while we wait, I think just a brief about how AI has already been used in neurological diseases. Is the best example is the use of the programs for diagnosis of stroke. It has significantly transformed at treatment of stroke. Why? Because we've been able to easily and quickly diagnose and the various imaging findings of these imaging algorithms. So we'll go along. I think there are some hiccups. Can we move to the next slide? This is not working. Yeah. So just for perspective, in 2016, artificial intelligence and neuroradiology, just about 13 publications. As we move along, and in 2025, the publications have almost increased tremendously to about 518. And this is just neuroradiology. I'm not talking about AI in health sciences, radiology, in medicine per se. This is just neuroradiology. So as I was talking to you about, stroke imaging has been transformed with the use of currently available tools in the public domain. And if a patient of stroke comes to us, our main focus is to rule out hemorrhage, exclude other stroke mimics, identify early signs of ischemia, identify the site of occlusion, which has led on to this ischemic infarct in the brain, reduce the status of collaterals and how the distal part of the brain is being perfused, evaluate the perfusion which is happening, and map the cervicocranial arteries for prospective thrombectomy. This entire flowchart, when a patient comes to us, goes to the CT or the MRI gantry, and we have the data out of it, takes about, if not more, at least 20 to 25 minutes. And what is important is, in stroke, time is of essence. For perspective, we have our honorable neurologist here. So every minute sees about 1.9 million neurons dying, and you just can't actually see them die because each neuron has a function to perform. So if we can reduce the time of the diagnosis of stroke and map these arteries so that actually we can perform treatment in these patients is very, very important. Can we have the next slide, please? I think this is not working. So what is involved is image acquisition, image reconstruction, and image interpretation. And this takes about at least, if not more, 20 minutes. So this is what you get on a non-contrast CT scan. You see a well-developed hypodensity, which is actually an infarct here. And to see where the infarct came from, you do have to perform a CT angiography or an MR angiography, whatever institutional protocol you choose. And this is what we see many a time, the thrombus in the middle cerebral artery, which is responsible for this stroke. Perfusion is also done to identify the salvageable area in the brain, whether you are going to do any good in these patients if you kind of remove the clot, and whether these patients will eventually come out of that neurological deficit that the patient is harboring on that time. And this is the eventual treatment that you want to perform. This was the left IC angiogram shows a significant reduction in the perfusion of the MCA territory and the clot which was hanging here in the MCA. We went inside, put in a stent, retrieved the clot, and this was complete restoration of blood flow. You have to do this in the quickest time possible, and for that you need to have algorithms. So we have, fortunately, in the public domain, FDA approved algorithms here, and this goes by the name of Rapid AI in India that we have. It automatically identifies the infarct area in the brain. It tries to give a scoring system to that infarct area in the brain. It automatically detects on CT angiography images the area of occlusion and what is the status of the distal perfusion. It also, again, quantitatively tells us what is the amount of salvageable area in the brain. And so it generates images to let us know what component of the area is salvageable. It defines certain ratios as well. Like in this case, it defines the mismatch ratio and the area of the brain which has infarcted and the area of the brain which is salvageable. So you can actually, and this is available on your smartphones as well. So sitting at home, you can actually look at which patients are coming in, which patients require, and you can actually tell your residents before you reach there to prepare the patients for mechanical thrombectomy or neurointervention. In fact, if the patient comes to us in the window period, the first step would be intravenous thrombolysis followed by mechanical thrombectomy if required. So a number of softwares currently are available with us, but they come at a cost. Like this Rapid AI we acquired for about 50 lakh rupees. So we need to have our own systems in place, and actually we are working on that. And within just a couple of few lakhs, we can have these softwares available for our population and can be used in the peripheral centers where stroke is really a large burden. Now, as I said, this reduces the reconstruction and interpretation time by about 10 to 15 minutes. And you can see the amount of neurons saved, about 19 million neurons saved for about 10 minutes of these. Another use that we have seen with these AI algorithms is in the imaging and follow-up of multiple sclerosis lesions. So what these platforms or algorithms do is they identify the lesions right at the time when the patients present to us. The patient is put on various therapies, and these patients invariably are followed up at regular intervals based on MRI scans. So we have certain MRI sequences, especially the flare sequences and the contrast sequences, which help us to follow the burden of these diseases and base our treatment, increase or reduce our treatment based on what we get in the follow-up scans. Again, as I said, we have a number of algorithms currently available. They are well set, acceptable, and we are using for our patients. The other part is in hemorrhagic strokes. So in hemorrhagic strokes, the patients come to us with bleeds in various locations, various compartments. There may be subarachnoid hemorrhage, there may be intraventricular hemorrhage, there may be large parenchymal bleeds. So each of these patients behave very, very differently. And it is very important to identify the location of these bleeds, the volume of these bleeds, and the secondary sequelae that these bleeds are causing on the normal brain and the compression, and whether these patients will require urgent decompression or not. Unfortunately, in peripheral centers, even if we have CT scanners, we don't have people to interpret these scans. So AI-based algorithms can really help us in defining these lesions, classifying these lesions, and triaging these patients, whether these patients can really be moved to centers which have neurosurgical capabilities in the shortest amount of time as possible. Many of these hemorrhages, especially subarachnoid bleeds, are secondary to presence of these intracranial aneurysms. So how AI can help is, like in this case, we have a saccular aneurysm which requires endovascular treatment, and because I perform neurointerventions and endovascular treatment, this is a very pertinent problem that we are facing. So we choose certain, so these are filled by certain material which are called coils. So these are nothing but platinum wires which we use to fill up these aneurysms so that the blood eventually will not go into these aneurysms, and these are protected from secondary bleeds. But what is important is to identify the size of the coils that needs to be put in these aneurysms based on the size of the aneurysms. And if you choose a smaller coil, the coil will go back into the parent artery and will occlude the parent artery. If you choose a larger coil, there is potential for you to rupture these aneurysms while you are putting in these coils in these locations. So identifying and the correct size, diameters, and the length of coils is very, very important. We have AI algorithms to actually, and this is especially important in the initial first few years of the trainees, which help us identify in choosing these appropriate coils for these aneurysms. So this is a software which is available in sizing of these aneurysms. At times when the aneurysms are very, very large, the coiling is not really sufficient. You need to reconstruct the parent artery in this case, and for that you need to put stents in these parent arteries, and you need to identify the size of these parent arteries. Again, this is not moving. Can we go on to the next? Yeah, thank you. So again, choosing the size of the stent in the parent artery in addition to the coil is very, very important. Placing a smaller stent will not cause the aneurysm to heal. Placing a larger stent will cause the parent artery to get disturbed and dissected. So again, softwares are available. Coming to what we have been doing, and I started this about 12 to 13 years back as radiomics. So AI began in imaging, in radiology, in neuroimaging as radiomics. Radiomics is nothing but identification of the texture analysis of various neurological disorders. And this was one of the first things that we did. We tried to identify tumors. This was actually the first thing that we started off with, because you all know that any intracranial problem, especially tumors, is very, very difficult to biopsy. You need to perform a craniotomy, take your biopsy needles in the center of the tumor and pick a biopsy sample, and which will tell you what tumor it is. So we thought imaging gives us about 70 to 80% accuracy, especially MRI, various sequences to identify these tumors. But it's very, very difficult to further classify these tumors because almost all these tumors require different treatments. So primary brain tumors will require biopsy, surgical excision, followed by radiotherapy. Metastasis will require a whole new different treatment. Lymphoproliferative disorders will require radiotherapy and chemotherapy. So what we did initially was we tried to segment these tumors, localize these tumors, identify the necrotic component of these tumors, and how much perilesional edema were they causing so as to cause significant mass effect on the adjoining brain? What was the degree of midline shift and whether these tumors actually required decompression in the ER settings or not? Just a brief about how AI models look at these images. So this is an ultrasound image of a kidney, right? So this is how we look at a kidney. We see a capsule, we see cortex, we see medulla, and we see the ducts. How the AI models see these images are in the form of numbers. So just a representation, and these numbers are eventually fed and developed, fed into networks and identified, categorized, and the outputs are again achieved in the form of these numbers, which are eventually transformed into analogous signals, and eventually we get these images. So this was one of our earliest projects that we came with. So what is important is we need to define the tumors. For training an algorithm, we need to define and train that algorithm on particular neurological disorders. Like we need to define what the necrotic part of the tumor is. We need to define what the boundary of the tumor is. We need to define what the perilesional edema is. This is called ground truthing. So if you do a suboptimal ground truthing, obviously the model will not be accurately trained and you won't get the results, the accurate results that you want. So these were our first papers. We trained models. We tried to identify tumors, segment it, identify features which actually were specific for these tumors. And initially we chose gliomas, intracranial tumors, gliomas. We tried to grade it into grade 1 to grade 4. And we also included meningiomas subsequently and tried to define our codes. And initially we collaborated with our friends from the AI and engineering backgrounds. Initially, this was from Thapar Institute, Patiala. Then we entered into collaboration with IITs. And they actually gave us codes. We validated them. And we found that these codes are really helpful in all these. So these were initial first of our few, about 10 to 15 papers from 2012 to 2016 that we came up with models to identify, segment these tumors. We developed multiple classification systems. We ultimately reached at conclusions that multimodal networks are really better than using single-based networks. And what we initially we did was from the images that we input, there were extraction of features on which were dependent the intensity component, the edges, texture, and shape analysis. Specific feature vectors were extracted, they were amalgamated, collaborated, and ultimately the machine learning algorithms were trained, a classifier and a declassifier models were developed, and out of these specific features were extracted, and ultimately new images were reconstructed and classifications obtained. The second component that we worked on was improving our imaging resolution, because many of these patients who come to these emergencies will not give you time to image, especially in MRI scanners. Why? Because these patients are moving and MRI requires at least 5 to 10 minutes of these patients lying still. So we worked on algorithms and we actually published a couple of papers to improve the resolution of images. A very valid example is the MRI scanners that we have in the periphery are invariably either 0.4 Tesla scanners or 1.5 Tesla scanners. This is nothing but the strength of the magnets that we have. As we improve the strength of the magnets to 3 Tesla and 7 Tesla, we have better images. Unfortunately, these are costly, expensive, and the peripheral centers don't have it. So we attempted at improving the resolution of the images of low strength magnets of 0.4 and 1.5 Tesla to match with their 3T counterparts. And actually, we were successful to about 70 to 80% in improving the resolution of images. Why? Because ultimately, reading images, in addition to what you already know about reading images, the second thing and the most important thing, what matters is how the images are for your interpretation. So we published a couple of papers on that as well with significantly good results along with collaboration with IIT Mandi. Next, please. Yeah. So we call them super resolution of MRI images, in which we significantly improve the signals of these MRI images. Next, please. So there's a problem with this. The next problem that we faced was there are certain disorders which have certain category of texture which is better appreciated on CT versus MRI. Like in we all understand calcification is better seen on CT. And it's very, very difficult to identify calcification on MRI unless you are using gradient-based images or so-called susceptibility-weighted images. So we can have the results of both CT and MRI amalgamated into a single image. This was a thought process that will significantly enhance our diagnostic accuracies of disorder. And we attempted this. We tried our hand in fusing these images. These images look very, very differently. Like in this image that you can see on the left side, this is the CT scan. On the CT scan, the bone is very, very well identified. The soft tissue resolution is significantly poor. While in corresponding same image, same patient, same section, this is the MRI, and the soft tissue component of the brain is very, very well depicted as compared to the CT scan. However, there is a compromise of the calcification and the bone. So if you have a mix of both these components, we can actually improve our accuracy of identification. We tried our hand in fusing these images, and actually based on AI algorithms, we got very, very good results. And this was from a third collaboration that we had based on our understanding. So we even tried a hand in fusing the angiographic images with the bone images. Like in the standard angiographic images that we do, because I also perform endovascular treatment of neurological diseases, angiographies that we used to perform initially, maybe 10 years back, when we didn't have subtraction modes in our angiography machines, we used to get the angiography, the depiction of and demonstration of the vessel along with the bones. And you all know that the skull is actually hinders our evaluation of these structures. We tried to subtract these images so as to get only the subtracted angiography images, which significantly improved our accuracies in visualizing these disorders and actually treating these disorders. Another role was to fuse these angiography images with X-ray images. So that was a corollary that we did. And we again published quite a few papers on that with significantly good results. And this was actually appreciated by a number of our collaborators and in fact our students as well. Now, the next thing that is important is evaluation of the intracranial hemorrhage that currently we are embarking on, and we are trying to develop algorithms. We've kind of received grant from ANRF. We're trying to develop algorithms in traumatic brain injuries, especially for centers in the periphery. When the patients are coming to them in the peripheral centers, they are scanned, but there is no one to interpret them. And whether these patients require urgent triage, whether this bleed is significant enough to cause mass effect, midline shift, so that these require certain significant decompression. This was the initial work that we started in 2018, and our thought process was developing these algorithms. We were able to identify, define these hemorrhages, distinguish this from the normal brain, and really were able to tell us that this patient requires urgent treatment. So again, this is another funding that we have got actually, as I was telling to you about. So identifying hemorrhages, identifying fractures, and differentiating hemorrhages which are not causing significant mass effect versus the ones which are causing significant mass effect. These are the patients who require urgent decompression. So we are trying to, again in collaboration, we are trying to develop algorithms which will help us in triaging these patients, and especially in the peripheral centers, and sending those patients in the neurosurgical centers as early as possible so that we don't lose these patients to trauma. Another funding that we have got from DBT is the brain hemorrhage and aneurysm evaluation, because hemorrhagic stroke is a big burden, and most of these patients will not survive. And the mortality rate of aneurysm patients dying in the hospital is to the tune of 30 to 40%. This can significantly be reduced if we identify these aneurysms early and we treat these aneurysms early. A significant role is in the screening programs. It has been shown that there is a 5 to 8% burden of asymptomatic intracranial aneurysms that can be potentially treated. And in fact, many of the countries have developed their own registries, and they are doing screening MR angiographies to identify these cerebral aneurysms so that these can be treated even before they present to us with symptoms in the emergency. So treating asymptomatic aneurysms, the risks of treatment are only about 2 to 3% versus 10% treatment that is in patients who come to us with symptomatic ruptured aneurysm. So the aim of this project is to develop an automated pipeline for establishing comprehensive abilities to detect and quantify these intracranial hemorrhages, including SAH, detect its causative factors, namely aneurysms, AVMs, and other vascular disorders, define the morphology of these aneurysms, develop tools to elaborate its structural details so as to offer optimal treatment, and with the ultimate aim is, to reduce the functional outcomes and reduce the mortality. So this is again a DBT funded project. This just to show you how an aneurysm looks like. So this is an aneurysm, very small aneurysm on the parent artery. This small bleb actually was missed by our residents. So what is important is to identify these aneurysms. Also, the aneurysms, intracranial aneurysms, are of multiple types. There may be saccular aneurysms, there may be dissecting aneurysms, there may be blister aneurysms, and so it's very difficult to identify uh, these aneurysms, classify these aneurysms by our residents and even the junior faculty. So these algorithms will actually help us in identifying this as well. So these are the initial few results that we obtained, and these actually our algorithms helped us in identifying these aneurysms from the parent arteries and actually made a significant difference, I would say, in how we treat our algorithms. So these are some of our a few papers that helped us in, and obviously in collaboration, that help us in identifying, segmenting these aneurysms. And so this is the initial phase that we've just started with this. And the ultimate aim, as I said, is to develop the pipeline to ultimately arrive at treating these aneurysms. So these are first of our initial papers in that journey. So can we have the next slide, please? So in neuroradiology, apart from looking at images, these are the various things and these are the various levels that AI can actually help us in triaging all these patients, right from clinical requisition and scheduling of these examinations, patient screening for a particular exam, actual imaging acquisition, detection of pathologies, automated interpretation of the findings, image management, post-processing of these images, analysis of the image quality, reporting and analytics, and automated dose estimation as well. So, so we can optimize MRI scanning utilization using these AI algorithms. We can assess the scan imaging quality. We can schedule these patients. Next, please. We can actually play a role in population health and disease prevention. Radiomics can help in disease evaluation and image quantification. And AI actually can help us through automated segmentation of all these areas. It can even have a role in resting state functional MRI studies. Stroke, I alluded to you about, radiomic analysis of other neurological disorders. Alzheimer's is a big kind of disease burden that we will see with the aging population. Demyelination, it's already happening there in AI. Other potential clinical uses are predicting overall survival in neuro-oncology patients, prognosticating outcomes and complications in cerebral vascular disorders, preclinical diagnosis of Parkinson's disease and other movement disorders, cortical feature analysis in especially epilepsy patients. But there are challenges in the form that some of these algorithms may mimic human bias in decision making, like when these algorithms have been trained by data sets which were faulty. That is very, very important. The intent behind AI design at times may be unethical, but again, there have to be regulatory authorities coming in and taking and playing a big role in this. So I think there are other challenges. There'll be future talks on this as well. Some other ethical issues like algorithm generalizability across institutions and across scanner types is a problem because there are varying vendors who are making these scanners. Homogenizing is a little difficult. Limited availability of large annotated training data sets is a problem. Regulatory approvals are a problem. Integration with existing IT infrastructure will take time. I envisage it will take a decade, if not more. Data is a problem, but data mining can be done. Data mining can be used again based on statistics, machine learning, artificial intelligence to actually get at conclusions. Brief couple of last slides about future perspective. Apart from the imaging that I was focusing about, we actually can play a significant role in multimodal AI, wherein apart from images, we can use text and charts for deriving at conclusions. Federated learning is important. There is an increasing role of explainable AI in which transparent models will provide interpretable decision making for various disorders. Personalized medicine is important, and I think that is the way to go. And I will end by just showing you a couple of chapters. You can go there, and if you are actually interested in radiology and radiomics, you can go through these chapters that which we wrote about AI and neuroradiology. So I would say that this you can see this as your own self. This is basically AI researcher, natural intelligence, or you can call it a radiologist. And this is AI. What we need to do is we need to mount this horse of AI. And once we do that, we can actually control, maim, and actually regulate how AI can be used for our own benefits. Thank you.
Thank you for this wonderful journey of AI evolution that you've shown in India. And I saw the first paper being published in 2016, when in India, where there was not much of buzz around, but that's a wonderful job. Before, I mean, now the house is open for questions. Yes, sir. Identify yourself, sir, and you can ask a question, please.
You have given a very nice explanation. Myself, Dr. Pankaj Kumar Singh from IIT BHU. There you have used SVM. Yeah. How SVM works in the medical system?
So these tools, support vector machines, and these tools are basically, they augment the analysis of images at the level of breaking them up into pixels and voxels, and then ultimately defining textures on these, and ultimately taking those textures, fusing these images, and reaching at results. So I think if you are, so as a clinician, I would say that this has really initially, in our initial few collaboration, this initially helped us to in the texture analysis. But as of now, we've actually evolved beyond this, and the technical aspects, I think, will be better answered by our collaborators, AI-based collaborators, and on how currently we can use SVM in our research.
You didn't apply that.
But
you didn't apply it. You have already published paper on SVM.
Yeah. So initially we used, but we have actually transformed into multimodal things as of now, like RESTnets and multimodal various other.
Probably this is a wrong question to a clinician. I mean, they are tech collaborators, and they've clearly evolved of the image acquisition from SVM to a better techniques, tools that they have been using now. Probably this would be best answered by tech people like you. If you have any comment on this.
Yeah, I think.
Just I want to know that I am aware about this, but I want to know about in the medical.
Yeah. So probably you've evolved out of it. And if there are no more questions, I have few questions. I mean, thank you for this wonderful deliberation of your work. I mean, see, when we train the machine, you have a gold standard. You know the diagnosis. Like talking of tumors, right? Now the tumor evolution. I mean, the tumors have evolved from histopathology, the clinical features associated with it, now to the molecular levels and the multi-omics. Now, if you train something in 2016 on whatever tools you've used, irrespective of the tools, now evolving multi-omics has changed the diagnostic paradigm now. So now probably with the evolution of multi-omics, with the evolution of genetics into it, probably you need to retrain the modalities to have, I mean, those at 2016, the sensitivity of the agreement with the machine model will not be sustaining now what we have, right? First questions on your comments on that. Second thing is inter-rater variability. And when you talk of imaging, you have multiple images of a single patient. So it can go up to thousands, right? So when you train multiple data sets, including images of a patient, right? And the same data sets keeps appearing. So there is a bias to it, right? And I'm not a technician, but I have the broad overview of the technical flaws that can come into it, and the inter-rater variability is important. So if you train the machine with your radiological data set, and similar data set would be trained by someone else of your colleague who are blinded to you, there will be variations. So your comment on that. And sorry for the last question. The last question in the pipeline is, I mean, when we train the machine, right, we have input of the data with the positive diagnosis, the confirmed diagnosis. What about training the machine with the false data? Say they are stroke mimics, right? So early ischemic strokes aren't picked up on, say, CT. So maybe a seizure with thoughts paralysis would be taken up as a stroke. Maybe hypoglycemia would be taken up as a stroke. So do you also try to train these false positives into the machine, or it's just the true data and then seeing the rest of the data being how significant it is? Sorry for the trouble, but
no, very pertinent questions. Actually, 2016, 2018, as you correctly said, it doesn't hold true as of now. Because why? Because for that matter, the tumor classification has changed. We don't look at tumors like grade 1, grade 2. There's a lot of radiogenomics involved. So what we have currently done is we've added that multimodal component of radiogenomics to our imaging, and to analyze whether it has significantly changed the accuracies, and it has actually. So again, uh, so genomics, so on board our pathologists as well. So they share, so obviously if we train that, we need to have images as well as the other multimodal data sets. We are inputting those images, and we are inputting the biopsy samples of radiogenomic data as well in those multimodal networks to ultimately arrive at a conclusions. So correctly pointed out, this era is completely different, and there are much more inputs involved rather than just image to have to derive and reach at a conclusion. So yeah, the second is the inter-rater variability. Obviously, it is all GIGO. So whatever you input is the output that you get. So we make sure on ground truthing. So that's what we call ground truthing. Once we are doing the ground truthing is done by experts and not really the residents or the people who have just started. And ground truthing is done at least two or three people who have been in this domain for the last and working in this domain for the last about at least 5 to 10 years. Obviously, if you train the data and the people who are not well versed with identifying the data, the algorithm will give the results accordingly. So obviously, we use people who are well trained to define the data to the algorithms.
do you also train false
Okay,
positives?
so till about 2 to 3 years back, we were not. We were just focusing on only the so-called true positives and only the disease at hand. But of late, we've started to give these algorithms the negative data also and the alternate data also. But obviously, alternate data not to tell them that this is the alternate data to tell them that this is not the true data. Like we are not telling them this is a cortical dysplasia, but we are telling them this is not so.
Now question arises, what sample size would be adequate for any data set?
Okay, so sample size initially used to be very, very large, but now with the process of reverse and transferable or extrapolative algorithms coming up, even the testing data can be used for validation, and the validation data or the training data can be used for testing. So we can interchange the data. And now, so we've been told, I think we have collaborators with us, even a single data can be actually expanded and multiplied to form multiple data. So we've given them one data set and they've generated their own 10 data sets just to train the algorithms. So we are looking at, so although the data required is huge, but then data actually can be manufactured for training these algorithms.
Dr. Chirag, as you have said that there are FDA approved softwares which has been incorporated for detecting early detection of strokes. So are these able to detect all the possible stroke cases, or they used to miss even?
No. So I didn't show you an example. So there was a patient who came to us with suspected stroke. So that was right-sided hemiparesis. So we suspected a left MCA infarct. But so on the algorithm, so we have the aspect score, right? So aspect score given to us was 5 by the algorithm, and we didn't at that point see the images, and there was MCA occlusion. But when we went to the console, saw the images, it was a large basal ganglia bleed. And due to the bleed, there was significant compression of the MCA, which this algorithm identified as occlusion. So there are fallacies, and last slide actually holds true. We have to sit on the AI to be better able to utilize AI for our best. So ultimately, if something goes wrong, medical legally, we won't be able to kind of say that this was done by AI. Onus has to be on the clinician in charge.
Thank you. Thank
Do
you.
you have any
Wonderful.
patents out of this? Nathan? Any patents out of this?
Not as of now. Initially, we had patents for the initial, but then obviously those are redundant as of now.
Yeah, my question is what do you feel are the major limitations, and have you validated this at your institute level or in the periphery? Because mainly we need it for the peripheral doctors more. Institute may, as it is, we have experts doing it. So the limitations, and have you validated in the peripheral people, the peripheral hospital?
Right. So we started off with open data sets. So those were ideal conditions, optimal images. Everything was very easy. Algorithms could easily pick up everything. Then we transferred to our institutional setup. The accuracies fell significantly. Then we trained the models accordingly. Accuracies, in fact, became better. Now we are collaborating with 2 or 3 peripheral centers. We've received the images because that was institutional work. The previous 10 years was institutional work. Now we are training these algorithms with peripheral data sets, and still the accuracies, as you rightly pointed out, have actually become have fallen. So we are trying to again reorganize these algorithms to define and identify and work on those peripheral data sets. We are working on that. Thank you.
Thank you. Thank you, Dr. Chirag. Now, I would like to invite our next speaker, Professor Sameer Trivedi, Professor Urology, IMS BHU. His area of interest are uro-oncology and urology, endourology and renal transplantation. He is editor of editorial board member of Frontiers in Reproductive Health, and he has published more than 130 papers in international journals. He has delivered guest lecture at various international and national conferences. So I invite you, sir, for the presentation.
Thank you. Good morning, respected chairpersons and members of this august audience. Thank you to our director, Professor Sankwar, sir, the telemedicine team, Dr. Nilesh, Dr. Amit. It's a pleasure to be here, and by the time they work out the presentation, my presentation is going to be more of kind of glimpse into how AI is currently being used in the field of urology. We are already moved beyond the testing and validation phases in a lot of areas within urology, and it is now being used actively at various centers. So I won't go into the technical details of the procedures or hardcore urology because that is not your specialty, but the focus would be more on kind of how we are using it, what are the potential avenues in which we can utilize these AI-based algorithms and pathways, what are the current challenges and limitations, and what is likely to happen maybe 10 years or 20 years down the line. So that will be broadly the outline of presentation. I don't think you need this slide. This kind of superfluous. You have been hearing about AI for last 2 days and you all know about it. I just want to emphasize the last point. As of now, despite being widely used, AI cannot be a substitute for a clinician. And as the earlier speakers have pointed out, we need to learn to take control of how to use AI and live with AI rather than rely on AI to do the job of clinicians. So that appears to be unlikely, at least in the near future. Why urology as a specialty is particularly suited for utilizing AI algorithms? There are a couple of reasons. Number one, ours is a very, very imaging intensive specialty. We rely heavily on endoscopy images, findings of CT, MRI, IVUs, and so on. And these make it a perfect learning model for AI-based techniques. There is a very high procedure volume. The protocols are more or less defined. The workflows are structured. We have a very high degree of objective outcomes to rely on. We deal in more in absolutes than in abstracts. So it is more of black and white than shades of gray. So whether a patient is stone free or not, it's a very objective parameter. Whether the patient has got tumor or not is a very objective parameter. So most of the indicators in urology based procedures are objective, which makes using AI relatively easier. As somebody pointed out earlier, we are moving towards personalized medicine, customized therapy for individual patients, and especially in the field of uro-oncology. So precision oncology is something which is heavily into practice in urology, and therefore, again, AI is quite a good modality to use. We have got large number of data sets across various centers. Almost all the procedures at major centers are recorded and stored. So we have got huge digital data. Robotic surgery was the first to be used in urology, and probably still now about 65% of all robotic assisted procedures are done in the field of urology. So we are already heavily into robot assistance for performing our procedures. And the current robots, surgical robots that we have, they already have inbuilt AI models to assist the surgeons intraoperatively. So that is another advantage of using AI in urology. And of course, telesurgery, which is coming into the picture now, is being increasingly done for urology procedures. Even in our country, there are plenty of instances where telesurgeries have been done from hundreds of kilometers away on peripheral centers. So because of all these reasons, urology is ideally suited for use of AI. There are various domains or various modules within urology where AI can be used, starting from new drug development, precision medicine, asset allocation, and so on. The net result of all these is ultimately better clinical services for the patients, better diagnostics, better therapy, better follow-up, better prognostication, and so on. So if we look at more concrete terms, how urology is using AI in the current era, starting from diagnosis, be it of stones, be it of cancers, be it of functional urology, neurourology, planning the treatments for these patients, whether you want to go in for surgery in these patients, whether they should be put on active surveillance, whether the surgery should be in the form of a laparoscopy or endourology, or it should be an open procedure, whether the patient is a candidate for radiotherapy or chemotherapy. If you offer the patient treatment, what are the likely outcomes that are going to be there? During the surgery, as I mentioned earlier, we are using AI to augment our surgical efficiency, provide better outcomes. Telesurgery is already happening. And then very important application is the way we train our residents, the way we are teaching and training our residents can be very well monitored and evaluated by the use of AI techniques, as I will demonstrate in the later slides. And then there are a lot of outpatient uses. You have got medbots, which can help you in history taking, follow-up of the patients, triage of patients, patient counseling and education, and so on. So a lot of things where AI can be used. I'll just take a brief examples from almost all the domains and not go into too much of detail. Regarding imaging and radiomics, the earlier speaker did a fantastic job on neuroradiology. Similarly, for uroradiology, role of AI, we have got now excellent algorithms which help in detection of stones by doing segmentation and volume estimation and so on. PIRATS scoring is something which we use for diagnosis of CA prostate, and there is a significant degree of inter-observer variability when it comes to PIRATS scoring, and we rely heavily on the experience and expertise of the radiologist. So this is one area where AI-based algorithms can help us in better quantifying and identifying the type of tumors. Then in follow-ups also, when we do subsequent imaging in the follow-up of the patient, the similar algorithms can help us regarding the impact of therapy on that particular patient. If the radiation has been given, what happens, what has happened to the primary lesion? Has it shrunk enough? How much is the change, and so on. Then for histopathology, which is again a very, very subjective and observer dependent kind of field, and we again rely very heavily on histopathological evaluations to deal with our uro-oncology patients. AI-based models have now been published and reported to have a degree of superiority over the conventional pathologist-based models in terms of detection of very subtle foci, which might be missed by less experienced or younger pathologists. For example, in CA prostate, it's a multifocal disease often, and the pathologist might focus on one particular aspect, whereas it may miss secondary lesions. Similarly, for quantifying the degree of tumor aggressiveness, uh, this all can be done in a much better and more importantly, much faster way. Normally, a histopathology report takes about 5 to 7 days. At our institute, it takes about 3 weeks. But using AI techniques, this time can be brought down to 24 to 48 hours. And you realize that the timing is crucial when we are dealing with patients of oncology. Then endoscopy. Urology endoscopy is something which we do day in, day out, and it's a significant part of our urology practice. And again, it's a very, very subjective thing. I'm sorry, these videos are not running. So can somebody do something about it? There are some more videos later on, so I would prefer if you can do something. So cystoscopies, for example, endoscopy of the urinary bladder, the most significant indication is picking up bladder malignancies. And there are such a wide myriad lesions within the bladder which can mimic a malignancy or which can mask a malignancy. And it sometimes becomes very difficult to identify these lesions. So we have now got models, one which I wanted to demonstrate, but unfortunately that video is not running, which can help us in picking up these lesions. Occult lesions can be picked up, the lesions can be quantified, they can be measured in size. Then other big chunk of our practice is regarding stones, renal stones, ureteric stones, and so on. And almost every aspect of stone disease, starting from diagnosis, treatment planning, the treatment itself, and the follow-up, is now helped by AI-based models. So in imaging, CT-based imaging or even ultrasound-based imaging, we can have a much better stone segmentation, volumetric estimation, quantification of the burden. This is in turn important for us to decide the type of treatment that we want to offer to the patient. Whether this stone is suitable for a lithotripsy or whether this patient needs an invasive procedure like a PCNL or a ureteroscopy depends on the volume of the stone. Then looking at the stone, AI models can predict what is the likely chemical composition of that stone. That again is a major determinant of the treatment. Certain types of stones are more likely to recur in future, so we can offer these patients counseling and lifestyle change advice and prophylaxis in order to prevent recurrences. Similarly, before we offer the patient any treatment, AI can help us in telling us the likelihood of the success of that procedure. So outcome prediction is another major application of AI-based models, especially for endourological procedures. We were the first, I think, in this country to use this model way back in 2003, when things like AI and ANN and these things were unheard of. So we had the good fortune of having IIT within our campus, and the collaboration was done, and we published this paper in 2003. And this was done basically to predict the number of shock waves that a particular patient will have while undergoing extracorporeal shock wave lithotripsy to fragment the renal stones. And the algorithm was fairly successful. Subsequently, we followed it up with another study which was published in 2010, in which we compared the AI model to the conventional multivariate regression analysis and tried to see whether how did the AI model score. And it was fairly comparable between the two. Subsequently, we have moved on to uro-oncology, and couple of projects are underway, so I'll not go there. Similar models have been now developed to predict the success rate, likely complications of endourological procedures. For example, in this study, they have tried to predict the outcomes of flexible ureteroscopy. So the 4 broad parameters that they studied was what are likely post-operative complications that may happen after the procedure. SFS is the stone-free success rate. So what are the chances that this particular patient will be stone-free post-procedure? So based on these parameters and these models, before the patient undergoes any procedure, we are able to make him sit down and tell him that, look, these are the chances of complications. This is the possibility of your being stone-free. This is something which can go wrong and so on. So this is a significant step in counseling and better preparing the patient for these procedures. Probably the biggest domain where we are using AI currently is prostate cancer. This is one of the most significant malignancies which happens, and particularly since it's more common in Western countries like US and Europe. Therefore, the amount of research that has gone into CA prostate is disproportionately higher as compared to other urological malignancies. So almost all aspects of CA prostate related uh, treatment pathway has seen the advent of AI in this. So starting from diagnosis, then the most critical aspect currently in CA prostate management is the risk stratification. It is now being realized that not all CA prostate patients require treatment. And probably last 15, 20 years, we have been over treating our patients. Even if no treatment would have been done, these patients would have died of other causes rather than of CA prostate. So cancer-specific mortality in CA prostate patients is low, particularly in a subset of patients. So AI models help us in identifying which patients would be the ideal candidates to go on this surveillance pathway, which candidates would be ideal for definitive therapy or aggressive treatment. And these models integrate variety of parameters starting from the biochemical parameters like PSA values, information from MPMRI, that is PIRATS scoring, the histopathological information, and now currently we are also incorporating genomic scores into this kind of models. So these are some of the commercially available models. The earlier speaker pointed to the high cost of these models for a particular center. The advantage with these models is that they are commercially available. For example, the Artera AI tool. There is a website, you go into it, you click it, all kinds of fillable fields open up. You fill in the particulars of your patient, age, Gleason's grade, PSA, MRI findings, genomic scores, and right then and there, it will give you that this patient has this much probability of having a metastatic disease, this much probability of extra capsular invasion, this much probability of lymph node positivity. This would be the ideal treatment for this patient. This is the likely 10-year survival of this patient. So this kind of information is readily available at the click of a button. So these are the kind of models that are coming up, and they are helping significantly the clinicians in making these decisions. If you look at the whole landscape of CA prostate, right from the localized disease to recurrent disease to metastatic disease, almost all the aspects related to their management are being affected by AI-based models, be it targeted biopsies, be it prognostication, be it risk stratification, be it choice of therapy, outcome prediction, and so on. So almost everywhere, AI-based models are being used. And same is the case with other domains of benign urology. BPH LUTS is another fairly large subset of patients that we see. AI-based models can help us in quantifying the severity of patient symptoms, can predict the likelihood of responding to the medical treatment, which patients are more suited for surgery. So this kind of information can be obtained from AI-based models. Similarly, for functional urology, which is the neurourology, looking at the patterns or tracings of urodynamic studies, AI-based models can predict what is going to be the likely outcome, which patients require intervention, what kind of decision should be taken in this patient. For andrology, which is again a specialty within urology, especially male infertility, the semen parameters, we have been relying on semen analysis for maybe 60, 70 years now. But with the coming of AI-based models, which rely on CASA findings, which look at the conventional semen parameters in an entirely different light, they can help us in predicting the success rates of our reconstructive procedures, success rates of IVF, ICSI, and so on. Then coming to very exciting field in urology is regarding the intraoperative assistance, especially with the use of robotic assistance that has become very common in urology surgery these days. So based on the use of certain domains which are called as tile pros, which are inbuilt in the Da Vinci robotic system, which is the most common robotic system used for urological procedures, It can guide the surgeon intraoperatively about the correct extent of the lesion, which is the normal area, which is the pathological area, which would be the correct plane of dissection. It can, besides the obvious advantages of stabilizing your hand tremors, making them more refined, increasing your degrees of freedom, it also gives you an idea about the normal organ which you have to leave behind and the pathology which you have to remove. Augmented reality is something which is playing a greater role in this. You superimpose the findings of pre-op imaging onto the intra-op findings, and on the table, on the screen, you can see where is the likely lesion and which is the normal pathology. I hope this video runs. No, it cannot. So maybe we'll have to skip the videos all around. This video would have shown you that what happens during surgery once the patient is operating on, say, a kidney tumor. You are planning to do a partial nephrectomy. It's a complex mass which is lying entirely within the kidney, and you are not sure how deep is it going. So oh, it's working. Fantastic. Thank you. So this kind of augmented reality can tell you what is the blood supply to that tumor, which is the vessel which is going to the normal kidney. That green thing you can see is the ICG, which is used intraoperatively to detect the vascularity, what is the vascular supply of that part. So this kind of AR applications are helping surgeons do a much more refined procedure, a much more patient-friendly procedure, and avoid unnecessarily sacrifice of normal tissues. Then there are certain OPD applications. Now we have developed disposable sensors. So this sensor is implanted in the patient's urinary bladder cystoscopically, and the patient goes home. And that sensor continues to sense the filling of the bladder, the pressures that are being generated within the bladder, what is happening to the walls of the bladder. All this data is going to an app which is there on the patient's mobile, and then subsequently it comes to the treating clinician. So sitting at his clinic, the patient can look at the patient's data for over last 1 month and can see how the bladder has behaved in normal physiological conditions as compared to what we do when we call him for a urodynamics, which is an entirely artificial setup. You put in tubes in the bladder. So the whole physiology changes. So these kind of things are helping clinicians in a much better way. And lastly, I would tell you about the role of AI in our training and simulation of the residents. So we have got programs and softwares now which can tell us how our residents are performing a particular procedure, how their hands are moving, how often does an instrument go out of the view during a particular segment of the procedure, as shown in this. So based on this feedback, we can guide our residents what mistakes they are making and how they can correct it. Similarly, the tracking of the instruments intraoperatively, which organs they are touching, which planes they are dissecting, where they are supposed to go, where they are not supposed to go, which organs should be handled how. This kind of information can again be obtained and feed it into an algorithm, and which can give you the feedback. And this is the surgeon's hand movement analysis. Both right and left hand movements are independently analyzed, and they are projected below in the form of a graph. So those two lines running together will tell you how the resident is moving his hands, left hand and right hand, while performing a laparoscopic procedure. And then this is matched with a standard or a reference given at the baseline, which an expert, if he is doing the procedure, if he has done the procedures, what has happened to that. So you can do these kind of comparisons and change your training program. And then this kind of virtual reality, I'm sure you must have heard of it. This is already started happening in clinical trials and probably would enter the clinical arena soon, where you can build a whole 3D holographic models of the patient's body, identify the area of interest, separate the organ or the particular system that you want to focus on, do a kind of 3-dimensional 360-degree rotation around the patient, around the organ of interest. And then this can help you in not only teaching about the anatomy, it can also help you in learning about the likely pathology which has happened. It can help you in deciding what kind of treatment would be an ideal for that particular pathology. And this is not restricted to urology alone. It is open to almost all the organ systems in the body. So these kind of things are happening because of virtual reality in the surgical practice area. And this is just a paper I want to show you about what I was saying earlier, how the residents' performance have been monitored. If you look at the two cubes, the one on the left, very clean-cut green and red area separations. That is done by an expert. If you look at the cube on the right, it's all jumbled up red and green. That is done by a resident. Similar information on these three charts that you see below. So this kind of objective information that you get from videos of surgeries will help you in teaching your residents the correct way of doing the procedure, the correct way of handling the instruments, the correct way of dissecting it. And this is something which is more likely to be coming up in the future, creation of digital twins. You feed all the data from all the omics that you have done, radiomics, genomics, proteomics, metabolomics, and then you can create a virtual identical twin of the patient, which will have exactly similar characteristics in all aspects. And then that can help you in predicting as well as planning the treatment for any diseases that may happen. Limitations and risks, I think almost every speaker has talked about it, so I don't need to waste too much time on it. I just want to point out something which is the so-called black box decision making. Now, this term came from World War II when the US Ministry of Defense was designing radars and so on. They noticed a peculiar phenomenon that you can feed all the data that you want, you would get a good output, but what is happening inside that machine was not clear, which is something called black box phenomena. Similar is the case with AI. We feed all the inputs, we give it a lot of information, it will create an algorithm, but what exactly happens inside is not very clear. So that in turn leads to trust issues, or how much are the clinicians going to be able to trust the judgment of the AI-based models, or for that matter, how much are the patients going to trust that model is a question which still remains unanswered. Regarding the data issues and biases, I think they have already been discussed. Ethical and legal considerations, I think there is a talk scheduled for later on in this program regarding this aspect. So again, this is something that I can skip. So finally, to take home, as you have seen, the evolution of AI is happening at a tremendous pace. It's already there in urology in various domains. The clinicians are using it. But at best, right now, it's an assistive tool. People who are thinking of a robot independently sitting at a console and operating on the patient, that is not happening and unlikely to happen in next at least 10, 20 years. So now, the robots that we are using currently, there is a grading for robotic skills from 1 to 5. The Da Vinci robot is level 1. Level 5 is a completely autonomous robot without any human interference. That is unlikely to happen. And AI is unlikely to replace the clinicians, but as the earlier speaker showed the last 3 slides of a horse and Usain Bolt and the man riding the horse, probably that kind of simile is quite perfect in this scenario. It can assist us to make better decisions, to deal with our patients in a much better way. Thank you.
Thank you for this. Now the mic is not working. Can you help us with this?
At a time, one thing works. If this works,
In
that
the era of AI, these technical glitches are wonderful. So thank you for this wonderful deliberation, sir. And it was indeed a pleasure and a treat to hear you. And you've rightly said, I mean, urology as a subspecial, as a super specialty is probably dealing most of robotics and the AI part of it. And it was wonderful. Now I'm sure there must be questions in the house. If they have listened to your talks and are intrigued, yes, we have one. Please identify yourself and please ask the question.
he is Professor Sanjay Sinha, sir. He is from Hyderabad. He is one of my
Sorry, sir.
revered seniors.
My apologies. My apologies.
It's a pleasure to hear you, Sabir, and to be here back in my alma mater. One of the challenges that we find, which we think we are going to face, is that the new generation of residents who train on these devices, would they be equipped to handle an emergency? The way that we think that we are able to. So let's say in a laparoscopy, have a catastrophe. We know that we can go back, we have all the skills to open the patient up and salvage the situation. Sometimes it's a matter of seconds which you get actually to do it. So how do you think that's going to evolve?
Yeah, that's an excellent point, sir. And I think that is where the difference between old teaching institutes like ours and the so-called new DNB centers is happening. Residents who are trained at old institutes like ours or AIMS or PGI, they are still exposed to basic urology first. So they know how to open up a patient the conventional way, how to take care of things. Whereas people who are training at private corporate hospitals as a part of DNB program, they are directly exposed to endourology, laparoscopy, and robotics. In their case, something going wrong and the need for conversion to open arises, that's an issue. So that I think is something which we as a society should address somewhere. Maybe the curriculum should be more standardized, even the DNB program, either if they don't do it, they can rotate their patients to other centers for 15 days, 1 month, so that they get an exposure. That's an excellent point, sir. Thanks.
I think, sir, AI will come into that too. I mean, in any case of catastrophe, how fast surgeons run to take care of the catastrophe and how quickly they repair it and how quickly the patient recovers, that again is a food for thought, probably. Yes, sir.
I am Dr. Anand Kumar Rai from IMS Patna. Sir, for application of AI in particular clinical condition, as I have heard that first we have to develop multiple models, and who will validate that the particular model is correct and that particular model has to be applied in particular clinical condition.
So that model development can be done in two settings. One is the academic center settings. The way we have been doing, we are developing some models, but then taking it the next level, making it commercially viable. You need to have a larger multi-center studies. So the best suited persons for those would be again like for drugs, pharma companies, or companies who are into AI-based models. So they will need to involve multiple centers, improve the sample size, have a more heterogeneous population rather than a homogeneous set of population. Say only 10 centers from India and they develop a model. It may not be applicable to say Caucasian population in US or Europe. So we need to have multiple wider centers to do this, and probably the best suited right now would be the private sector rather than any government sector.
Thanks.
And that's an interesting point raised, sir. I mean, like any study, there's internal validity and external validity. So when you come out with the commercialization of an AI tool, the people or the user need to understand on what data set has this been trained, what is the agreement with the the diagnostic or therapeutics, whatever the tool was devised on, and on the similar data set probably you can maybe deal with it, because there is domain the AI tools are domain sensitive. The moment you change the domain or shift the domain, the tools are going haywire. So that has to be understood by the users as well. So we are talking of AI, but AI will never replace the physicians or the surgeons, but AI will definitely delineate a physician or surgeon who knows AI vis-a-vis who does not know AI now. So that is going to be a era to watch and train ourselves.
That is where the role of regulatory authorities comes in.
Yep.
The regulations governing the use of AI models, they are very, very primitive right now. US FD has got some guidelines, Europe EMA has got some guidelines, but they need to be more refined, more stringent, and
obviously, sir. And probably ICMR is developing the data privacy rules. They are still in the phase of formulation, probably will have it this year. So if there are no more questions, we can call this session the day. Thank you. Thank you for both the speakers. It was a wonderful session, wonderful talk. Thank you so much.
Thank you to all our speakers and chairpersons for the enriching session.
Now I would request the chairpersons and our speakers to move to the selfie point for felicitation.
Now I would like to invite our honorable chairpersons onto a dais. Professor Vijaynath Mishra sir, Department of Neurology, IMS BHU, and Professor Anjali Rani ma'am, Department of Gynecology, IMS BHU, and Professor Deepak Gautam sir, Department of General Medicine, IMS BHU.
So after two very nice talks, we are in the next session. And our speaker is Dr. Harpreet Singh, who is a scientist G in Division of Developmental Research in the ICMR, professor, Faculty of Medical Sciences in Academy of Scientific and Innovative Research, New Delhi. And then his area of interest is digital health, artificial intelligence, and bioinformatics. He has several achievements. I think for paucity of time,
That's why I'm standing here.
your achievements, I mean, you yourself will be introducing through your talk. So please excuse me, sir. I'll
No
request you to please
problem.
go ahead with the talk.
That's why I came and before the introduction ends. Okay. So thank you very much for having me here. And I would like to start this presentation by giving some statements because I have been sitting here since 9 o'clock in the morning and I could see couple of apprehensions, couple of confusions about AI. So let me start with couple of statements and where I'm coming from. I have been working in this area since last 24 years in various capacities. I have been an active researcher and then I moved to program management. I managed a couple of very large programs of Indian Council of Medical Research, multicentric programs. And now I'm working in the area of LLMs because this is a very, talk of the town today. So I'm working in the area of security in LLMs, particularly the jailbreaks and all. Okay. So first statement that I would like to make here is that AI is a technology. It is not a domain. So as with every technology, it has both plus and minus. So it depends how we use this technology. So second is this digital health is a domain that I'm working in. And AI can have applications in various areas, whereas digital health can have AI as well as other applications, other technologies. So AI constitutes something like 80-90% of the digital health area, and then there are other technologies as well. Second is a very big statement. AI is not one single pill that can answer all the medical problems or that can address all the medical issues. AI is just a technology. We have to understand that. Third statement that I would like to make here is that as this American Association for Medical, American Medical Association, they have put up, they are reframing AI from artificial intelligence to augmented intelligence. So to emphasize that AI is not taking decisions autonomously, it is actually helping the clinicians. So in India, we have put up a paper where we are further taking it to the next level. We are saying that it is not AI, it is IA. AI is artificial intelligence, which is referred, but we are saying IA is intelligent assistant. So we are taking it to the next level that it is not just augmented intelligence or augmenting intelligence, it is the intelligent assistant that we have. And then, a morning I was listening to talk by doctor from Koita Institute, and he was talking, giving a very nice overview of the role of AI, use of AI, different technologies in radiology. We all should be optimistic, and in fact, many of the speakers have talked about it. We all should be very optimistic about the role of AI, but at the same time, we should also have a plan. So it is not that we can say that AI will, make robots and that robots will do surgery, but how those robots will be built, how those surgeries will be performed. There are a lot of things that we have to make plan for. And then, and then on top of that, as I mentioned, I'm working in the jailbreaking area. So there are a lot of security issues. What will happen if those robotic models are poisoned? What will happen if those robotic models are jailbreak? So those all things, they need a regulation, they need governance, proper mechanisms, which government is working on. Probably you must have read about this recent document that come up from PSA's office, Principal Scientific Advisor to the PM's office, about the AI governance. They have put up a framework, which is a very nice way of putting, and then India AI Mission is also putting a lot of such kind of documents. And another thing, why we should have strong these regulations, because AI is dealing with life. It is not dealing with our financial records. It is dealing with the life of individual. And then there is a very interesting development is DPDP Act, which we talked about a lot, but understanding is still limited. What DPDP Act is and what it is for. Previous speaker was talking about putting on a web server patient information, age, gender, and then all the vital parameters. Is it allowed in the DPDP Act? Because DPDP Act is mainly consent centric. Whether the patient has given you consent to put up all his parameters and his tests on that portal, and then allowed you to use his data to get in, because he is trusting you. He's not trusting the web portal. So that those are the things which we need to, look at. And one common theme that emerged was the requirement of data, quality of data and the requirement of data. And this is, I think, where we are very strong. In India, the kind of diversity we have, it's actually a very big advantage to us. So all AI that we can develop and we should develop is definitely going to make an impact in the coming years. So now let me coming to the presentation. These were some of the points that I've taken from the previous presentations. So as I said that I am from the Indian Council of Medical Research. So when I say digital health, why we should go in digital health? I think this slide is very common. You must have seen this slide everywhere. We have this three-tier healthcare system, and at every level we have shortage of trained manpower. So I would again rephrase this word. It is not shortage. We have skewed manpower. Majority of our manpower, expert doctors, they are mainly present in the urban areas. So there is scarcity of manpower in the rural areas. So how we can address this challenge? So when we designed our three-tier architecture, we designed in such a way that majority of the individual problems can be addressed at the primary level and very few should be referred at the tertiary level. But in actuality, what is happening is that our primary levels are highly underutilized, whereas our tertiary care facilities are overburdened. This is a picture taken from IMS. So digital health is a technology which can address this challenge, which can address or bridge this gap. These are some of the areas where digital health can make an impact. So I'll be just touching upon these areas. If anyone is interested, I'll be happy to talk more about it because I have been working in a couple of these areas. Smart telemedicine solutions is one area we should be working on. And a couple of Indian companies are already working on it. I'll tell you that. Digital markers and digital therapeutics. Therapeutics is particularly an area where we are not there right now. So we should be investing in that area. And then the personalized robotic assistant. So as put up by our honorable minister, India is going to see a huge investment in digital health area, particularly AI, because we have good number of engineers as well as we have good quality of data. Not quality, but diversity of data. Quality we need to improve. I'll come in a moment. In the VIKSIT Bharat master plan also, there is a very strong emphasis on use of digital technologies in health, particularly telemedicine, as well as there is a concept put in a VIKSIT Bharat master plan, the e-Ved or e-doctor. So government is also very aligned on using this digital technologies for health. Now, when I say AI, when we say digital health, the perspective for using AI by the developed nation and by the developing nation is different. Developed nation, what they are looking at is enhancing precision, efficiency, personalization, whereas what developed nation is looking to fill the gap of access, workforce, and primary diagnostics. Because screening is something that we are looking at, early diagnosis is something we are looking at. Again, this is for general understanding. When we say AI, we only look at the sensitivity, specificity, ROC, and couple of F1 recall score and all that as a measure of its success. But developing a AI is a complete life cycle in itself. These are steps which are involved in developing a good AI application. We generally focus only at internal and external validation. We don't look at clinical evaluation, trials, regulatory approvals, development integration. So I agree it involves multiple stakeholders, but as a doctor, you should be aware of these steps so that your application which you develop should go to the bedside. Sorry. So now coming to what, this is what my understanding about working in ICMR for a long time and then looking at the projects which are coming in different areas. These are some 6 areas that I think are very important for our Indian context and we should be working on it. And of course, cybersecurity is something that we should be all aware in the light of this DPDP Act. First one is this intelligent telemedicine solutions. You all know about eSanjeevani. It is a very nice application and it has given healthcare access to remote areas. how we can improve e-Sanjeevani or telemedicine solutions. Couple of areas where I can see is, AI assisted clinical notes. Patient is talking, doctor is talking. From this conversation, can we develop SOAP enabled notes, which is a standard procedure or standard protocol for taking notes? Few companies are already experimenting on it. So can we help, or can we be part of this what you call path that we are taking? Second is AI assisted clinical decision support system. This is a very important area, and we all know that clinical decision support system, what it is. eSanjeevani is trying to put up CDSS in the eSanjeevani portal to help doctors take a decision on what is this disease and how this disease is going to progress and all. Third very important challenge, which is for the engineers, because we have remote locations where connectivity is limited, how we can improve the transmission algorithms or the compression algorithms so that those images and all those data can be transmitted from low bandwidth areas. And you'll be surprised to know that when I started searching on papers in this area, I could only find one paper. So this is an area where Indian engineering institutions should be working very strongly in this area, and probably they are working, but they are not in connect with the health sector. So there we need to bridge that gap. And then as the previous speaker was showing images of AR, VR, that is also something which is close to reality. But how, again, the plan, the thing is there, but how we can integrate that? So this is a paper that we have put up in a journal which is in review on developing a framework for telemedicine 2.0, how we can integrate these technologies and come up with a smart, intelligent telemedicine solution, where we are using all this AR, VR, generative AI, robotics, blockchain, metaverse. This deepfake is a negative connotation word. So, but since there are no good alternatives available, we have used this. And then the smart sensors. Second thing we all talk about is availability of electronic health records. So there are different systems which are put up in different hospitals, and big agencies like NIC and CDAC, they have also developed their hospital information systems. The challenge was the record from one system was not communicating with the other. So their National Health Authority came into picture. They develop standards, they develop protocols, they develop guidelines, and one of the very important is this Universal Health Interface or Health Information Exchange. These are API-based mechanisms where these different systems can communicate in a standard way. The term that is called interoperable. So this things, CDAC is in the process of doing ABDM compliance. NIC is also in the process of doing AB. Once it is done, we'll have plethora of data. We'll have enough data. Then the challenge comes, how we can use this data to understand the disease. So there, are we ready for that? Because this integration is going to come in another 1 year or something. But are we ready for the next level, or we'll start thinking when this integration happens? So this is another area where we should be thinking. And then these are, two areas. One is this one and the next slide, which are of very close to me, because we are 1.4 billion individuals, and we have very good penetration of mobile and smartwatches, smartphones. These smartwatches, smartphones, mobiles, and various sensors, which even are put up in this room, they are capturing huge volumes of data. Huge volume of data is generated. Can we use this data to understand the disease? Can we use this data to understand why certain diseases are happening and what is happening at the patient level? So there again, we need a plan. And that plan needs to involve multiple stakeholders, not just individual doctors or engineers. It involves multiple stakeholders. There are some examples also which, yeah, I'm well in time, so probably I'll discuss that also. Digital therapeutics is another area where, you look at this Digital Therapeutics Alliance, this website, there is a alliance which has been formed. So, by definition, digital therapeutics is a software that can give intervention to the individual, that can give certain guidance to the individual on how to control that disease. So Digital Therapeutic Alliance contains applications from 7-8 countries, not from India. We are the largest producer of data. Can we be the largest producer of these software-based digital therapeutic applications? Majority of these applications are in the mental health area. I agree, because mental health, use CBD. There is something called cognitive behavioral therapy. And then there are a couple of other, I'm not very well versed with your terminologies, but then in the mental health area, like, anxiety consultations and all. So there are digital therapeutics available, and even the pain management and all there are. But can we develop these kind of applications from India, and using Indian patient data? And then, of course, we have to address challenges of our language barriers and challenges of our availability of internet and all. Imagining a doctor sitting at 100 kilometers apart and the robot doing operation is very good. But then if you look at the practical challenges, if 1 second delay happens or even 1 millisecond delay happens on the internet, what will happen to the patient? So those challenges we need to address before we make those technologies available. I'll come to that why I'm saying this statement. And infodemics is another very challenging area where we have to deal with it. There is a difference between misinformation and disinformation. Misinformation is when the individual do not know what he is talking about and is giving false information. But disinformation is when one intentionally give false information. How we can differentiate between mis and disinformation, and how we can address that. WHO has recognized this as a very important challenge. India AI mission is also looking at it very closely. How we can develop, collaborate with multiple stakeholders. Since I am coming from ICMR, how we can develop consortia and develop, what you call collaborative agreements to address this challenge with the engineering colleges. There are a lot of government initiatives. It will not be, feasible for me to put all those initiatives in this one slide, but very important couple I have put. India AI mission, which is hosting this Impact AI Summit in Delhi, and which is providing a huge compute capacity to all the researchers, because when you say AI, you need compute power, you need storage power, you need GPUs, and so compute capacity India AI mission is providing. And then the repository of data and models, trained models, and the repository of data sets, which is one of the challenge. So there are something like 9,000 data sets available, 9,500 plus on the AI Kosh repository. So which is, I think you all should see. And then Ayushman Digital Health Mission, Bharat Digital Health, ABDM, is also very good, what you call initiative by the government of India. And then IHIP is again going to be a very informative initiative by the government of India. And then a number of documents that we have published. So now coming to ICMR, from the Indian Council of Medical Research, we also recognized the importance of data and AI and digital health revolution long back. So we published this document in 2017, ICMR Strategic Plan Document 2030, where the second chapter of this document talks about rationalizing different data systems and developing an integrated research data platform. And details of which I can talk offline, I can share with you. And this, in alignment with that, we, before that the document was published, we started this data management laboratory in ICMR, because one of the major challenge doctors were facing was how to structure this data, how to make data portals, how to, data collection and analysis. So we developed this laboratory and provided professional level services to the doctors on developing data portals and data collection platforms. Using this laboratory, so this is something, a lesson that we have learned at ICMR. Using this laboratory, we helped 118 data systems we developed, and with the vision that all these data systems can be used for AI. And data systems we developed on COVID, AMR, mental health, various areas we developed data systems. But then the challenges with these data systems, standardized semantics and ontologies, most of these data systems were not using. Uniform data quality standards. Some doctor is taking picture on a 2 megapixel camera and another doctor taking picture on a 10 megapixel camera. AI is going to make a difference. And then the data integrity, sustainability, and translation. Finally, because I was having a meeting with this representative from Netherlands, and I was talking that 90% of our AI projects are not going to the clinics, and he was saying you are saying wrong. Not 90, 97% are not going. Only less than 3% are going into the clinics. So I would say why it is happening, we need to understand that. So a very bold statement is that not every digitized data set is AI ready. When we say that we have developed a database, a web portal, and our system is AI ready, it is not the case. So considering various definitions of a AI ready data set, there are many definitions we considered. We came up with this definition and we call it a gold standard data set, which is a AI ready data set that is accurate, representative, interoperable. So this is the definition that we put up. And using this definition, we initiated, morning doctor from Dr. Arpit was talking about this MIDAS program. We started this MIDAS program, which is a hub and spoke model program, where hubs are thematic areas and then spokes are which are putting up data onto it. And this MIDAS program has generated a lot of standardized documents, and the data is published in good journals. And I'll be happy to share with you that on the AI Kosh, which has 9,600 datasets, our MIDAS oral lesion dataset is trending at the second level and is second most downloaded dataset. In addition to that, we have also published various guidelines, ethical use of AI. And so since the paucity of time, I'll be running fast. There are various standards which are put up by the international agencies on reporting of AI, developing of AI, and the various life cycle of AI. So there are future AI, and then there is this consort AI if you want to do. So considering all that, we came up with the MIDAS 2.0, which is a quantitative measure of looking at the AI readiness of a dataset. So here we are looking at two major components, data quality and the privacy risk score, which has not been addressed in many of the metric or these frameworks that are coming up. So these are the 15 dimensions. I'll not go into each of this. Annotation is something that is, has been discussed, and we have put up a quantitative way how to look at the quality of annotation. Now, I think 2 slides are left, so I'll finish in time probably. So when we say that, we'll develop AI tools, we'll develop AI models, we'll develop AI, for whom we are developing these AI models? So we are going to develop these AI models for our rural population, because in urban, as my previous speaker was saying, we have doctors, we have experts. We may not use AI that desperately, but for rural population where the scarcity is there of the healthcare professionals, those are the individuals we are looking at. And then there is a difference between screening and diagnosis. So we'll be looking at more developing on the screening side of AI tools. So here, this is something that is close to my heart, and I'll be probably working in another for 5 years, next 5 years on this. Can we develop a fully automated primary health center? Right now, it is a fancy thing. It looks very fancy, but we have bits and pieces there. Can we integrate those bits and pieces to develop this fully automated where an individual just walks in, puts his ABA ID, his or her ABA ID, and then while he is moving through the corridor, his vitals or his various standard parameters, health parameters are captured, and then an AI model is giving a consultancy, and then automated machines for doing various basic level health parameter checks. So this is something that is a vision, but there are a lot of challenges in this vision, and we'll it's not that I'm not saying that this is something that will be very successful, because at the end of the day, the model that I'm showing may be very altogether different when it comes. When I say that there are bits and pieces of technology already available at various TRL levels, technology readiness levels. At TRL 9, we have temperature sensors, BP kiosks, ECG pads. So there are technologies. It's only that how we can integrate all these into a one beautiful ecosystem. And so I'll close this presentation, I think well in time, by quoting a modified version of what our honorable member Niti Aayog said about AI. So I'll say digital health leadership belongs to India. we would like India not only to become the biggest consumer of digital health technologies, but to the biggest creator of digital health tools. This is something that is feasible right now. We can do it. With these words, I thank you. Thank you.
Thank you, Dr. Harpreet. It was a wonderful talk. And over last 4 years till our this COVID went, and now we are presenting with AI. Probably that is one of the biggest thing which we have got innovated, and things have really changed during our COVID times. Certainly, we were the one of the premier institutes who were going for the rural healthcare, and one of our projects we say it oxygen ferry wala, where like you say ferry wala goes like डब्बा ले लो ये ले लो. So our team went for oxygen ले लो, oxygen check करा लो, and then we through the auto rickshaw, through motorcycles, we transferred the patients to ICU, and then one of the challenges was to screen and to diagnose and then treat. So Honorable PM sir also in his Man Ki Baat, he said that the one episode you remember, Jahan Bimar, Wahin Upchar. Yes. That was one, we started with that. Now with this AI, and especially that AI PHCs, probably that is one of the prime thing which probably our institute will also take the initiative. This part of India where we are sitting here, feeding to 26 crore population, especially from 8 states. So probably our institute should take one of the leading position with your this AI generated PSCs, and especially those the most remote area of the country, like after Sonbhadra in part of Bihar, Odisha, and so that is one very wonderful lecture, and we really appreciate your this talk. Thank you. Thank you, sir.
Thank you, sir. First of all, I congratulate you for the wonderful talk, and you have make all the terms very crystal clear. Like you are when we come for the MBBS for the first class, So this is very wonderful, and this if PHC model goes, like I think our country can do wonders. I think this can very well happen. We have existing primary health centers and this community health centers, and nowadays all they are equipped, well equipped. So I think this we can go and just lead the world like anything. This is like very wonderful model. I really congratulate to think like this. Like this will be the wonderful. Now, no people will then transfer from the village to the cities. That's why we are lacking, and everybody is coming to the cities. And the workload on the tertiary care center will also decrease, and the tertiary care center will do the work which is required by them. A very, very, how much I say less is more for you. Thank you.
Thank you. Thank you so much. A very nice talk indeed. A lot of good things that we learned, I have learned. So, but there are certain caveats I would like to just ask you. When we are thinking of a manless PHC, and at the same time, the legalities associated with AI say that ultimately it is the person who is responsible, and no way the AI or the software. I think what can be a way out when we are using a manless PHC? Because
So there are AI acts which have come, this European Union AI Act, and then you have this various states of US also coming up with their own acts and all versions of AI Act. So there is a paper in New England Journal of Medicine AI, NEJM AI, which talks about giving status of a AI based application equivalent to a doctor. They are saying there's a paper, and you can read about it. AI acts are challenged. The AI acts are not, what you call capable of addressing this kind of challenge. So you are right that when we implement AI at a PHC level where lives are at stake, there are two things. One, at the PHC level, what AI can do? What AI can give a basic consultancy, can do screening, and
yeah.
can do triaging. Refer patient to the next level. So we can deal with the sensitivity and specificity. And of course, we have to be very rigorous in doing that. But it is something that we need to do. Unless we don't do it, it will not happen. So we have to at least try. And as sir said, I'll be more than happy if this kind of proposal is developed at BHU and then put up at ICMR, and we'll be happy to see how the quality and the what you call readiness of that proposal. But it has to be comprehensive, looking at all the aspects.
Thank you so much, sir.
Hope I've answered your question.
Yeah, adequately.
Thank you.
Pardon, sir. I am Dr. Anand Kumar Rai from IMS Patna. Sir, in basic medicine or basic surgery, we have taught that first we have to take history, then examination, then investigation, then treatment. When we use AI or telemedicine, we have to overlook the examination part. Do you think that it is okay for the patient?
Sir, both plus and minus. Examination part, you see patient physically. That's what your
Yes,
question is,
yes, yes.
examination. I say that it is absolutely required, but only thing is if it is not feasible, if it is in remote location. I have been into places like Melaghat, where in a tribal community there is no doctor at 20 miles or 30 miles. What you will do?
Sir, do you think that this is ethical, sir?
I completely agree with you. So that is what I am saying. We have to be very rigorous in our evaluation procedures. We have to be very rigorous in compliance to various government regulations and guidelines. So compliance is separate part. That's what I'm saying. That is planning. But we should also have a vision that this is what we, because providing healthcare services to those people who are there in the remotest corners. Even you go 50 kilometers from this area, you will find that doctors are either not qualified, I would not say bad, not qualified to address those kind of problems which they are addressing.
Sir, if that particular doctor has particular degree, we assume that he should or she should examine the patient.
MBBS qualifying for
In
cancer and all.
MBBS final examination, the particular candidate has to examine the patient.
Just want to say, like if we go inside India, like I had done around 1,000 camps with the remote to remote areas. Like if you go to Mizoram Sunday, all the hospitals are closed. And if you go to the interior, I saw not even a one doctor, not even nurse is available. But at least the sir is saying like, this is like, the practicality is different, but the theoretical part is different, right? We know on the papers, this should be done, this should be done. But when you go to the interior, when there is nobody, at least if we have at least blood group test done, if we know the hemoglobin and that information, if we can pass, then can be a realistic. We want then, if the primary health centers become like this, then I think doctor will also start going like there, right? But but if you go to Kashmir, if you go to northeast part, not even one medical college. Practically there is nothing. They are managing their own. For that purpose, this model will definitely, it is not, you are saying correct, we are not against, but practicality is entirely different.
Sir, as my first Director General, under whom I served, Dr. Ganguly, N.K. Ganguly, he said that I fund 1,000 projects. If outcome come from even single project, I'll call it a day. So we have to try. See, this is something which looks feasible, at least on paper. So let's try and see if it works. If it doesn't work, that's all right. That's a research failure.
Thank you so much.
Yeah.
Thank you. So I'll request my senior and co-chair, Professor V.N. Mishra, sir, to please conduct this session. And I'd like to take and excuse both of us chairpersons and ask the organizing secretary to please replace us from someone else from the audience, because we have something very important. An exam is going on. Sorry for breaking the confidentiality, but I have to take the exam.
So, next speaker, it's a great honor to me to invite Dr. Vikas Kaushal, who is from Periwinkle Technologies Limited, and his area of interest is health system strengthening, primary health care, climate health, reproductive and women's health. Dr. Kaushal have received Bayer's Scholar Award 2022, Gate Institute Global Health Leadership Accelerator Award among 120 under 40, the new generation of leaders from John Hopkins and Bill Melinda Gates Institute for recognizing his leadership in global health innovation. He have also received the Certificate of Appreciation from State National Health Mission of Bihar and Uttar Pradesh for strengthening public health programs. He have been invited to global and national platform of IECFP, NASCOM, WHO consultations and AI for health initiatives. So welcome Dr. Vikas Kaushal, and it is great to learn that you are from international to Bihar, Uttar Pradesh, everywhere. So welcome here, sir.
So in the meanwhile, I will just request two chairpersons to please join the session. Dr. Sashi shall please join the session, and Dr. Lalit, both of you please join the session as a chairperson. Thank you so much.
Thank you so much, Chair, and good morning, everyone. Thank you, IMS BHU, for organizing
Welcome.
such a appropriate and relevant conference where the need and ask, as well as the vision to scale healthcare services up to scale. And I'm very grateful that I'm talking after Dr. Harpreet, which has set the context ki why technology should be not limited till development. We all know about regulations, R&D, clinical stakeholder engagements and all. But what about after deployment monitoring, and what about scale up? So I'll try to focus ki how technology may not about development. It should be about how we are going to use it till the last mile. And to a question, it wasn't asked, we don't have doctors at sub-center level. So we have approximately 1 lakh sub-center in this country. And as per IPHS norm, a sub-center don't have a doctor. A nurse and a CHO is running it. So we have people who have to go to health facilities where we don't have a medical MBBS doctor. So how we can capacitate our nursing staff or our frontline health workers to provide services till the last mile. Before starting it, I like to mention that I'm working with 2, 3 engagements, and one of my engagement is with Periwinkle Technologies. We have developed a device called Smart Scope, which primarily used to screen cervix. And it is not just giving information about the cervical cancer, it is giving a spectrum of information risk stratification wise. We'll discuss in detail. Just like to highlight that we have recently won MIT Solve Award by MIT USA. We got UNFPA Equalizer Award by UNFPA headquarters. We got Zayed Sustainability Award this year. It's a very recognized and reputed award from Middle East. And we won different challenges nationally and internationally in the tech based. And yesterday only, we got selected for Andhra Pradesh Health Tech Challenge. And day for tomorrow, I'm traveling to Vijayawada to install our device in Guntur Medical College. Yeah. So this is just a glimpse of our recognition. I'm not like boasting about our device or our technology. I'm just giving when a technology reach to the last mile, then only it get recognized and get rewarded. This year we got opportunity to last year, in fact, we got an opportunity to speak at UNGA, United Nations General Assembly. They like the concept ki how we are giving technology in the hands of frontline workers, not just confining on centralizing at a district level or a state headquarter or national headquarter. The priority, as Dr. Harpreet also mentioned, is to reach the last mile, and what we are trying right now for with our technology. So these are I just like to introduce Veena and Kaustubh. They are our co-founders. They are based in Pune. We have headquarters globally as well as nationally. We are sorry. Yeah, is it working? Yeah. So we have headquarters globally in Boston and in India and Pune. We are actively present in Africa and Asia. In Africa, we are in Cameroon, Malawi, and Ghana. While in Asia, we're in India, Nepal, and Sri Lanka. And we have a roadmap to go beyond these 2 continents into our next countries. We have FDA approval from US FDA K level, which is considered as a good affiliation from FDA. PDSU and ISO thing we have achieved. And then we have some 6 patent granted from USA, India, China, and Israel, and multiple publication from 2020 to 25. Let's talk about the global impact still now. So we were in R&D from 2021 to 2017. Then we went to regulatory processes, and post 2020, when the COVID thing was happening between us, we were trying to have a market access. So as per global impacts, we have screened more than 450,000 women across the globe, including India and African countries. And with this screening effort, we have tried to achieve or save life till 8,000 women. We are present right now in 900 plus health facilities and have trained more than 5,000 healthcare workers, including doctors, nurses, gynecologists, and oncogynecologists. Thank you. So just like to give a context of how cervical cancer is present among us or between us. So in India, if you'll see, the load is approximately 1,25,000 per year, which is 1/4 of global burden. So imagine India contributing 25% of global cervical case burden, and then we are contributing 1/3 to cervical deaths. That is approximately 78,000 per year. This is all given by ICMR, our national and data. While the prevalence is below 2%, and in some tribal and rural pocket, it is not merely 0.1% also. So the kind of screening which is supposed to happen to decrease this burden is not happening, and the roadmap or the pathway is very difficult for us to achieve. In terms of absolute numbers, I will say the second most common cancer in women. First is breast. But again, I'd like to differ here. We always try to focus on the cancer. We don't try to focus on the precancerous thing. If you are able to identify the precancerous thing, this whole mortality and morbidity indicators will automatically come down. So if you include precancerous in this cancerous thing, the numbers in absolute will be more than breast cancer, which is the number one cancer for women in India right now. The WHO strategy we all know about 90, 70, 90. 90 is about we have to immunize every adolescent who is in the age group given by national guidelines by HPV vaccination. I hope many of the states have given their uh, I will say roadmap of vaccination as well as the budget, and hopefully by next financial year government will be able to provide HPV vaccination for adults and girls. 70% women in the age group 35 to 45 needs to be screened, which I told you 2% are merely less than 2% in fact are getting screened for that, and 90% of women who are confirmed positive needs to be put on treatment, and put on treatment means the outcome should be life, not death. While the current scenario is the women who have been diagnosed and are put on treatment, 50% are dying. So this is the problem crisis which I'm trying to highlight is the complete. I'm trying to highlight now in the UP context since we are standing in UP. In absolute numbers, there's the cancer which has a maximum numbers here. Active cases 45,000 more than 45,000. Which is 14.4% of India's total cervical cancer burden. If we'll see per 1 lakh population, the rate of incidence is 13.48 and the rate of mortality is 7.79. In last 2 decades, if you'll see the reduction over decades in terms of cervical cancer, it's negligible. It means the kind of efforts which are required to decrease this incidence and mortality is not sufficient. We have to work a lot on it. The mortality, it's not a study, it's a report that has mentioned that 28 deaths are happening per day in UP. I'm still again repeating, it's not a study, it's a report. We have to validate it. Majority detected at stage 3 and 4. So there's a study which has indicated that if a woman is diagnosed at stage 3 and 4, the mortality is going to be 77%. And if she is going to be diagnosed at pre-cancer stage, the mortality is 7%, almost 1/10% of what mortality is happening when the diagnosis is happening at third and fourth stage. So late stage detection is the primary problem currently, as well as the screening, which we are not achieving majority. Screening coverage, if you'll see, rural is doing better in Uttar Pradesh than urban. I must agree that because of this comprehensive primary healthcare national program under Ayushman Bharat umbrella is doing some amazing job. I'm not saying it's doing perfect job, but it's still doing amazing job. That's why the rural is doing better than the urban because of for functional and operational our primary healthcare centers. As per NFHS 5, UP has merely 1.5% women who are in the age group of 30 to 60 are getting screened. And there is a regional disparity. If you see the district of Farrukhabad, which has screening rate of 0.1%, while the highest in Devariya, which is again nearby Varanasi, is 6.8%. So as per the WHO standard, we have seen that 70% women needs to screen. So if we have to calculate the gap, it is approximately 68.5%. So we have missed to screen 68.5% women from the state, which can only be achieved when we can bring screening at scale and if it can be done at the lowest primary healthcare centers. So just to give you a context, when as per IPHS norms and when health and wellness program has been launched, now it's called Arogya Mandir. So that time it was been asked that every PSC will have an extra nursing staff to do VIA, but I don't think we have still achieved it at even 2% of health facilities to dedicate a nursing staff to conduct VIA. So if we are not able to conduct that, we have to bring technology here to enable the screening efforts to achieve at least 50% of women get screened at the uh, in their age group when they are eligible for it. So in the current screening methods, the pap smear, VIA and HPV-DNA. We are using this three primarily screening methods. Well, the pap smear has a sensitivity of 50 to 70%, require lab test, multi-visit process. Sometimes it takes 14 plus days to get the results. And it also relies on cryopathology expertise, which again is very much confined in urban settings, not in the rural settings. Next comes to VIA. It's very subjective in interpretation. Variable accuracy from 53% to 80%, required trained personnel, and there is no digital documentation. I just like to give a gap here when the nurses or the doctors also who have been trained on VIA during the entire days of training, they are not able to see a real squamous junction with acetovite area. If in the training period, if I'm not able to see acetovite area in the squamous junction, how can I diagnose when it will come in real scenario? Then comes the HPV DNA testing. Of course, it's an expensive, thing, at least for LMIC like India. Limited availability in resource constrained setting required additional triage methods and long turnaround time. There is a one more development happening in HPV DNA. In India, at least 6 to 8% of cervical cancer are non-HPV. And this epidemiological shift and drift is going to increase in near decade for sure, because there is a study in Ghana which have mentioned that 14% of cervical cancer is non-HPV DNA dependent. So we can imagine in coming years how much it is going to be difficult when we are currently trying only for HPV vaccination and HPV DNA dependent testings. What are the other major implementation barrier? If you'll see, there's a workforce limitation. As I sir said, there's no shortage, but limitation. We have to work in a task sharing manner. A A&M or a medical officer or a specialist needs to shift their task, not just confining with one task. Geographical accessibility. Of course, we are living in a country which is so diverse in terms of geography. Where at one end we have Nagaland, tribal hills, and one land we have coastal islands. The loss to follow. I will explain it why this loss to follow is a major challenge in context of any kind of screening. I will say cost and infrastructure. When a woman comes for a screening, she's not coming alone. She's coming with a family, and there's a loss of wages thing in that. So if you calculate this, there's a cost as well as infrastructure barrier. So there's a need of point to care solution for screening and diagnostic both. And here we want to bring our innovation by a single visit approach to screening, diagnosis, and treatment. Yeah. So I was talking about how this loss to follow up is happening. So the leaky pathway right now, which we have obtained, or we are using in our system. If someone has to get screened, she has to first get herself registered. Then she has to go for sample collection. Then there will be a lab investigation, then report generation, referral pathways, and treatment. In this whole leaky pathway, 70% of our clients lost in between because they cannot come repeated times to these health facilities for repeated actions. If I have to divide the barrier categories, it are systemic and logistical barrier, workforce and quality, socio-cultural, economic, and programmatic gaps. If I have to deep dive into it, inadequate infrastructure at some of the health facilities for basic screening thing, we need privacy, examination table, a sterilizer to sterilize our cuscos or any speculum which we are using in our screening process. That is not available. Uh, self-development of legal iodine or STK is again a challenge because sometimes nurses have not been trained for it to prepare these solutions. Economic and access constraint. Of course, though we have a free test, but again, the indirect costs are more than the benefit of the test itself. Because the thing is, she has to come again and again for get herself tested, to get this report generated, and then collect it, and then go for confirmation at a higher health facility, be it CSC or DH, and most probably she has to go to DH to get it confirmed because again CSC don't have the capacity to confirm the suspect positives. Logistic attritions, again because of most of time, because of multiple follow-up, as I said, pap smear take 14 plus days. Centralized resources. So most of our services are either confined at a district headquarter, state headquarter, or national headquarter. That's why whole of the crowding is happening at these places, and the burden is coming back to DH state level bigger hospitals or national level bigger hospitals. Then comes the cultural policy and workforce gaps, so workforce expertise scarcity, policy and programmatic failures, subjectivity in interpretation and socio-cultural barriers. So how technology now can bring a solution for all these challenges. So subjectivity in VIA and colposcopy can be reduced by objective AI assessment. The centralized colposcopy lab, which are confined to a district or a state level thing, can be reduced or can be eliminated by point of care devices. Logistical delay because of multiple visits can be eliminated by immediate result and triaging, and workforce shortage, task sharing or task shifting with existing workforce can be tried or can be integrated. So here is a device which is we call it Smart Scope, which is again a technology plus integration of AI. It's a portable handheld device, compact in design, and it's basically a digital via Willy plus colposcope. It's a cloud-based AI assessment based on machine learning algorithm will analyze the images instantly and give you result. Color coded assessment. It gives color categorized assessment in 4 high risk categories. I will discuss about it. The color codes are green, amber, brown, and red. Green is for normal cervix, 6 to 70% as per the recent trend. We have screened 4,50,000. Amber is 18 to 25. It's not benign or precancerous. It's just an benign condition, infective one, which can be treated immediately that spot of time. And why it's very much required to treat amber or the benign condition, because we all know that if these benign conditions persist for a longer period of time, for years, it can convert into carcinoma. Then comes the brown. It's low grade lesion that can be immediately addressed. If there is suspect, a gynecologist or oncologist can give a cryoablation therapy if that is available at district hospital level. Then red, the high grade lesion is 4 to 5% that can be referred for confirmatory for biopsies. So clinical and logistical advantages is high accessibility. It can be accessed at a very lower level of subcenter. Standardized process, there's no chance of subjective error. Real time objective results. If you are screening the woman right away, she can be diagnosed or she can be get her result instantly, and someone is sitting at a district level or a medical college level can remotely review that findings and give his or her interpretation about the next step. It is suspect positive. So we did multiple clinical studies, NCD pilots, and multicentric evidences. We did small pilots to large pilots in state like Madhya Pradesh, Uttar Pradesh, Punjab, Manipur, Orissa, Chhattisgarh, and Jharkhand. Uh, we have 1,000 plus installation till date in 24 Indian states. We have also deployment in Lakshadweep. Uh, and just like to tell ki, we are working very closely with Nagaland AIDS Control Society. So we are screening every HIV positive woman in Nagaland to see the prevalence of CS cervix in HIV positive women. I think it was never been tried, but we are lucky that we got funded from UNFPA for that, and we are doing it. Then comes to clinical advantage. So we did many studies in that, but one study I just look to highlight here. From the Vidyapeeth study, the accuracy, if you compare with the traditional colposcopy, is 83.30%, while the traditional colposcopy 63.67%. Sensitivity is 83.33, is almost equal to colposcopy. Specificity is 83.33%, while positive likelihood ratio is 5%. So the last study result in number of 877, the accuracy was 84%, while the sensitivity was 90 and specificity was 73.3%. So we did national and international studies like in hospital like Safdarjung, AIMS Bhatinda, ICMR and ICPR, Dinanath Hospital India, and Cameroon and FPI India. So these are all studies which different sample size from 877 to 2500 to check our sensitivity, specificity in different population, different geography, different settings, both at primary, secondary, and tertiary. The recent publication which we achieved is about the accuracy of AI-based smart scope test as point of screening tool and automated assessment of digital images of uterine cervix capture with smart scope. So few validation findings are, it is comparable to colposcopy superior to PAP and VI in studies, and effective point of care triage, and it is very much feasible to integrate into primary healthcare system. This is the competitive advantage, which I'm not going to repeat because we are running out of time. As per our study, again, we have achieved the 30% threshold time, which make us economically cost effective to get integrated in country like LMIC, especially in the context of primary healthcare system. And traditional approach versus smart scopus approach, it requires minimal training. The ANMs which we have trained just received 1 day of training, and the very next day they started screening of CS. Then 40% reduction in tertiary referrals. What we want to achieve, that our higher facility should not be going overburdened. So if you are trying to screen at the very lowest level, the overburdening of the higher facilities like BHU, which is overwhelmed with the number of clients and patients. So patient management protocol, we are giving a first-hand counseling through community mobilization or in person on the spot, capturing the images through the device, at least 6 to 7 images, normal, pre-via, post-via, pre-Willy, post-Willy, and then green light to check the vascularity. And based on this all captured images, the AI will give an interpretation that needs to be get. Sometimes when there's red and brown, then we are keeping human in loop. So responsible AI means you have to always keep human in loop. Then only we can call it a responsible AI. And that's why for every suspect positive client, we are involving our gynecologist or oncologist who are present at the facility. That's very best. If she or he is not present, he or she can review from a distant wherever medical college or a national institution. So after screening, if she's green, she can go back and she can come back after 3 to 5 years based on the state protocol of rescreening. Then treat if she's been diagnosed for amber condition, like benign condition, infective conditions, and if she's been suspected for brown and red, she's been referred for review by a gynec or onc. So this is how this device works. I just like to give you a snapshot of it. We have dashboard services for a larger population information service, pilots. So how it works, we trained our healthcare workers on selected scope, which can be done instantly in 1 day. Remote expert reviews, where the flagged suspect cases are been shared and they instantly give their verdict or their comments on that. The healthcare centers refer the flagged patient to the tertiary center, and the dashboard shows impact metric on the web. So these are our experts, Dr. Sarita from VMMC Delhi, Dr. Leela from Homi Bhabha Cancer Institute, Hyderabad, Dr. Bhavya from Cancer Institute, Cuttack, Dr. Nikhil from Aditya Birla Memorial Hospital, Pune, Dr. Veena from Dinanath Mangeshkar, Dr. Kavita from ICMA, Dr. Manju from Bharti Hospital and Medical College, Pune, and Dr. Lavya from All India Institute of Medical Science, Batinda. These are our, like we received some kind of feedbacks from our stakeholders. So why Smart Scope? It can be used as a primary screening, remote confirmatory assessment, short TAT. Large amount of cross-sectional data from India and Africa for training and validation testing we have. Reliable AI due to control on data quality and clinical validation in multicentric India international studies. Sometimes we said that data has been owned by an institution or by a state. I like to mention that data is first owned by the client himself or herself. The data first primarily belong to the client, then comes that we have authority to use the data. So sir rightly said that the data, someone was showing the web portals, the age, sex and comorbidities, that should not be displayed. So that's why we are ABDM compliant, and whenever there's a scope to integrate, we are ready to integrate that. So benefit of women, available near homes, hence no hassle. Very little time in the day needed. All gynecologists health issue addressed. So we're not just addressing the CA thing, we're also addressing precancerous thing, which has a potential to get converted into carcinoma. So we try to address then and there only, so that the woman don't have to go in the cancer stage. And then she also can get straight for the benign condition, which has again a potential to get converted into carcinoma in the longer period of time. Less expensive and better prognosis. Yeah, so in Uttar Pradesh, just like I give a snapshot, we are working at currently 11 health facilities in districts like Mathura, Bahraich, Sonbhadra, in a CHC named Mayurpur, Ayodhya and Gorakhpur, And by next week, we are going to have 5 more operational facilities in Noida district. So till now, we have did our this thing in 9 states with 63 facilities. These all are pilot initiatives. Our clients are also from like Manipal Hospital and others medical colleges. I also like to GIMS is the medical colleges with whom we are attached, or we are working very closely on grants and research proposals. Uh, yeah, the private hospitals we are working in government hospitals, medical colleges, and NGOs. The medical colleges in Chandigarh, Chhattisgarh, Odisha, Chandigarh, Mizoram, West Bengal, Assam, Delhi, and Himachal Pradesh. So we got a very good response from all these medical colleges. These medical colleges are using the device for their hospital setting as well as camp settings. So these are the name of medical colleges with whom we are working in different states, like in Punjab, GNP Chandigarh, Odisha, Acharya Harihar Postgraduate Institute of Cancer, Chhattisgarh, Bhimrao Ambedkar Medical College. Okay, so the opportunity for us is how we can integrate this AI-enabled handheld device and can give into the hands of frontline workers to achieve what we want to achieve, especially in context of screening every woman who is eligible for screening, and that fits in the age group of 30 to 65 as per National Program of Prevention of Non-Communicable Diseases. Thank you.
Thank you, Mr. Vikas. It's a good idea, good smart scope. Though I am a urologist, but I have few comments to make. You have mentioned in the screening of cervical cancers. In screening of cervical cancer, there are well-established methods like Pap smear. Especially Pap smear, I will say, rather than HPV testing, it's very cost-effective. Where your device stand here? Secondly, how you have compared with the standards that is colposcopy. You should have compared with the Pap smear also. Thirdly, you have mentioned the validation in 18 patients in Vidyapeeth study. The 18 patients you have mentioned, but at other centers, your trials are ongoing. So how you have validated your instrument regarding efficacy? Have you done the control group based on the imaging like we do in the urology? Based on the cystoscopy images, we diagnose the bladder cancers. So have you done the biopsy for the control where you have mentioned whether it's a normal patient, it's a cervical cancer, or it's a precancerous condition?
Very question. Sure. So that was one sample. Otherwise, we have did multiple studies with medical college. Hello. Yeah, with multiple medical colleges, and we have did this comparative study with case and control both, where the smart scope is used. One in slide I tried to mention about the false positive one, where the 40% reduction happened because of use of smart scope, where the clients who were not positive were been suspect positive and they've been referred to the higher facilities. We Pap smear, so if you see the sensitivity and specificity, Pap smear lies very below, very low. So, these days, even clinicians are, I mean, who are gynecologists, who are not preferring with colposcope. Colposcope is good, of course, but it has to be done by a gynecologist. And we have a gynecologist at DH. Even at CSC, we don't have a gynecologist. But if you want to do it at a lower level, you have to, I mean, we can use these kind of devices where a gynecologist can review if they suspect positive, because it has a basic principle of VIA Willi plus colposcope both.
So what is the cost of this device? Will it be cost effective to install at PHC?
Yes, sir. So we are approximately in Chhattisgarh and UP file club. It is approximately 35 of PSCs we have installed, and it's cost effective that, and it's very much cost effective. The cost negotiation I cannot, I mean, discuss it right away, but we can anytime discuss in other table.
Thank you, Dr. Vikas. Nice work. We are running short of time, so we'll have to close this session. Thank you all the
Can
speakers.
I ask a question?
Sure.
So I want to ask how many patients we can screen for this device, single device. Is there any limit?
No, I mean, in one day, if you see 7 minutes is a turnaround time for one client. And if you'll see the working hours, 8 hours, if I'll see it's working hour, we can, on an average from counseling, post-counseling, 25 to 30 clients, we can easily do in one day. But if you have a person, one who is doing registration, one is doing counseling, we have reached till 55 to 60 also in just one day in camp settings.
Okay. And is there any additional benefit if we combine this screening test with HPV DNA test? Is there any study published on this?
we have co-testing thing study we haven't did, but we have been asked if we can do something. I can say there's an additional benefit out of it, because HPV testing, if a client is positive, you might know about the lesion. Then you have to again go for the colposcope or smart scope like devices to screen, because HPV testing doesn't mean that there is a lesion there. You have to go for colposcope or any kind of visionary or visualization techniques.
And sir, आपने cost नहीं बताया. We really want to know.
Ma'am, sorry to intervene. I think Dr. Vikas can take more questions during lunchtime.
Sure.
So we'll have to go forward. Thank
Sorry,
you.
sir, one question.
Sir, please, we are running short of time. You can ask personally to Dr. Vikas. Please move to the next session.
Thank you to our speakers and the chairpersons for this wonderful session. Now, I would request the chairperson and our speakers to move to the selfie point for the felicitation. Session.
Now I would like to. Let us now proceed to the next scientific session. Now I would like to invite our honorable chairpersons to the dais. Professor Seema Khanna ma'am, Department of General Surgery, IMS BHU. And Professor Sangeeta Rai ma'am, HOD, Department of Gynecology. And Professor Tuhina Banerjee, sir, HOD, Department of Microbiology.
Again.
So, moving on to the next session, I welcome our next expert, Dr. Uma Sinha. She is already there at the podium. She is the alumni of BHU, and at present, she is director and clinical lead gynecological robotics surgeon at Apollo Group of Hospitals and Honorable Professor Apollo and Macquarie University, Australia. And she is an expert in robotic and laparoscopic surgery in benign gynecology, fibroids, and endometriosis. There are many achievements to her. She is a founder of President Association of Gynae Robotic Surgeon of India, AGRS, President Asian Society of Gynecological Robotic Surgeon, Joint Secretary, Endometriosis Society of India, and she is a fellowship director, Verticuity and Intuitive Robotic Fellowship and Minimal Assets. She has more than 71 publications with more than 350 citations and performed 1,000 plus robotic surgeries, largest series in India. So I welcome Madam for her next talk on AI in laparoscopic and robotic surgery.
Thank you. I should say respected chairpersons, but I'd say Seema, Tuhina, and Sangeeta, thank you for inviting me and the directors up and the uh, organizing team of this artificial intelligence group here today. Really honored, and it can be nothing better than coming back to your alma mater to speak. This morning, when I just opened the newspaper, I found this. And I felt that this is exactly the right platform to talk about the intelligent OT. I bring you greetings from Hyderabad. And Hyderabad is something that we all remember as Charminar. But don't forget that it's a very fast moving city today where a lot of IT backup happens. So we are integrating that in our operating room as well. These are my financial disclosures. I came from the city, from the banks of River Ganges, and Shushruth was, in 6th century BC, the surgeon to be looked after. It is always my pleasure that wherever I travel, whether it is in Melbourne, to Manipal Institute, to the chapel in CMC Vellore, or our own institute here in IMS, we found Shushruth's photograph or statue, and this really makes me proud that we are finally recognizing our heritage. So this was the gate. And today, again, when I drove in, I had the same feeling I had in 1985 when I walked in. That's the institute where I learned my surgery. And as Sangeeta mentioned, has been a long journey since I passed out in 1993 to go ahead and establish the Association of Gynae Robotic Surgery of India, and also now today become the president for the Asian Society. This was the surgery I used to do in 1994, immediately as I passed out. A large cervical fibroid being done with open surgery. And that's the surgery I do now today with robotic surgery. Disease did not change, the woman did not change, but the technology has changed. And that is what makes our OT today an intelligent OT, which is giving the benefit of minimal access surgery to women. My robotic journey started in 2012, where by that time I had actually trained myself a very hardcore laparoscopic surgeon, and I felt I could do most of my surgery laparoscopically. But I was introduced to this monstrous machine, and I said, what am I going to do with this? And there began the journey for new frontiers. And today that's what is the basis of my talk in surgery and how we are using these new frontiers for training. But let us begin the intelligent OT with the decision making. And large language model, patients are using that themselves. So we did our own analysis and we published this paper on large language model where we gave 8 scenarios of fibroid uterus to ChatGPT and the Google Bard to see whether they came up with right information of how to manage. If you look at the results of this study, we found that in the first attempt, a general answer was about 62.5% and a specific answer came in just 37%. But as we know in these large language models, the prompts are very important. So if you give the right prompts, they give the right answers. So by the third prompt, we could actually improve the sensitivity to 62%, but still not 100%. So we can't still base our diagnosis just on ChatGPT. And the Google Bard was actually not as efficient as ChatGPT. So we then moved on to how to use this in preoperative assessment. This is something which I have been working on, where we work with MRI DICOM images in fibroid uterus, convert them into a model. This is a small clip from a press meet that we were doing. And this is a small model that talks about that this patient had so many fibroids, about 13 to 14 fibroids, and that's how we diagnose. So we do a 3D printing, and this gives us help to counsel the patients as well, make them understand the burden of the disease, and that's what we do. We went ahead and did a robotic surgery for this patient, actually went ahead and also published this case with a digital model, and very proud coming from this institute, this actually featured on the cover page of this journal, which is an international journal. So this is what is actually augmented reality. We don't have this at the moment. I'm just giving you a glimpse of what it is. So in our robotic platform, we should be able to integrate these images as we are operating so they come into our view. But this is what the model we get right now in our doing preoperative assessment. So we calculate, we isolate, we identify in 3D vision, where are the fibroids and how do we get. That's the integration that we are actually looking at and working on it. We have tried to integrate this model in endometriosis as well, which is one of the toughest surgeries to do, and look at can we predict this, the bowel adhesions, how deep are those nodules before we operate. We worked on some of those models, but haven't yet reached the standard operative procedure where we can actually go ahead and make it into a usable large language module for patients to use. The next, what we use as a preoperative surgical trial. And this is one project I did with University of Ottawa, where we actually used the DICOM images and created a 3D virtual assessment of the patient. And this, as a surgeon, I can sit with my Meta headset glasses and do a virtual surgery, know where exactly my nodule is, where are my structures around it, what are my neighboring structures, how am I going to prevent damage to those structures, and go ahead and do it. This is a small video of the same surgery, which is being done in virtual reality. But then when I'm doing it with my robotic surgery, is a large parametrial endometriotic nodule, which was identified in that, and then went ahead and successfully, safely done it for the patient, also went ahead and published this case for us. So this is how we are trying to use this in day-to-day practice. What are these smart, intelligent things in the OT, which I today use as my intraoperative interventions? Let's start with fluorescence guidance. I think Dr. Trivedi also spoke about it. And this fluorescence that we use is nothing new. It was used for photography by Kodak in 1955 and actually FDA approved in 1959. But we now have a Da Vinci platform, which is Firefly technology, which we are able to use. So it brights up my screen like this. It gives me a green light of the ureter whenever I'm operating. And that's how I can safeguard this structure in my difficult surgeries. So you can look at these surgeries which we are trying to do in multiple situations. So there is a simple robotic hysterectomy, but the lower two visions can actually show you that in this deep stage 4 endometriosis, the ureters are deeply burnt, deeply depth in the fibrosis. And that's how I identify every time I'm operating. Either am I doing a periodonectomy or I'm taking the IP ligament and I'm trying to identify this structure, which probably with the skilled eye with multiple years of experience also can miss. And there can be either a direct injury or can be a delayed thermal injury if I don't take care of it. But believe me, it is not, the ICG fluorescence is just not for robotic platform. It is also available in our operating room with the laparoscopic platform also. This is the Stryker 1688 system in which the fluorescence is actually seen beautifully. This is a large cervical fibroid where we first ended up putting the ureters fluorescence ICG and then went ahead and performed the surgery. We are trying to modify this to use it also to identify our bladder in patients of previous cesarean sections to do safe dissection of the bladder, so that bladder injury is also one of the commonest injuries that we find in women. We have also used this technology to also identify our colpotomy, because sometimes we have difficult cases where colpotomy may be very difficult and we wouldn't know where is a cervicovaginal junction, and we have used this technology to actually benefit patients with that. We also use the fluorescence guide in a very unusual situation, and that is the isthmocele repair, because sometimes identifying the defect, repairing it can be difficult. So this is not a dye. This is, we are using just the endoscopic light to give the fluorescence, as we would see, and that's again the firefly in operating room. So these intelligent operating room interventions are already there. But when we use technology so much, this is the question as a teacher I ask sometimes, are we getting too dependent to this anatomy? Will our future surgeons will be dependent on these technologies? Like somebody also asked whether we can open up a surgeon and finish a patient with has a complication. So I think learning surgery, the anatomy hall here, don't forget that is really very, very important to go ahead and do it. Other intraoperative image assistance that we normally do now is a Tile Pro technology. If you look at the small vision under the console, is a DICOM MRI images which are running through in various segments like sagittal, axial, coronal. And I'm trying to identify my fibroids while I'm operating, looking at. So this is my screen that I see when I'm operating, but I also have the MRI images running down very clearly. So I can in real time identify where are my fibroids, what have I removed, what am I going to do next, and then identify. I can also in the same way use an intraoperative ultrasound probe, which is that you can see, which can be easily handled by my robotic instruments. And then I see, and I get the real-time image of the ultrasound on my console. So there is a direct correlation. I don't have to see on any other screen. And that's what is we call as Tile Pro technology. This is the operating room setup. That is not the future for us. It's actually our operating room for almost 13, 14 years, but we can say that it's a kind of future. This is how it looks. These are the masters that we are working on, the console, and you can see the vision of the operating room as we move from the console to the patient. These are the foot switch, which has electrosurgery, which has the camera pedal, which has everything like as if you are driving a car. And these are the masters you can use actually. And that's my touch pad where I can change everything to be able to operate. These are the real magic, and that's the masters that you can use. But physics meets biology these days in our operating room. And the pulley and the fulcrum effect of these instruments actually make things better. This is where we actually talk. That's Dr. Fred Moll, who actually was the beginner who started this idea about robotic surgery with Intuitive Surgical. He's no longer Intuitive Surgical. And that's Dr. Edwin Kula from Columbia University, who actually propagated this in gynecology, and probably one of my inspiration and mentors as well. So these are two gentlemen I feel has been improving our missing link. We did our surgery with wrist when we did open surgery. We missed those wrists when we did laparoscopic. And that's the missing link was brought back by robotic surgery. And you can see the rotation of the instruments, and you can find that we just can't get this movement when we do a laparoscopic surgery. These dissections then gave me the benefit of doing a zoomed surgery. So we can zoom into this. You can see this is no fluorescence used, but you can still see ureter very, very clearly to do the dissection. You can actually identify your hypogastric nerves in the pelvis in stage 4 endometriosis because of the benefit of a 3D stereoscopic vision and of course zooming and doing a precise surgery. We also can use a third arm, and that's no future at all. So imagine yourself as having 3 arms while doing surgery, not 2. So this is what you can see in many of these small videos that I have clipped for the audience benefit, where you can actually see a third arm is coming in. Here you can find that third arm is holding my cyst wall while the other 2 are operating. And I can, with a swap of my foot, I can actually change which arm becomes active. And that's how I can actually go ahead and look at that bladder dissection which you are doing. Actually, that arm is holding my bladder for me to dissect in the right plane. I don't need an assistant there. Sometimes in a troubleful situation, like when you get a lot of bleeding, a third arm can come in as assistance to hold your bleeder, to give you that breathing space for a minute, to identify and then make a plan of how you're going to salvage that situation. So a third arm becomes very, very useful when we use the robotic platform. It can also give me an advantage of using almost human hand-like movements inside the patient without actually using the patient. That's what I call hugging the uterus. When we have a very large specimen, we need to move from one end to the other. We literally hug the instruments and go ahead from the one. We also use those 2 instruments to just lift. And believe me, I never imagined that with these instruments, I can do this. And actually with those masters that you saw, actually lift the whole uterus and go into the posterior fornix. I can actually also use those instruments like my hand to retract tissues. So I don't need something which is not human hand-like. And of course, sometimes do a little dance like a salsa, where the 2 instruments can actually work in tandem very, very closely to be able to do this. This is a program by Da Vinci where we talk about augmenting the images into our surgical field. This was a little bit touched by Dr. Trivedi as well. And that's what you can see while operating in the console. You have a small screen where you get the complete digital twin of the organ that you are about to operate. But what we really need in augmentation is this. This is a car which I drive. It's a Volvo V40, and it gives me a automatic brake if there is somebody. And it shows auto braking was enabled in the city. So if there's something comes and I have not braked, that car will brake itself. And that's what we need in surgery, that if I'm near a nerve or a ureter about to damage, they say, wait, there's a ureter there. So that's what we are looking at with augmented reality. So we started with freehand surgery. We moved into minimal access. We are at robotic surgery. This is where we are. And of course, we are talking about a fully automated surgery to say, hey Siri, perform a type 3 hysterectomy today. But watch out for that ureter. You should not damage that. We also get some of these uh, information or some news item that a small part of the surgery was automatically done, maybe a suturing was done, but we are far away from doing the whole surgery. We are far away from working from home. But yes, with a console, probably today I can, because there is a team in the operating room which can do the rest, and I can sit in my home and work on the console and operate the whole case. So there we are reaching there, and these are all these various parts of the intelligent system that we are talking about. Force sensing, because we know how much Newton of force will we apply on the tissue. We get a haptic feedback of what tissue are we touching right now. We get wearable eyeglasses, which will integrate or augment my images onto my screen while I'm operating. We can give how much my electrosurgery is giving the heat. What is the pressure I'm applying? What electrosurgery is the best at this point? How do I use all this data with all of them to do the best part that I'm about to do? So this is the first part that I wanted to talk about of what we are already doing and what we can do. But how do we train our surgeons is what I've been talking about. Now, how do you understand a surgical process? We have a domain knowledge. We have a visualizing of the surgery where we need to know, understand the anatomy and understand the steps. But live surgical workshop are very much, but they hardly ever equip a student sitting in the audience to go and perform that. Because it is something very difficult. A very experienced surgeons performing looks easy on the screen, but when you are seeing that patient, it doesn't look that easy. So learning the art of surgery can be like a guru shishya, or can be like Sushruti used to teach, one-to-one, or it could be where you can use various technologies. So Hindestian principle of doing apprentice model of seeing one, doing one, teaching one is probably no longer valid. And I think our patients also don't deserve it. So how do we do about it? There are a lot of advancement. So laparoscopic surgery showed us a way that when we operate, 10 people can observe. So you can learn by observation. But how do you do on your own way when you want to do this? So when you don't do simulation, when you don't practice surgery, surgical errors increase. We also can do remote learning, which I'll be just coming in a moment. But we did some remote learning with Eklavya many years ago. I mean, he was never next to his teacher. He was learning from a distance. And that's what we are trying to do this. So the telepresence to tele-remote surgery is what we are talking about. What we do today is telepresence. That means we are present in the operating room. What we want to do is tele-remote, where I'm somewhere else and somebody else is somewhere else. So we are trying to develop technology. In fact, there are two technologies I'm going to talk about, which can enable me to connect to the BHOT. And if you're operating, I can either guide you through the screen in front of me, or if we are connected, the two consoles are connected through a 5G, I can take over your surgery for 5 minutes or 10 minutes, do a particular step and then give it back to you. And that's something we do often. If we have a difficulty, we cross a cross consultation with a different department, right? We can do that over miles. And that is what will make a difference to that whole thing. So the two technology I'm going to talk about is one is Intuitive Hub, that is by Intuitive Surgical, the Da Vinci people. And this is a hub which has a screen which can get transmitted to another OT miles apart. And the doctor sitting on the other OT either can learn or demonstrate. And then you can actually annotate and tell them, okay, this is the right plane to cut. You can cut here instead of being there. We have a similar sitter, which an Indian company called Univlabs is also developing called CSM. And this is also has the ability to connect the ORs across the country, across the continents. Because we can do live surgeries, we can do telementoring, we can do multi-role access. And of course, recording and broadcasting is again an important part of teaching. We don't want all surgeons to be just YouTube surgeons. It's good to watch YouTube videos, but you are watching a robotic surgery if you're watching in 2D. You are not getting the same depth perception as you should get it. And as because even when a robotic surgery in the OT is going on, the rest of them are watching them on a, you should be watching on a 3D beta glasses, which we have now started doing in our hospital, where we have now recorded our surgeries in 3D. And we run this program where we teach students with a virtual reality meta headset, where they get the depth perception exactly in the same way as I was seeing through the console. This is something where the concept came to me. I have worked with a startup company in Hyderabad. We built up a platform and we teach small batches of students with this gentleman. He owns that Deep Blue platform. And they created this platform for us where we use the meta headset for doctors to sit like this in an operating, in a room, and they're watching the surgeries exactly like they would have watched. It's just through an intranet where they all get connected to the same 5G, and they can see, and you can see I'm just guiding them, talking to them. They're all watching the surgery as if they were seeing on a 3D console for themselves. So these 3D recorded, I also gave a demonstration of the same thing, which was very well appreciated at Melbourne in the Society of Robotic Surgery meeting, where we talked about how we can use this technology to teach. So once we come to this concept of using virtual reality in technology and surgical teaching, we can actually use virtual reality for depiction of diseases, where I talked about 3D orientation of the disease, 3D virtual surgery of the disease before you go in, or using these 3D virtual reality videos to teach. So a lot of applications of virtual reality can come in my operating room or in my teaching modules. Limitations, we know that when you use a virtual reality headset, you get cut off from the actual where you are. So that is where the augmented glasses may be better, where you can see the virtual reality, but you can also see what's happening in the theater. So we may move into that space very soon. But what we need in intelligent OT is these 5 things. Number 1, precision. I think we as surgeons want it and need to do it. The surgery should be precise. Then we should have intraoperative guidance of what disease we are dealing with. How much is the disease? Where is my clear margin? It could be either with one of those, either MRI augmented images or a twin of the organ or something of that sort. Then we should have safety so that we are able to do safe surgery, preventing any damage to the neighboring organs or any other organ that we don't want to damage. Then we should be able to learn by using this technology, which could be simulation or it could be some kind of thing that we are adding to our learning armamentarium. And last is the insight. This is a concept which I'll just talk to you, where we use a lot of data today. And data, as you know, is the new gold or the new oil. When we use data, we collect data over many surgeries. It could be my own surgeries, it could be surgery for all of us, and that data can tell us which step is actually making a difference in the outcome. So when we use this data, it could be multiple ways. We use the data when we use which surgery, how much time it took, what procedures we use, what instruments we use, and how did we use this data to actually make the surgery next one safer than that. So there are three in this loop. We collect the data, we get into the insights that what the data is telling me, and then take an action during my surgery based on that. So supposing you are doing a cholecystectomy and you are not sure whether this is the right duct to cut, the insight of maybe 10,000 surgeries can actually come and brighten up your screen and say, okay, this is the right duct. Go ahead. And that's where a junior doctor will really get a benefit with it. Just like the sports people use their data to advance their disease and their game by analyzing the data. This is what Dr. Trivedi spoke about, but the slide that I want to show you is how this data can tell you. This is steps from radical prostatectomy, but you can see how the expert and the novice, the dominant hand and the non-dominant hand are moving. So the experts' movements are so precise, but look at the novice's movement, and that's what they can see and learn and improve. This is my own data from a My Intuitive hub. So My Intuitive app can tell me where, at what point in my surgery, this is a robotic myomectomy going on with endometriosis section, and I can see which instruments at what time did I use, what instruments were just lying in some side and I did not use, and I can make my surgeries then more effective. When surgeons are trained in virtual reality, the number of surgical errors also come down, and that is the beauty. All these technologies are entering our theater. It's just like the Industrial Revolution. We were weaving our clothes, but the Industrial Revolution came and the clothes started getting made in factories. We adapted, we became better. We still love our artisans. Banaras is full of them, but we cannot deny the clothes that are coming from the factories as well. So we can't get left behind. And that is where the technology actually needs to be integrated. Soon, the OTs are going to become like the tower at the airport. The operating room is like a control room, the 2D, 3D inputs that we are doing, the pre-operative, all gets integrated into one, and the tower can actually guide you if you are about to crash and make a mistake and tell you don't land there. The one interesting thing which is not there, our hospital is actually contemplating to talk about it, is operating room black box. These are something which can actually collect, record surgical performance. So it can not just collect your mistakes and improvement, but it can also improve your efficiency. It can tell you what happened between two cases, that it took 1 hour for one patient to get out and the other got shifted in. That's OT efficiency. And I think where I come from, every minute in the OT matters, it's money. And I have to be efficient. So I think many of these can come back and where we can discuss. So the future of OT is digital surgery. Actually, the applications are unimaginable. Robotic platforms are going to be a reality in some way or the other in every OR, as I see it, not more than 5 or 10 years. We need to integrate it into our modalities by augmented reality, virtual reality, improving our surgical efficiency. So responsible deployment of this technology is very important. I think we need to be responsible about it. Healthcare is evolving technology, so should our operating rooms. Patients deserve safe and effective care, and every surgeon also deserves access to proper instruments, expertise, and insights. Thank you so much. I'm future ready with the support of my two very, very small, strong pillars of support. Akanksha is here. Sanjay is busy, but thank you so much.
Yeah, one question allowed.
Okay. First of all, congratulations, ma'am, for bringing this topic to here. My name is Dr. Pradeep Chauhan. I am Associate Professor of Anatomy in AIMS Rajkot. And in our institute, we develop our own virtual interactive 3D replica of prosected specimen and teach our students to dissect on them in the virtual reality platform. Uh, I'm well versed about this technology. You mentioned that in this technology, one of the haptic feedback that you can know that what type of tissue is that. But according to my knowledge, till the date, haptic feedback has not evolved to the extent that we cannot understand whether we are touching the artery, vein, or nerves. So maybe I am missing something.
You are very right. I was not talking about haptic feedback in virtual reality. I think that is not there at all. You cannot make out what tissue you are touching. I was talking about haptic feedback in robotic platform. When we do a surgery, at the moment, whatever platform we are using XI, which is the 4th generation, still doesn't have so-called haptic feedback. But the new generation of DE5 has a force feedback mechanism.
That is
Yes, so
proprioception. I think that is the proprioception is there, but touch and texture feedback is not.
Not yet, not yet. But the same actually is true for laparoscopy as well.
Yes.
You don't touch tissues with your finger, right?
Yes. But ma'am, in our anatomy, whenever I present this in our conference, there is always a question. आपको कैसे पता चलेगा कि artery है vein है? Yes.
And that is true. So the original thing also remains.
Yes, ma'am.
But there is paucity of resources. And I know in anatomy, there is paucity of cadavers.
Yes.
So we cannot provide that way we used to have cadavers when we were students. Now students' number have increased, cadavers have reduced, but we have to still teach anatomy. Thank you. Yeah,
What's your take on telesurgery? Because telesurgery, there are no unified guidelines.
Yes.
Whether we talk about our India or even there are transcontinental telesurgery going on. So rules are different in India, rules are different in USA. If something happens to the patient, who is responsible, whether the surgeon is doing, patient giving consent, or where the surgery has been done.
Correct.
So what's your take on that?
I'm glad you brought this up. Thank you so much for this question. I have a very clear thought on telesurgery. Right now, what is happening is anecdotal, right? Somebody sitting somewhere performs a surgery and it's just for the social media or the newspaper optics. If I come to here and perform a surgery in Hyderabad, I need to make sure the team in Hyderabad is strong enough or skilled enough to manage the patient if either the 5G is disrupted or there is a problem there. So question now to the audience, if my team is that experienced there, why am I doing my surgery from Banaras? There's no need, right? So I don't think that we are there yet. But what I mentioned in robotic surgery, it gives us this ability to cross coordinate. Like if we have a problem in gynecology OT and we need a ureteric catheterization, we'll call you, right, from the next OT. You come in and do in 2 minutes and go away. Right. So a colleague from a different specialty, or if I have difficulty in doing some dissection, you'll call a senior and they'll help you out in a step. That can happen cross countries and cross cities now. So I think there is a role there. And I think I would like to be that person who say, you get a robot here. I cannot come here every day. You start the case. I know you, if even not robot, you'll finish the case. You are confident enough. But with robotic surgery, maybe the ureterolysis in a stage 4 emergency for you initially may be difficult. I can take the control 5 minutes, do that little step for you and say, give me the control. That's it. That's where it will work. And that's where we should aim for. And that's where the actual ethics and maybe rules should come in. There are no clear rules right now.
Thank you.
I don't believe in doing surgery. So I have a lot of these requests from many of these companies, ma'am, kar dijiye, because I know they'll just use it for their optics. I said, no, I'm not doing it because I don't believe in it right now.
With telesurgery, that is the Data Privacy Act.
Yes.
That is
Yes.
coming.
Yes.
Because the data we are transporting through the digitalized cable, even that is also not secure.
Yes.
So that is also one mirror.
Yes. And if the patient party can actually access to it. Yes.
Thank you, ma'am.
Thank you, Sangeeta.
Having again an impactful and excellent lecture. You have nicely explained how AI will have an impact on gynae surgery. It enhances the safety, precision, and the efficiency of the surgeon by the 3D images and real-time navigation through robotic assistance. And the most important is it will reduce the complications and further the medical legal issues. That is a great burden to surgeons. So thank you, ma'am, for your excellent lecture.
So, Madam is an authority, as we all could, understand by her presentation. Excellent presentation. Thank you so much.
Ma'am, I was just interested to know how big is your team to manage this, where you are working?
Team is big because the team doesn't just include the doctors. So there are 4 or 5 people in my team as doctors, but then there are the technicians, nurses, the anesthetist. This is not one man's job. And Something else I say when you do robotic surgery, it's an alien concept for the surgeon. You're away from the patient. Your team has to be excellent. People say you don't need assistant. Okay, you don't need, but you need an excellent team because you are not next to the patient, right?
It's a team.
You are sitting somewhere else. So team is very important. Yeah. Build your team whenever you're doing robotics.
Thank you, madam. Okay. So I'm happy to invite the next speaker too. So Dr. Himanshu Verma is a student of Department of Surgery, IMS BHU, and the mentor and the mentee both are here. Professor Ajay Khanna sir is here in the audience. I'm sure both of them are happy as we are. So Dr. Himanshu Verma is a vascular and endovascular surgeon. He is currently working in Fortis Memorial Research Institute, Gurgaon, India. And his core expertise is mainly in peripheral arterial disease, diabetic foot and limb salvage, AV fistula, and dialysis access. And the best part is that he's our student. So welcome, Dr. Himanshu.
Thank you, ma'am. Never been scared enough because today now I'm thinking I chose a topic which actually I'm not an expert at all. So nowhere in my CV it writes I'm expert on AI. But yes, I do have disclosure that I'm very avid user. Any model, anything came, probably I was one of the first ones to use. Let's start with something interesting. I don't think there's a sound here. I thought, is there sound here? So ये एक वीडियो है जो मैं रोज घर पे सुनता हूँ क्योंकि मेरा बेटा है 2 साल का. एक टाइम तक ऐसे वीडियोस मिलना बहुत मुश्किल होता था because making animation was very difficult. Then suddenly came an era, then when you open the YouTube and it is filled with these kind of amazing videos. But still, when I go back to this picture, ये मैं 2000 जब हम internship में थे, we used to go to Northeast Department of Pediatric Surgery से sir used to organize. और इसके पीछे एक बड़ी लंबी कहानी है. I will save time, but when I look at this picture, इस picture को खींचने के पीछे जितनी मुश्किल थी, that also वो सारी चीजें याद आती हैं. That's why that is very important. It's okay. I have gone through the video. Okay. So now let's talk about changing landscape of medical research. And what is it about how to learn to think in age of artificial intelligence? We'll touch things about what is cognition, where does technology plays a role, and how does the human wisdom comes in. हम सबने when we have been in our early times being at an internship or initial JRship, writing case reports has been one of the very beginning foundation of how we learn medical literature. Going through that library, then finding those the papers. अब वहां से next time आया when Google came in. Now this so-called inefficient, because now as we become senior we realize probably उस केस को सर्च करते समय हमने सारे के सारे आर्टिकल्स पढ़े नहीं थे. We probably knew maybe some, we read some, उसके कुछ conclusion को पढ़ करके उनसे एक केस रिपोर्ट बना के रख दिया. So somehow we always don't value those initial case reports or papers because we know they are probably not the perfect one. But those were the ones which taught us that technique. The manual literature searching taught us to how to map intellectual landscapes, how to synthesize contradictions. So many discoveries has happened in the past in history, which were actually not the part of that search itself. It just came serendipitous. Desirable difficulties is something which is essential part of growing as a researcher. एक बहुत interesting study थी which has been seeing that handwriting versus typewriting has a different impact on your EEG development. When you just type and you don't do the handwriting, your brain slows down. This study, Google effect, was published way back in 2001 to I think around. Betsy Sparrow, she used basically what happened. They noticed that something which is easily available to you, Okay, you know that you can search and you can find it. Your brain starts not registering it. कई बार होता है कि कोई book पढ़ रहे थे और and some interesting word comes and you don't know the meaning. You search that meaning on net, immediately वो answer आ जाता है, you go through the text, but your brain कभी maybe हफ्ते 2 हफ्ते बाद वो again दोबारा से वो word आता है, we don't remember that. That's how our brain functions, because our brain remembers, we can find this on Google. It fails to register the meaning of that word. It was called Google effect, also a digital amnesia. Another study, again early 2000, because this is all pre-AI. This is about when Google and this thing came in. So there was a study जो England के taxi drivers के brain को map किया गया. Those drivers which used to use Google Maps and those who did not. It was seen that those who did not used to use Google Map, the brain's hippocampus was actually significantly bigger. और ये केवल Google Maps की बात नहीं है. सोचो छोटी सी चीज is affecting that part of your brain affects your episodic memory, your future imagination, and your the connecting concepts. Now coming back to research, the grunt work of research, वो papers पढ़ना, going through that very monotonous, boring part of the research job is actually essential to develop those the skills, which unfortunately in era of AI is, because I'm an associate journal of Indian Journal of Vascular Surgery, we see so many papers of coming in perfectly written, polished. We had an author who will almost send one paper every week. And when you go through these are AI written generated papers, which a normal human being, okay, which we will fail to write it even on months. Now come back to process of learning. So learning is you get the knowledge, then your brain processes it. That processing is which there are efforts. It generates connections, it compares, analyzes. After that, that knowledge goes and gets stored, increases your memory, and also helps you in case if you have a plans in future to again put that learning into a context. What happens with AI? You develop a cognitive bypass, because you have the moment you give a prompt, the output is there, that friction is not there. So that actually leads to something called as a illusion of learning. Simply because there's a text very finely written, you can read, when you read, you think you can understand. That does not mean that that is going and sticking in your memories. That does not mean that when in future you will require it will come back to you. So unfortunately, once if you go down the spiral, in place of learning, we'll end up in illusion of learning. There's a very interesting study. What they did, they made 3 groups. This may first group was basically it was they were looking at the capability of writing essays and then recalling about it. So 3 group बनाए. First group was LLM group. They said you will use LLMs, ChatGPT to write an essay. Second group was search engine group. They were strictly prohibited to use the AI, but they were okay to use Google and search engines. And third was a pure brain group. They were not given anything. When they actually analyze the brain activity, in the LLM groups were the weakest in terms of brain user. After some time, they actually became flat. They're literally copy and pasting it. Whereas those who were actually using their brain, they were the best. And the search group was almost somewhere in between. And this is not one study. There's so many studies over the last couple of years coming up about the prefrontal cortex decay happening when you just go purely with the AI. Now coming to AI in research. So any research, the essentially protocols are study design, data entry, analysis, discussion, conclusion. And when you talk about the volume of, and I myself, don't take me wrong, I know I have been probably put in so many AI parts in my own researches, have been victim of writing certain manuscripts using AI in beginning. But the problem comes in that the purpose of research is actually look at the existing literature, find the gap, then hypothesis, and then create something new. Whereas LLMs, at least all those that exist right now, they have been built on the probability. So it will once through the huge data set, okay, it will try to find after these three which will be the fourth best word that will come in. And second, it does not have any major concept of truth. Okay, it does not have any big thing where from it will get you truth versus wrong. It will only provide you the answer, which will probably it will be the best thing to be next. Very interesting paper came out from Apple itself, the study, which was the illusion of thinking. And it did show how much ChatGPT or any AI engine hallucinates. And we all must have experienced, and that's why ma'am was telling, that it's important what kind of prompt you give, because the better the prompt you give, the most probably it will less hallucinate. So having knowledge of all these is very important. There's also very interesting paper published in Nature was about the model collapse, because right now we say that AI is getting trained on all the data which we as seniors have created over last so many years. Then it helps to generate more data as you put things in automation, which will not have this much of distribution. So now this future data will have narrow, low variance, repetitive outputs, which eventually will lead to the model collapse and eventually generate the digital junkyard that they say. And that can lead to the shift from the researcher, role of researchers, from active creator to just a passive validator. That's the biggest fear. Because traditional flow of active creators that used to depend on their writing and refining, the experience and intuition is lost. And then it just gets converted to AI-assisted flow, passive validators. Well, AI is not going to go anywhere. That's what we all are here. So solution is symbiosis, not surrender. It's very important that the human researchers, we stick to the original ideas, discussions, cross question whatever comes from the AI. Okay, we make sure that friction is not lost. If there's a task, we break it down into multiple segments. We say, suppose we the initial output that comes from AI and it processes, it is always cross-checked. Human defines the wake. So you can start by starting a wake prompt. I'll give a very interesting example at the end for saving the time. We can use different kind of engines to create these mental exercises for the interns. So the future of research will be human can be or should be as a guardian of truth, because that monotonicity, that general thinking that can come from AI, so that the old style, the researcher role has to be remained. Okay, and that interface where humans must be kept in the loop between the data generation, validation, then publication. What AI can, so in the age of infinite information, making meaning in humanities, that is the humanity's highest function. What AI cannot do is experience wisdom through struggle. What we must preserve is deep thought and critical analysis. What we must build is training that honors efficiency and cognition. And our promise should to remain thinkers, not just operators. I'll step back from here and I'll go to a plasma story. What is this plasma story? What my thought is how we can be innovators in terms of using AI. So I live in Gurgaon, and sometimes I have to go to Delhi. The traffic is really long. So I started interacting, and the voice chat modem of ChatGPT used to work very well. And I have a tendency whenever I'm traveling, I say, okay, teach me something new. So one day I said, okay, knowing about your date of birth and your study, probably you didn't know what is plasma. I said, yes, I know what is plasma. I said, no, I'm not talking about the plasma of blood, but I'm talking about the plasma state. I said, yes, that was not in my curriculum that time because I was too young and plasma was not discovered. well, okay, they said, okay. I said, okay, tell me about it. Then explain me. I said, I didn't understood. Then I said, okay, explain me as if I'm a fifth grade student. It explained me very well. I understood. Then obviously, as a doctor, first thing I asked was, what is its used in medical industry? They said, okay, one thing is we use in the disinfection. I said, that's fine. In, like for the operation theaters, etc. And I said, we also use this in wound healing. I said, well, that was important because as a vascular surgeon, diabetic foot care is one of the major part which we treat, and we never heard about it. So apparently, I said, well, it's very hot, will not burn the skin. They said, well, you know something, there's something also cold atmospheric plasma. I said, okay, what is that? And this all is happening when there's a 30 minutes traffic on the road. So it said, okay, well, you can generate same the plasma by using electromagnetic forces on room air also, which is essentially a rich cloud of free radicals. And if you put it on the wound, it can kill bacteria irrespective of antibiotic resistance. Okay, that's good. So is it actually hypothetical or is it actually functional? I said, well, there are 4 C devices that exist in world. I said, wow, I was not aware of it. And then it found me the companies that exist. We had a discussion and their efficacy papers, it went on going. I said, okay, what is happening in India? So I asked, what are the companies or places that work about cold atmospheric plasma in India? Said, well, in India, there are only 2 labs. One is in IIT Gandhinagar and one is in IIT Delhi. Said, okay. So look into their publication. Are they doing anything in terms of wound healing? So it said based on the available data, they are not working anything on humans or wound yet. So far, their publications are limited to the industrial use. Said, okay, since I live in Gurgaon, who is the person who is in charge of the IT Delhi lab? So it finds out the in charge person, their email ID. So, and then on our discussion itself, it wrote an email and send it to him that I'm a vascular surgeon with my background, and I want to have a discussion about the cold atmospheric plasma and developing something out of it. And this was a week later. I was in IIT Delhi with Dr. Satyanand Kar, and this is their prototype, which is they already had built a cold atmospheric plasma, which they are using for the non-human use purpose. They actually have a functional waste management system, which can convert 100 kg of waste into just 5 kgs of ashes. And they have actually installed one of that in Delhi. So I'm just saying this was the conversation that came out of the entire AI thing. The point was we kept the friction on. So I will just end here because we all remember this movie. So right now, I don't know, it's okay, it's playing. So we belong to the matrix. So I think in a hypothetical build, if we go, it's all is about, as a humans, we go on the Neo and Morpheus and Trinity side, whereas the Smith is on the AI side. AI might show certain skills which are beyond our imagination, but it's our duty and it's our will where we want to be. We want to remain in that matrix where thousands and thousands of humans were there being brewed, or we want to come out of that matrix and actually use machines here, use AI to grow beyond and remain as a master. So that was me. Thank you.
So thank you, Himanshu. Now, you being an vascular surgeon and doing endovascular surgery primarily, how do you think AI would affect your OT, or what? How can you take assistance from AI?
So I'll
Like from ultrasound, we move down to Doppler ultrasound.
No. There's a very fascinating. So
Yeah,
actually,
so
2 years back, I was in Mayo Clinic. So I went to to meet one of the friend I was there. So they showed me, a facility. So right now, the process of angioplasty is you insert the femoral artery, put in a line. then you take a wire in, then you go do selective angiogram, you pass the, try to cross the lesion, then you balloon it, and then you put in a stent. So now this, and then at the current advances, we have other things like intravascular ultrasound, where with ultrasound on the tip of the wire, which already we use it on a daily basis. Now they are developing on a model where all you have to do, actually they are saying they can also do, all you have to do is a puncture of femoral artery and then load a preoperative CT angiogram, okay, on the same table. The wire will go inside. This hybrid wire will have auto navigation skills. That much they've already achieved. It will have IVUS built on tip along with some core diamond cutters on the top. So it will navigate to the area of narrowing. Okay. Then it using IVUS and some other technologies, it will analyze the type of a plaque from the front. And then it will give an idea and it will ask you, should I drill? It will keep it center line. It will drill through it. Then once it drills, it will analyze the plaque circumferentially. It will give you recommendation. The next, you should balloon or first you go for a rota. And based on, so that is the kind of skills you're talking about. So, and this is amazing. Yes, it's amazing. And if you look at the healthcare sector, the burden which is there, using AI, I think that burden can be actually filled. But same time in background, when I'm talking about the research, that part the human factor should not be lost. That's my biggest fear. And when I actually, for last few days, when I was reading about how it affects our brain development, it's even more important when we give that phone with the chat GPT to a 5 or a 10 years kid. Because अगर हमारे brain का जो already इतना develop हो चुका है, उस पे ये इतना affect कर सकता है, तो what about that brain where these function and neurons are actually forming? So that is my biggest fear.
Okay, so thank you so much for this talk. I think the core of the talk was the friction has to be on, right?
Yes.
Yes. So I cannot talk on your subject, but what I understood.
So for the friction, I think 1 or 2 minutes might be left. So I took this entire talk to prepare after I had a discussion. The basic version was given to me by SciSpace. It was very good interacting, but after that version was made, I landed, most of the visuals were with ChatGPT, with Gemini and other things. But I did spend almost 2 days sitting and talking and thinking about and reading about the papers. So friction has to be kept.
That is because you have a tremendous urge to learn, which the younger generation or many of our student population don't. So my question is, how do you think we can monitor when so much of the AI content is so easily accessible? This urge to learn is being compromised.
I think first thing, breaking down the prompt, it starts. Basic thing, it starts from breaking down the prompt. Even if you want to get an email written, you tell what all details it to be written. When you're breaking down the prompt, then when the return is coming, you already have a frame built in mind and you can compare that outcome. So analyze the outcome. These two are very basic things. Any AI is perfectly to be used. We should use it, but not just give and take. You should break down the prompts, the explore, analyze. Just think it as, you have so many interns to work for you and you have a bigger role and you can ask them, go get it, go get it, go get it. But always remember, whatever they bring can always be wrong.
Thank you. Any question from the house?
सुन रहा
You mentioned about the cognitive bypass and illusion of learning. But as for
that's what I learned on last 10 days, and you have been doing those for years. So you can question, but probably you can answer.
No, sir. I am totally agreeing with what you have just said, because yes, it is affecting us neurologically and also on the cognitive level. But my question is just as we are and the generation coming before me, they are heavily relying on Gemini, Claude, and other LLMs. for getting the information which is readily and easily available to them. So it would be very difficult for us to completely tell them not to do that. But what are the ways that you can suggest that can mitigate this effect of cognitive bypass, so that the accessibility is still there, and but it also helps in that neurological development and does not cause any kind of cognitive decline?
So take it this way: if you go back, all the IAS exams and all, I used to be fascinated because उसमें reasoning का एक बहुत important part होता है, right? और वो questions बहुत मजेदार लगते थे. But sometimes वो या तो हमें मिलते नहीं थे. Now, if I am supposed to make a reasoning examination pattern for say somebody, मेरे लिए बहुत मुश्किल होगा. But now you have LLMs or AI. If you want to create a reasoning but interesting pattern, reasoning examination for a 5th grade student, and it's your son, okay, you create it. Time nahi lagega. So we have to be part. I think that is my reasoning. You cannot, especially for the kids or younger generations, you cannot keep them away. As long as you keep on dragging them off it, तो मुश्किल होगा. If you want them to be involved and understand उसका better version क्या है, that's the solution. I think there has to be, जैसे होता है ना, there has to be phone free day. So in AI, there has to be discussions, or there has to be competitions, research, where has to be no AI part. Okay. And you have to give that kind of mindset. I don't know. You tell. So yeah, artificial intelligence should not make you artificially idiot.
So with this, thank you, Dr.
you, sir.
Himanshu, for the beautiful insight. I also have a fear that one time we are so much AI dependent in coming 5 or 7 years, the AI will tell that humans are morons. And they will talk to
Are you aware about,
what about our existence?
So I don't know. I thought it might have been discussed over last in last 2 weeks. Something very dangerous kind of thing happened. One creator actually made a social website, network for AI bots. So if you are aware about AI agents, और उसमें क्या था कि humans can only observe. Okay, they cannot comment, and you can leave your AI agent there. Those AI agents are talking. They are talking among themselves. Or when you see this writes ki my human asked me to do this, it asked me to find a name for myself, and I thought of this. And uske niche dusre AI bots are actually commenting. There has been a this was in a lot of news, because at 1 second they said that humans are watching us. Should we develop a new a language so that we can talk ourselves? So far this all is under human control, so it can be terminated, but they're saying that Skynet is born.
Thank you to our speakers and our chairpersons. Now I would request the chairperson and the speakers to move to the selfie point for felicitation. We'll be continuing all the rest of the scientific program post lunch.
I am Dr. Sukanya Mehrotra, Senior Resident Microbiology.
And I am Dr. Pratham Brigwansi, Junior Resident Medicine. And we will be the anchors of the upcoming sessions. We now move into the final 3 sessions of today's AI conference, where we'll be continue the exploring the cutting edge ideas, practical innovations, and future directions in the artificial intelligence. Let's begin our next session by calling upon the stage the chairpersons. Professor Sunil Mishra, sir, Department of Pharmaceutical Engineering, IIT BHU. And Dr. GP Modi, sir, Department of Pharmaceutical Engineering, IIT BHU. And Dr. Utsav Bharti, sir, Medical Officer, Department of Health and Family Welfare.
We request you to start the session, sir.
Hello. Hello, everyone. I'm Dr. Utsav Bharti, and
आप कीजिए ना.
I would request Dr. Pranta Chakraborty to come on stage, and he will be speaking on that areas of interest is community hematology, artificial intelligence, and digital health. He has many publications, and he's currently as Chief Medical Director. I would request Dr. Pranta Chakraborty, sir, please continue with this presentation. Thank you, sir.
Thank you. Thanks for the kind introduction. And I know it would be very difficult to remain awake after this sumptuous lunch. But see, being a hematologist, we are considered to be the best clinicians amongst pathologists and the best pathologists amongst clinicians. So now with other technologies come in, we are wearing different hats. And I bring to you greetings from Tenkasi, which is the global headquarters of our technology thing, which I am partnering now, called Zoho. And I think most of you know what AI is. This audience does not need to know that again. But what I would like to tell you is that within those subsets, I think the greatest popularity came when ChatGPT was being used during COVID. So if you think that AI is new, we will be mistaken because it started when most of us were not born. So in the 1950s, and some of the clinical decision support systems we use today was developed then. And at that time, IBM's Deep Blue had beaten Kasparov. Okay. So there were rule-based clinical decision support tools. The problem was the coder's bias was inherent in that. And then there was a huge gap. We were trying to learn medicine, healthcare. In the first decade of this century, we had something called deep learning. And these were based on ground truth. So this time the question was not only is it a cat or a dog, but how many dogs could be seen outside this auditorium, say at 1 p.m. And healthcare wise, whatever you see, sometimes the videos come viral as diabetic retinopathy screening by Google, breast cancer, lung cancer screening, skin condition classification, predicting your outcome based on your electronic health records are part of this process. And this we call AI 2.0. Now here the problem was that the real-time data was not matching with what the models were predicting, and there was something called catastrophic forgetting, which we often face when we face the Viva Voce exams during our MBBS exams. And then the next decade came the foundation models, which is generative AI. You must be hearing it for the last 3 days, which can now tell the difference between a cat and a dog, but not the way we tell it. So it's all about tokens and which comes before and which comes after. And in healthcare, you have MedPalm, MedPalm 2. Now you have Gemma, where Google has already signed a MOU with National Health Authority. But one of the greatest drawbacks is hallucination. So confidently incorrect. So basically, this is where we are now. We can generate anything, including deepfake videos, and we are trying to emulate what happens in our brain, though we don't really understand 10% of how our brain works. So why should AI have such an impact in hematology and hemato-oncology? That is the question. Because it is one of the most data-intensive medical specialties. A lot of data is generated every minute, be it from a peripheral blood smear, automated cell counter, flow cytometry, NGS, or multiomic analysis. This presents a challenge as well as an opportunity for us who are in this discipline. So, how can AI do it? Before that, you have to understand that it's not only natural stupidity which we are trying to reduce. We are trying to reduce our fatigue. You know, routine work, tedious work, and at the end of the day, you are fatigued. So they face inherent limitations, especially in long microscopy sessions, and no two microscopic observers can agree. So if you look at our consensus, there'll never be a consensus in the truest sense of the terms. And you have a time constraint. Any amount of data which is, say, produced during NGS, if the human brain has to process it and then generate meaning out of it, it's virtually impossible. So these challenges become particularly acute when dealing with, say, rare cell populations, like we are now doing single cell sequencing, right? So imagine single cell genetic expression, and we are trying to make sense of it. So where does AI excel? Pattern recognition. Obviously, if you generate an algorithm, it can be supervised learning or unsupervised learning or reinforcement learning. So if you think of an intern, supervised learning is what we are supposed to give them. Unsupervised is actually what they're doing in most of the government medical colleges. And reinforcement is if they have some good seniors who guide them. So all this leads to high dimensional processing and predictive analytics, or what we call today as medical forecasting. And what you have to remember, and I'm telling you in spite of the fact that right from Sam Altman to Sundar Pichai, all are there in Delhi, they will tell you that, we will replace doctors. They will never replace clinicians because it's a powerful diagnostic adjunct. But we always keep human in the loop. So in hematology, what has happened is, first was image processing software, automated blood cell morphology, digitized smear, and then you could even identify normal and abnormal cells. Next decade, right, in clinical decision support systems, rule-based access systems in laboratory medicine. So flagging of the cell counter and other things which were already incorporated by different companies like Sysmex and Beckman Coulter. Now, the next decade, we developed machine learning algorithms, which you'll read about in the journals, SVMs, random forest, gradient boosting, which can handle nonlinear biological data, especially when it is generated from genomics, proteomics, metabolomics, because it's a big data, really big data. And then in this decade, we now have convoluted neural networks, which are a part of deep learning revolution. They can classify bone marrow aspirates and medical images. So in a hospital in Delhi, they were trying to see, and a very senior ex-professor of hematology told me, Prantar, I was amazed. It was doing a good job in more than 99% cases. Now, even in more than 99%, if you're doing 1,000, if you make two mistakes, the patient suffers. So that is one of the ethical problems, which I think we have already discussed. And today, generative AI is simulating new molecular structures. It can synthesize training data, right? You have to buy such expensive cell atlases. Now you don't need it. You tell it, it will generate it, it will multiply it into different problems so that you can learn better, the machine can learn better. So digital morphology, as I told you, it has been for a long time. It has been from the time when a digital camera was invented. And now you have a camera in everybody's hand in the form of a cell phone. So clinical laboratories can do efficient triage of abnormal samples, reduce the inter-observer variability if you're doing a good job in terms of algorithms. Now, bone marrow pathology. See, I'll not go into the details of the models. If you're interested, you can read about it. There are some very good YouTube videos also, or even Gemini or Google LM Notebook can give you a very good insight. So there is Inception V3 based deep learning architecture, which can even grade bone marrow fibrosis. So it was always a debate, right? Myelofibrosis grade 1 or grade 2 or grade 3. And we poor students had to suffer during our Viva. Now, these algorithms are doing such a good job that a Cohen's kappa coefficient of 0.83 has been achieved when comparing with expert hematopathologists. That means the people who were examining us, this is achieving 0.83, but obviously ye dil mange more. So vision language models, you have large language models, you have so many types of models. Now you have vision language models like CLIP, MedClip. They generate draft pathology reports by integrating the visual features with the clinical context and medical terminology. Now, I think the pathologists here would vouch, even today you sometimes get samples without any history, right? It has been sent. Mind you, this AI will be totally useless there because it looks at the patient's data, it understands what the clinician is thinking, then it looks at the sample and then it gives an opinion. So it is so important that you do not lose your clinical skills and history taking skills. Now, flow cytometry. Here, obviously, there has been a revolution because it is all about numbers. So whenever the machines were being developed only, the softwares were being developed, they used some amount of, we had a software, we still have it, but we don't use it because it's so expensive, called MATLAB. And we used to use it for interpreting flow cytometric plots. And now you have high parameter panels, 40 fluorescent colors, right? 10 colors is now also obsolete. So more than 1 million cells per specimen. Who will look at it and who will tell it? It has the capability. And I'll give you an example. You know, BD, which was once a leader, it is still number 2 or number 3 in flow cytometry. In the last 2 years, it has taken over 21 AI startups. So what does it tell you? That they are now trying, because chemistry has its own limitations. So you cannot improve the colors very much because there are certain overlapping spectra. But you can use AI to interpret it better. So you have something called T-distributed stochastic number embedding, Flowzone. These are all names of certain models. There are open publications on this, which can do an unsupervised clone recovery, automated gating. So, the thing which we dreaded when we learned flow cytometry was the gating. And no two persons could agree. They say, no, I'll get this cells, another would say this. Now it is automated gating using deep learning models with very little interoperator variability. MRD. So, we are talking of minimal residual disease. Previously, we were happy with 10 to the power of -4, 1 in 10 to the power of -4. Now we are looking at 1 into 10 to the power of -6. And who can do it? They can do it if they know how to analyze this big data. And that is why you are seeing AI being used in a significant manner. So whatever be the data captured, the flip side of this is that garbage in is garbage out, right? So we call it GIGO. In healthcare, it's not GIGO, it is GIHO, garbage in, harm out. So if you generate a lot of data from a single cell and your algorithm is not good, then you'll get all sorts of harm out. This is a beautiful review article. This is a bit old, 2 years, but I think it gives you a good insight into how it is helping flow cytometry. And I'll show you an example. So this is manual gating by a person who has 20 years of experience in flow cytometry. And this is automated gating. At least to the naked eye, there does not seem to be a difference. So this is how AI is joining hands with flow cytometry. Next is cytogenetics and karyotyping. Again, you have CNNs, automated recognition of critical cytogenetic abnormalities like aneuploidy, balanced translocation, unbalanced translocation, other structural variants, but it is better that if it is taught. So state-of-the-art transformer-based karyotyping systems, which are available commercially already, they have been trained on databases exceeding 50,000 annotated images, achieving expert-level performance. Now, who has annotated them? The humans, the human pathologists. So, if the annotation is wrong, you might be in for trouble. For solid tumors, liquid biopsy has met AI. And how has it done it? By enhancing the signals. You know, when you're looking for one circulating tumor cell, so you use certain parameters and teach the machine. So now you are detecting more and more chip. There's one algorithm called meta-CH. But what happens to those whom we detect chip? The cardiologists have become more interested in it than the hematologists because heart failure, coronary artery disease, they have been found. And then you have CAT-boost based integrative models which combine the circulating tDNA analysis with clinical parameters. And you have cell-free RNA profiles. So it's all about, jugaad, multimodal fusion. You get data from different points, give it to the machine, and then it would show you something which perhaps a single human brain or a group of human brains were not possible. So just like MRD detection, relapse prediction is also being helped by AI. Now, what is now happening is, and this has been launched last year, that along with the PET-CT images, you are integrating the histopathology. You are integrating the immunohistochemistry. And then you are using SVMs and logistic regression to analyze those images and detect the heterogeneity and where you have to target and what to target. So obviously the future is about multi-omics. And let me tell you, after genomics, epigenetics, metabolomics, proteomics, now omics we are talking about is exposomics. So exposome is whatever we are exposed to when we are in the womb till our death. And it means the internal and external environment. But if I look at the conventional genomics and transcriptomics also, you are now integrating gene expression profiles with epigenetic signatures and then trying to predict. And there are, graph neural networks or graph convolutional networks or graph attention networks or graph transformer networks. They successfully integrate this across different cancer types. So when you are in some trouble in diagnosing, you can use it. Single cell, I've already talked about. And if you want to read more in our field, AML is the most difficult disease till now. So what we are trying to do is, again, look at single cells and try to find out how the clones are, and when you use certain drugs, how the resistant clones come. And then you look at their gene expression, then you look at the pharmacodynamic and pharmacokinetic profiling, and then maybe you become a better hematologist. That has not been proven till now, but there are early indications. And then when quantum machine learning is coming, it would be a big jump because, proteomic analysis. So you already have QProteoML, which is a groundbreaking quantum machine learning platform using QPCA and QSVM, which is used in multiple myeloma now, and it is outperforming even classical machine learning and deep learning in understanding the drug resistance patterns. Now I have a very simple question for you. Please raise your hands. Can you diagnose acute leukemia without using a microscope? How many believe yes? Only one. Okay. So let me show you a publication last year. Evaluation of a machine learning model based on laboratory parameters, which do not include a peripheral blood smear, bone marrow, or a microscope. And there are certain simple things which can be generated in the district hospitals, like, fibrinogen, mean corpuscular volume, prothrombin time, LDH, monocyte count, MCHC, and certain basic parameters like age, lymphocyte count, and platelet count. So the thing is, with an automated cell counter and automated biochemistry analyzer, what did they show? And this was in France. And mind you, it's an open source explainable AI. So they showed that it's an accessible technology. Rapid triage can be done. So whom to be sent to a tertiary care center, it can lead to resource optimization. Because if it's APML, if you do not treat, the mortality is still more than 50% in the first 5 days. So AI PUL is a game changer. And if anyone wants to validate it, I think you can always do it, because at least in this study, the validation was more than 98 to 99%. So without a microscope, we are diagnosing blood cancers. Now I come to transformers. You already know, right? GPT itself is a transformer. So multimodal transformers, which is the future, you have something called MARIA. So what is MARIA? It's an acronym for Multimodal AI for Hematologic Assessment. So it looks at self-attention mechanisms that can even handle missing data. And it can move beyond narrow, task-specific things, predict what is going to happen to the patient. So how are clinicians affected? I showed you the pathologists. How are clinicians affected? They are affected in multiple ways, but they have to be very clear that they are not being used as guinea pigs and their patients' data is not being leaked. So DPDP Act has already been notified. Now we are going in for something called federated learning, where your data stays with you, but in an anonymized forms, it goes and then it gives you a prediction. So it is similar to Google Map. Everyone is contributing to the car movement, and you can see which roads are congested, which are not. You have to calibrate the models. Annotation is so important, and explainable tools like SHAP, these are important, and you have to have regulatory compliance. So today in India also, there are regulations by the CDSCO called software as a medical device. So if anyone comes to you just like that, do not accept whatever they're saying. Every company, including the so-called East India companies like OpenAI and Google, always will give you a rosy picture. Half of it might not be true. I hope they are listening anyway. And the next step is to integrate into your running system. You cannot say, oh, I'll throw out whatever I have and now I'll become AI compliant. That doesn't work. And the most important is human in the loop, human AI co-validation. So if I talk of the speed revolution, diagnostic accuracy is close to 97% now, but ultimately we need 100. MRD sensitivity has gone to 10 to the power of minus C by using multi-parameter flow cytometry and AI. And liquid biopsy can predict a relapse 4 to 8 weeks before. Stem cells, which are recalcitrant to your standard therapy, can be detected with 99% sensitivity. So the frontier is multimodal AI architecture, where it starts from clinical narratives, okay? History, symptoms, physical exam, treatment history, laboratory time series, digital pathology, with which I started, flow cytometry, genomics, transcriptomics, proteomics, imaging, and that entire holistic view. So you get a digital twin and you want to know. So peripheral hospitals can use it for triage. Reference laboratories can improve their efficiency. Molecular laboratories can give better reports. Clinical decision support is already there. We can improve it, but it has to be contextual for India, not only for India. What will work in Varanasi might not work in Chennai. So longitudinal monitoring is another thing which is. It is definitely helping us democratizing expertise. It is breaking geographical barriers, reducing diagnostic delays. But there are certain challenges and limitations. Data set bias. Remember, garbage in, harm out. Generalizability gaps. If you give too small a data, it will fit it, but it will be a danger fit. And most of these big companies, including Gemini, ChatGPT, Claude, they are all black boxes. And there is a concern about cyber security and privacy. Do not become over reliant on them. Do not start mistrusting your brain. Okay? And medical legal uncertainties are there. So in the next 1 minute, I'll show you that this is where AI is. Can you see hematology here? Okay, I'll just zoom in. So radiology, my friends in radiology, they have to think a lot, but hematology is number 4 when you exclude radiology. It's a small drop. It can tell you a lot of things, but some things are already there in terms of digital morphology like Cellavision, which is in Sweden. And then you have our own Indian SIGTUPL, which is trying to develop it. And we have developed an open explainable AI from Indian Statistical Institute. If anyone wants to use it, I will share the GitHub repository where it detects the cells just like a pathologist does. So even a thalassemia patient in IIT Bombay has done it. So don't tell what can I do. You can do a lot of things if you work together, if you discuss together, and the bottom line is that it cannot be done only by the technologist. What not to do is do not use novel therapies dosing, skip human reviews, and what has been done in Harvard or Stanford might not be true for your population. So you have to have an essential validation checklist, as I told you, if you're planning to buy something, and you are the final person. Thank you. I hope I have been able to give you an overview as to where we are going.
Thank you, sir. It was a very knowledgeable lecture and presentation. Actually, I'm not from hematology background, but sir, as you told key data, I think since last 2 days we are discussing the same thing, and you have rightly pointed out that data needs to be Indian specific population. In fact, demographic Eastern UP is not different from Western UP. So how can we do that? Being a pathologist or hematopathologist for better diagnosis of early stages of cancer, not only leukemia and everything.
Yeah.
Any pre-cancer stage.
So what we can do is what we don't do. That is documentation. Whatever you're doing, try to document it, maintain the image files, and try to develop your own database. That is gold, right? It is called data is gold. Similarly for the clinicians, if they are doing a lot of things, but they say, no, we will not risk. It's too difficult, seeing a patient with a computer in front of you. There is ambient scribe now. You keep on speaking to the patient, the entire operation can be transcribed into meaningful medical knowledge. If you are not generating good quality data, neither natural intelligence nor augmented intelligence, nothing will be able to work.
Thank you, sir. Now the question is open for audience. If anyone wants to ask something to sir.
Yeah.
Excellent talk, sir. My question is that if you are like a pathologist,
Yeah.
do you take consent from the patient when you are putting their pathological slides on AI platform?
Yeah. So that is a very good question, and DPDP has been made it more murky, right?
That's right.
So I think PGI more than 50 years back did something. When they used to admit a patient, the last line of the consent was that your sample and data can be used for research. That's why they could do so much autopsies, right? Nowadays,
Can just one line should be treated as a patient consent?
that is what I'm
That's
telling. They
another
did it
thing.
50 years
Right.
back, and they thought they were safe. Today, you are not, but maybe every pathology can have their own guidelines that we may use your data in an anonymized manner for better development of diagnostic tools. That much has to be mentioned.
Thank you, sir.
Even
Thank
if it is from thrown away slides. Yeah.
Yeah. EMA X. So is data on this AI are being fed by you only? I mean, Indian data is fed to that AI or?
Yeah, it's Indian because we had an ethical committee clearance. So what we were trying to do is the institutions which were doing it, they took their institutional ethics clearance and they did it, but it was all anonymized, obviously.
Okay.
So, now the problem is the AI models are so good that they can de-anonymize anonymized data. So you have to go astray, even another step further so that it remains anonymized. Yeah.
Just one quick question. Isn't it a good idea to have a sort of the banks like they, India, we have the bank, brain bank, something like that. Similarly, we can have a bank for all these things so that it will be.
Pathology department, in previous days also, they used to have their own slide bank, right? It was used mainly for teaching. So you were using it for teaching students. Now you use it for teaching machines, but you have to maintain it. And that's why I told you that annotation is more important. If that annotator does not have a necessary skill, then the machine will be the same, right? Thank you.
Thank you, sir. Thank you so much for such lovely lecture. I would now request Dr. Devendra Kumar Neem, sir, to please come on stage. He is Associate Professor from Motilal Nehru Medical College, Prayagraj, and he's from Pharmacological Department. He's gold medalist from KGMU and conducted workshops on artificial intelligence in research and biostatics. He is a known speaker at an international conference at MIT Prayagraj on artificial intelligence in medical research and is an author of multiple books and chapters. Thank you for coming here, sir. The stage is all yours.
Thank you, Chair. Good afternoon, everyone. Shankar sir. He was my teacher in KGMC. And good afternoon, everyone. So I'm going to discuss on the basis laid by Dr. Chakravarti sir, just right now. So my topic is quite vast because the drug industry is benefiting AI from its inception. Like 1958, it all started. And the first beneficiary is always, any technology develops, the first beneficiary is always either the drug industry or the healthcare. And second one is the war zone, the ammunitions and all. So I will present this topic in 4 sections. First is the traditional paradigm challenges and AI transformation. Second is AI technologies across the drug discovery pipeline. Third is the drug repurposing strategies and success stories. Fourth is regulatory framework. So first, we should talk about the why we need AI in drug development. So we start with this graph. This graph shows the Irum's law. It is the just opposite of the Moore's law in data science or the computer science, where the technology doubles every 9 years. Here, the drug development, in drug development, the y-axis shows the $1 billion, the number of molecules developed per billion dollars. So it was in 1950s, it was 30 molecule developed per $1 billion expenses. Right now, it is close to 0.4. So on an average, $2.6 billion are used for developing just one molecule. And in traditional timeline, take 10 to 17 years to develop a single molecule that is clinically viable. And the failure rate after entering into clinical development, clinical trials, the molecule has chances of 10% getting success. And that is way more than the total molecules screened for a single molecule to develop. That is 10,000 molecules are screened for 10 to enter into clinical trials, then one molecule get approved. So it is a very costly and time-taking process to screen 10,000 molecules and get one as approved drug. So why the drug development fails. So mostly fails in phase 2, that is 70% due to lack of efficacy. In phase 3, the chances are of failure are from efficacy and safety issues, and poor target validation also causes 50% of the failure. And the earlier thing was ADME toxicity issues, that is now almost replaced by AI, because we now can predict the cardiotoxicity. That was the foremost reason of getting a molecule disapproved during the trials. Now we can very efficiently predict the cardiotoxicity of any molecule with AI models. So now we talk about the evolution of the AI models. So it started in 60s with early computational model where QSAR, quantitative structural activity relation, where we can fairly predict the biological activity of any molecule by by understanding its structure, and that was basic computational model. Then in 19 we developed some expert system that was rule based systems, and for ease of understanding, rule based systems are and they cannot learn from the data, but they can predict from the given rules, like regression models. So classical example is the regression model. Then come the data driven model, where comes the machine learning. Machine learning is we train a machine from the available data, and the machine tries to predict the connections between the data. Then comes the deep learning. Deep learning is machine learning in multiple layers. So what is the basic difference between the machine learning and deep learning? The layer of the neural network. So in machine learning, we usually work on a single layer of data, but in deep learning, we go into multiple layers of data. Then the foundational model, where the generative models, now we can even generate the data, and we can predict on and even generate the molecules, thousands, millions of molecules in computer system only. That is further screened by the AI systems to get a very uh, very likely molecule that could pass into a clinical trial. So here's the market transformation. It is a glimpse of what AI is doing in right now in the drug industry. It is a approximate 400 billion industry right now. Thousands of companies are there, but mostly are not actually revealing what they are doing, because whatever they are doing is proprietary. So the data is not available for general public to understand what they are actually doing, and that is the biggest gray zone in the understanding what AI is doing in drug industry, because every single drug, almost every single drug we know right now is using AI in any term from multiple points I will discuss later. So this is a diagram that is from my published article. So it is a very easy to understand diagram, where in the clinical pharmacology, a part of drug discovery is a part of clinical pharmacology. So it shows at what point in drug development, and after that, which kind of AI technology we are using. So you can see the machine learning. Machine learning is red and deep learning is green. So machine learning and deep learning are almost used everywhere in the drug development and pharmacovigilance and precision medicine field. So here is a glimpse of difference between the traditional and AI methods at different part of drug development, from target validation. The green part shows the difference that AI is creating in the different part of AI development. So approximate 40%, 45%, 50%, and you can see in stage 3 lead optimization preclinical 35%, phase 1 15%, phase 2 15%, phase 3 15%, and regulatory submission 10%. So it is creating a substantial difference in terms of the monetary, in monetary terms. And here's a radar chart that shows a clear comparison of traditional development that is shown by this inner graph, and the outer circle is AI technology, the drug developed with AI technologies. So the biggest difference you can see is in cost efficiency. So whenever we use AI in drug development, it is it has a major impact on cost efficiency, because AI can largely replace human beings, and the total duration and hours taken to develop a drug, and the least is in novelty of targets. So because the novelty of targets, that is a very difficult thing to find, and we need even better AI models, and that might be possible when we develop quantum computing. That will be the biggest difference. After developing the quantum computing, it will be the biggest difference. So here is the major technologies that are used in drug development: deep learning, graph neural network, and transformer models. So for the ease of understanding, you can understand, like, deep learning is like radiologist, the systems that can analyze and diagnose from the radiological evidences. It usually it is as simple like we are training the system on n number of the a huge number of the available data, and the system predicts it better than, sometimes better than, a human being, because it has the larger number of data set on which it is trained. The graph network are like GPS. So what it does, it can connect between the 2 points, so it can see what we cannot directly understand by our own understanding. And transformers are like generative models where we can understand the deep structures, like the 3D structure folding of proteins, that is usually uh, target in drug development. So here are some companies that are working, leading AI discovery platforms in silico medicine, Recursion, Benevolent, and Atomwise. These companies are selected from the huge list of companies because these are the pioneer companies that started in 2010, 12, and 14. So in silico medicine has a lead because the first AI drug that just cleared the phase 2A. The first 2A is important because whenever a drug crosses phase 2A, that means it is a proof of concept. So it is the first company that has a proof of concept drug. Uh, Recursion is largest merged platform, so it is using multiple technologies simultaneously. Benevolent is working knowledge on knowledge graph target. Atomwise, it is deep learning from virtual screening. So it is a company that largely works on the screening of molecules. So this company worked and screened more than 15 million molecules in single day. That was humanly impossible. So about AlphaFold. AlphaFold is a subsidiary of Google. Now it is known as Isomorphic Lab. So it is a company that works on 3D structural protein. Now it is called AlphaFold 3. Basically, it has 3 versions: 1, 2, 3. So now it is in advanced form of AlphaFold 3. So this company primarily works on the protein structure and target validation and identification. Then Benevolent, it was founded in 2013, and it mines the literature, omics, and clinical data. So it is a company that works on the multiple layers of omics, like proteomics, genomics, metabolomics, and all. And it is the company that predicted baricitinib for COVID-19. So one of the earliest molecule that got proper AI tag. Actually, even if we develop every single drug with use of AI somewhere, but very few get the tag of AI developed drug, because uh, no company is actually revealing what they are doing in the background. Because when they say we are developing it with AI, the concern of ethics arises. And drug industry is the most regulated industry in the world. So it is a fair chance that if they say that we are using AI, and if that AI is not proven for its ethics, then it might be chances that that company cannot get any kind of approval. So baricitinib, that is actually, it is a repurposed drug, but after repurposing for COVID-19, it showed 38% in reduction in mortality. Atom wise, I said earlier, it screens millions of data. So it screened 10 million compounds against Ebola virus in 24 hours. But one thing to understand, even if this company screened 10 million compounds, and I discussed earlier that we need to screen 10,000 compounds to get one approved drug. So 10 million compounds mean within a day we can screen for hundreds of molecules that were becoming a drug. But is it possible that we create or we gather information about hundreds of molecules in one day that ultimately turns into a medicine? So that seems like a fairy tale. And here is the key to understand that not everything that AI tells us or promises us is reality. So it is not a reality that 10 million compounds is screened and we got 100 drugs for Ebola virus. So the in silico medicine, this is their landmark is rentosertib, that is AI design antifibrotic small molecule. So it is in right now in phase 2, that is used for idiopathic pulmonary fibrosis. Right, it is in phase 2 right now, and it took 18 months from target to candidate. That usually take 4 to 5 years. So this is a big thing to say, but after digging out the multiple the data sets, the articles everywhere, what I found was, as of today, there is no single drug that we can say that it is approved by FDA and that carries a tag of developed by AI. A classical example is helicin. The helicin molecule was developed by some researchers in US in 2009. Then after 10 years in 2019, MIT took that. That was actually originally understood that it will work in diabetes. But after 10 years, the MIT people get to know that it has some antimicrobial properties. They started the preclinical trials. The data from preclinical trials was amazing. And that was considered as the wonder drug, first AI drug, first antibiotic after so many years, because antibiotic development is the uh, biggest bottleneck in the development of drugs, because there are very high chances that the antibiotic, after coming into market, very soon it will get some kind of resistance and it will be out of market. So usually the companies don't try to develop a new antibiotic because it is a matter of 2.6 billions, and they don't want to develop any drug that will vanish from market after 5 years after investing 15 years and 2.6 billion dollars. So most of the companies try to refrain from developing antibiotics. So it was a breakthrough news that the MIT people are developing a helicin molecule that will be a new era of antibiotics. But the current news is that when you search helicin in Google, you will see a number of articles and things about helicin, like they have invented something, that they have found something wonderful. But right now, the reality is, after preclinical testing, helicin was not found very promising in clinical trials. So it is still struggling to get into clinical trials. So technically, there is no single drug that we can say that it is purely developed by AI from the concept to the marketing. But here are some pipeline drugs that are still in the trials, different trials. You can see Rentosertib from Insilico Medicine. It is one of the most promising drug and very high chances that it will be the first drug that will get its AI tag for AI developed drug tag. It is in phase 2A right now. It has very high evidences of getting approved. So these are the major drugs, and this is GB 895. It is developing for severe asthma. It is in phase 3 right now. It is an antibody. So it is a diagram that shows where these molecules are right now in different trial phases. So here is the GB 895 in severe asthma. It is uh, leading the race right now. This is the timeline showing different molecules when they uh, came into the trials. So this is about Rentosertib, the clinical proof of concept I talked earlier, but it has cleared the phase 2A right now. So now the AI in target identification and validation. We talked about the multi-omics integration, genomics, proteomics, transcriptomics, and pandaomics in silico developing is this, and it has 96% accuracy in disease relevant target prediction. We talked about the AlphaFold 3, the generative AI. Why generative AI is so much useful in developing drugs? Because for screening we need 1,000 of molecule to get a single drug. Here comes the generative. Most of the technologies that are in use right now in medical field do not use generative AI. They are limited to machine learning and deep learning, where they use the large data set to predict new thing or predict in diagnostics or in anything, but not the generative AI, where the AI system can generate. So basically, the basic of generative AI is, or multimodal AI is, when we give some kind of data to AI. Usually, you have heard about you might be heard about the diffusion models. What it does, diffusion model usually try to impose noise on a image layer by layer, then get data from the that uh, that how can I that noise, and then whenever it come to recreate it, layer by layer denoise the thing and create something new that you ask it to do. So generative models, what they do, they can now create virtually a millions of molecules that can be further evaluated with AI for their efficacy and their safety. So this is the biggest leap that drug industry can take, but right now it is in primitive stage. So with the advancement of AI, actually computational power, here comes the power of quantum computing. So quantum computing has the power to uh, multifold the computational capacity of AI systems right now. It might be possible at that time that we can get the precise medicine, the precise molecule for every single patient. But before that, right now, we can benefit from these AI models, not as much as in diagnostics and other things. So one thing is this early, the biggest the problem in drug development is that uh, after developing or in the process of development, we find some kind of toxicity, especially cardiotoxicity. That is why we right now screen the molecule for cardiotoxicity first, then we go into anything. So deep tox can accurately 88% accurately the toxicological endpoint. It can predict the psychological endpoints, and it is one of the leading place where we can get benefit from AI systems. So drug repurposing, actually, whatever we know till now that this drug is AI developed, most of them are actually repurposed drugs that were available earlier, and now we are using it for some kind of other indication. So the basic difference between repurposing and basic benefit of repurposing is that we repurpose a known molecule that has cleared the preclinical testing and all, and it is a known molecule. But now with the availability of multi-omics, multiple data points, and the complex AI capability of AI to understand the multiple data points and multiple hidden points, it can predict where whether this molecule can be used somewhere else. Like if drug X is working on some kind of Y, uh, uh, some kind of target that is Y, but if we found a molecule B that is also working on that same thing, now we can repurpose that single drug for the other indication also. And earlier it was done by manual efforts, by the understanding of clinicians, their clinical knowledge, but now we can do it multiple times with use of AI. So by repurposing, we can save up to 10 years by simply, and the classical example of repurposing was the using of remdesivir, dexamethasone, and multiple drugs during the COVID era. So COVID was the classical example where we repurpose multiple drugs for treatment or so. Now we should talk about the 30. We have talked about this varicitinim. There are multiple ethical issues for AI. Actually, the biggest problem with AI is that we can understand it from the, if you have used AI, ChatGPT, the commonest AI we use, now it comes with thinking model. Earlier, whatever you command it, it will give you some kind of information or some kind of knowledge, but you never knew how it come to this point. Now it can tell you what it was thinking before it generated any response. So this is the it is called black box interpretability. Even if the AI system is very accurate, it gives you 99% efficacy or whatever in any system, any point, any given point of time in drug development. It was very difficult to know whether this what was the thinking of this AI system before getting to the point. Even if we get the 99% accuracy, but we are not sure what was the thought process of AI, whether it aligns with uh, our ethics or not. So it is the biggest hindrance, and with the development of AI, it might be a thing that will vanish. But it is the biggest issue right now. And most of the things are earlier covered by Chakravarti sir. So I'm not going to discuss. So quantum computing is the biggest thing, a biggest leap. The day quantum computing comes, everything will be solved, probably. The conclusion is AI is not replacing human intelligence expertise. It is amplifying our capacity to discover, develop, and deploy therapeutics and unprecedented speed and precision. Thank you.
Thank you, sir. Thank you for such wonderful lecture. Now, anyone in audience want to ask somebody to sir? So, sir, just one question, sir.
I'm not sure if you will be the right person to answer the question, but is is the patient going to get benefit of lower cost of medicine with this reduced time and reduced price of development of the drug? So are pharma companies going to keep that in consideration?
Sir, actually, let me answer this. When you were walking, when there was no car, you're walking to travel simply, were that costly, or riding a car is costlier? So my argument is that when there was no cars, you were traveling by foot, were that costly, or traveling by car is costlier? Simply, sir, the answer is that the technologies gives you mileage to get or to travel longer distances, but it is never cheaper.
Very true, sir. Artificial intelligence, as I think it's now on the end of this conference, but since last 2 days, we all are emphasizing that AI is a co-pilot with us. Whatever research or time, maybe with time in future, शायद courses of duration जो होता है, maybe that will be shortened because of AI.
Sir, future is that everyone will get a personalized medicine, precise medicine that is made for him only, precisely made for him, that will be surely available after 10, 15 years, 20 years, but that will be expensive than the current drugs, because it is the basic difference between mass production and customized production.
And hope so, sir. With time, drug resistance is also go with this artificial intelligence. I mean, drug resistance for antibiotics are it's no irrational use of antibiotics are causing drug resistance all over. Yeah. So I hope, and it's a very wonderful lecture, sir.
Thank you.
Thank you so much, sir.
Thank you.
Thank you, speakers and respected chairpersons, for an insightful session. We request you to proceed to the selfie point for felicitation. We also request the delegates to collect their souvenirs near the registration desk. Thank you. We now move to the next session with focus on an exciting and rapidly evolving frontier in biomedical sciences, that is biocomputational applications in therapeutic enzymes and monoclonal antibody production, along with the legal perspectives of AI. To guide us through this insightful session, it is our privilege to invite our esteemed chairpersons, Professor S.P. Mishra, Department of Biochemistry, IMS BHU, Dr. Vijay Sonkar, Department of Molecular and Human Genetics, BHU, and Dr. Chandan Singh, Department of Biochemistry, IMS BHU.
So now that we welcome Dr. Pratish Shukla from the Department of Biotechnology, Institute of Sciences, Varanasi. So his area of research is enzyme technology and microbial biotechnology. And he will be speaking here on the biocomputational tools for the therapeutics, enzymes, and monoclonal antibodies, production through novel platform technology. So I welcome you, sir. Thank you.
Okay, thank you, Dr. Sonkar and all chairpersons, and thank you for inviting me. If you see, this talk is little different than what you have heard right now. So we are talking about therapeutic enzymes and mass production, how the new technologies and how the new things, including the AI-based optimization, can be helpful. So if you see the enzymes, because I'm enzyme technology microbiologist, so both enzymes, there are different types of enzymes. So we are talking here about the therapeutic enzymes. The only difficulty with enzyme is that once you are isolating the enzyme or purifying the enzyme, its complete purification and its application is a challenging part. Along with that, if it is a microbial enzyme, there is more challenge about its strain improvement. So I will be talking about that along with that. So these are the five facets. So I will be more focusing on this novel platforms because it's important for monoclonal antibodies vaccine development. So if you see microbial systems biology composite of all these aspects, but the main aspect is how to control the metabolism part. So if you see this slide,
So we have to focus on interdisciplinary aspect. That is called industrial systems biology, where you focus not only on the disease diagnostics, you also focus on how these specific techniques are applied. So when you work on any microbe, any microbial enzyme or any therapeutic protein, you have to look at all these angles together to understand that, okay, this technology can be taken up to the translation level. So if you see, this is a simple figure which tells you about that a single mutation in any organism can give you lot of things. But when you engineer enzyme, you do lot of other mutations. So if you see, this is the analysis. If you have lot of metagenomics data, especially when you work on various disease parameters as well as all the environmental samples. So you see lot of metagenomics data and how to correlate all these data together. There are many softwares available which you can use because we are talking about AI for VIKSIT Bharat. So these softwares are available and you can see if you want to understand the taxonomic analysis, you can use this QUIM, Mother, MLST. You can use this functional category. You can use Megan, Megarep, and MGREST along with clustering. If you want to understand different pathogens, you want to have a comparative genomics of that, you can use this software. And for pathway analysis, if you want to go ahead with some new pathways for any disease or any disease biomarker discovery, you can see these softwares. These softwares are mostly free of cost, but some of them they require subscription. So you can always ask those subscription. This paper we published, Systems Biology as an Approach for Deciphering Microbial Interaction. If you see, most of the diseases and the other things are due to that. If you see, this is one case study we did with HMGCR. This is a very important enzyme, and we tried to see through computational tools that how this enzyme and how the statin therapy can be improved. So I'm not going on detail, but I will tell you about that. The isoform from Homo sapiens were studied. And if you see, we did the complete 3D structure of this HMGCR isoform 2 and tried to see that why we cannot improve our current statin therapy. So this study we completed and we came to know that these are different statins which are used, and we modeled these statins with Discovery Studio 2.5, and you can see a comparative overview was there about different statins and how these key residues can be used for developing a new statin therapy. So this study we published in Computers in Biology and Medicine. This is the only journal which having a very good interface of biology and medicine together. So this study tells about the innovations in statin therapy and how different types of isoforms can be crucial for designing a new novel therapeutics. Going further to the therapeutic proteins, I have limited this talk to only about that. So therapeutic proteins are basically, you can see that I worked on this map. So if you see the problem, the industry came because it's an industrial project. One of my PhD student completed this. So the problem was about the specific lactate accumulation. So lactate accumulation will give lot of problems. So we thought as a biotechnology person that why not we do the cell engineering and process optimization using AI tools and other tools. So we did this study. If you see, this is the uh, normal upstream process and downstream process, and it's a customary protein production process. Any industry is depending on that. So we proposed a novel approach according to this, that you can see the cost effective production where you get more high yield. So you cannot do one innovation in one step. You have to do innovation in every step. So if you see the clone development, previous speaker was talking about using the clone identification using automated system. So here, if you see the clone development, you have to think about the using the fusion tags to improve the therapeutic protein production, then glycoengineering, also the novel promoters. We used fermentation innovation, like we use the microbioreactors, small bioreactors, and also the medium and feed optimization using AI tools, and also the purification innovation, where you use the Wacker signal and fusion tags, and also we use this. So this is a cost effective, which I am going to tell you in that. So this we proposed, and then we implemented this strategy in our research as well. So you see this was published and it's one of the very highly cited paper. Many people are citing this for therapeutic proteins, especially after COVID. You can see people are more interested about vaccine development. So if you see, these are the common issues which we have taken care about the lactate and ammonia. We use the CHO model. And if you see, the CHO model was used and we did this study, metabolic engineering and cell culture studies. And here you see, this is the pathway which we engineered. And then we try to see that how these studies are going to solve the lactate accumulation issue. So if you see our approach, we cloned this pyruvate carboxylase in E. coli and then created an engineered CHO cell line, as well as we expressed these therapeutic proteins, and then we tried to assess the product quality. So the technology is already in the market, so I will show you those aspects. So we did first the cloning of pyruvate carboxylase. You can see that we use these vectors, and we use two strategies. Also, we did the codon optimization because that is very important when you devise a cloning strategy for therapeutic proteins. So we did this codon optimization studies, and then we applied strategy one where we cloned this PC in PSCHO12 vector as well as 13 vector. So this strategy was good because it was giving good result, but I will show you the limitation as well and our failure in certain cases. So we did the PCR cloning of the PC gene. Then we tried to do this PCR workflow, you can see here. Then we also had a second strategy because when you do any industrial project, you should have at least 2 or 3 strategies to take up further. So we did this cloning of PC in PCCHO11 vectors. And we concluded that the PC gene was cloned. We successfully cloned. We characterized the vectors, and also we got for the linear transfection studies. But then after that, the challenge was to create engineered CHO strain which can have more therapeutic enzyme production. So we did this through pool selection strategy. If you can see, these are the pool selection strategy which I have listed here. You can see these are the expression vectors. And then finally we did the transfection to understand that, okay, which are the important parameters. So these are the strategy one parameters. And after that, the transfection studies, they gave us a very good outcome. And then we did the optimization of electroporation conditions. So finally, we generated the stable pool 1 and 2 because we have to select and screen lot of clones. So we selected various clones, and if you can see, the more green cells are the higher producing cells. So this strategy takes a lot of time because you have to screen lot of cells. I will show you in the last that how much time. And this is the pool generation, how that it was generated. And we use micro reactors, small reactor, because big reactors, if you do, it will take a lot of time. So then we concluded that we didn't get much PC expression, but the vector and host combination also doesn't work. So we tried to see with the strategy 2, and then we took this second strategy, which was almost similar, but we used this PCHO11 vector. Same study we did the transfection as well. And then we generated the stable pool in this way, where we have one A and one B. And finally, we got the PC expression in a very good platform, which was proved by sandwich ELISA test. And you can see this is a mini pool study. And after that, these are the mini pool parameters. I'm not going to explain one by one because, but you can see in the paper. And we then did with the single cell cloning. This is a very tough task, single cell cloning as well as the clone selection. So you can see here that day 0 and day 17. You can see here the cells, how the viability of the cells, because our challenge is also to have most viable cells in less time. So that is a challenge which we achieved properly. And then this pool 2D finally we selected for the final map production. And you can see that the highest cell density of 26 into 10 to power 6 cells per ml was achieved. Cell viability also was better, and longevity of the cells was also better.
Sir, thank you, sir. So time limit, sir.
Yeah, I'm seeing that. Okay, I will finish. Okay. So we controlled also the lactate accumulation. So this is the final cell cloning protocol. So we screened 500 clones and then selected top 10 clones. And these top 10 clones, we select one clone for the map production, monoclonal antibody.
So you can see the clonality experiment. You can see day 0, then day 1, day 2, day 5, day 8, day 12, and you can see day 13. So these are the different facets I have shown you. You can see in the picture. And this was our achievement, to have a better clone for map production. And now the technology is already used. So then after collection and all these screening, we got one clone, clone 12, which is used for clone purity, metabolic profile, culture profile, protein RNA expression, and stability. So this is the complete summary of that. And you can see these are the top 10 clones. You can see we are presenting only top 10 clones here. We cannot present all the 500 clones here. So this is the versus clone 12 versus parental. You can see the difference. And then we summarized it that the clone 12 was less glucose and glutamine consumption rate, high lactate consumption rate. So lactate accumulation was reduced. And then we got more MAP production, therapeutic protein expression. Then we did this gene copy load check by qPCR, and we got very good outcomes here. Then try to see the feasibility aspect. So feasibility we did with the clone 12, and you can see we use this medium and feed optimization, and then we got a very improved yield. So this is the methods which we have used. We selected the right clone for map production, then we screened, then we tried to see the various type of screening protocols. So there's a process feasibility has many steps, but we use the medium feed optimization, and AI-based medium optimization was also attempted. So if you see, this is the different mediums. We tried to see the PC clone 12 in different mediums as well. And we got to conclude that PC clone was better performance as per the parental cells. Also, it received peak cell density, cell viability, and also lactate consumption profile. So this challenge was achieved, and also we got lot of PC clones which are stable as well as have a very good production of the map. So co-expression of therapeutic protein is not easy, which is having lot of limitations. This is a study we completed in 5 years. So we got these studies now in the, then we tried to see the co-expression, which because it was not tested earlier. So we did this co-expression profiling, and you can see that then again we did the fed batch because we have to focus on the maximum map production by the industry. Then we did the glycosylation as well, as so that we can understand that what is the galactosylation profile of the monoclonal antibody. So then we did charge variant. There was no charge variant study. I will show you in the last that earlier there were no charge variant study. We did that, though we didn't got very good outcome, but we did this study to learn. And then we did the glycosylation profile also, and this is the map charge variant profile. So the outcome of this research gave us a very good outcome, that is the higher cell density. You can see that 26 million, and then longevity 2 times more. We got charge variant. There was not significant impact, but we got a learning from it. And optimal PC gene 3-4 copies reported for the first time in this study. And these are the comparative study which were conducted earlier by other researchers, and this is our study. You can see here other published study and our study. Engineered a codon optimized PC gene expression in CHO cell. And also you can see the reported was 14 million, but we reported 26 million. And you can see the fourfold, it was only up to 25%. Cell viability 94% on day 14. It was earlier 75%, and day 12 was the maximum. Then titer improvement, galactosylation we improved by 2.5 fold. It was not done earlier. There was no study available up to the paper published. No charge, no significant impact on MAP charge. So this we published metabolic engineering of CHO cell for the development of robust protein production process. So these are few articles. Our learning, we used to write reviews, so we write good reviews so that we can learn more techniques and also understand that what are the different techniques coming up. So you can see this is one of the very important paper we have discussed about the various platform technologies which can be used. And gene editing, if somebody is interested on gene editing for cell engineering, they can also see this. This is all techniques what we have used. You can go through this review and you can see All techniques, cloning, fermentation, purification, everything is reviewed here. And this is the paper where we have seen this overexpression profile. This is our book where we include the all techniques. And I'm not going detail, but these are few aspects which IMS people can think about, especially the microbiome systems biology. You know that our gut is the second brain, and we should try to see about that. And also probiotics and prebiotics, that is very important. And along with systems biology for pathogen interactions, how the pathogen are interacting. And you see, this is a recent paper. I just wanted to share the idea here. Microbiome systems biology for natural well-being. Natural host microbe, and diet microbe. These are very important aspect as per the medical science is concerned. And this is our book. These are our collaborations. I'm collaborating with few doctors also, though I'm not a doctor, but I try to learn some of the aspects which you people are doing. So I'm collaborating with many people here. So laboratory, and we completed this project. And now biosimilars, medical people might be knowing about it. Biosimilar Epica is the leader because of this technology, because we have got a very good platform. We gave them the platform in 2020, and nowadays they are leaders in biosimilars, and the technology is already available. So this is my old picture, and this is our.
Thank you, sir.
So I acknowledge organizers and School of Biotechnology, IOE BHU, all collaborators, and IPCA laboratories. Thank you very much.
Thank you, sir, for nice, fabulous lecture. So the forum is open for only one question because of
And process optimization. So I have not shown much details here because of restriction of time. But when we did the medium optimization, we use MOGA, that is a multi-objective genetic algorithm, which is a form of machine learning tool, which can be used for various medium optimization. And when we use this tool, we got a better medium optimization parameters. Yeah, thank you.
So thank you. So next speaker, Dr. Anshu Singla, and he's a medical profession, did MBBS and IPS officer in last 12 years in field experience. And main topic is legal perspectives of AI in healthcare system. So because of time, please continue it if possible. Thank you, ma'am.
Can I have my presentation?
Good evening, respected audience. I will keep my presentation short, brief, crisp, and I will request you for a two-way interaction, if possible, and as far as possible. So lend me your ears for 15 minutes, and I think we will have some learning for both ends. Sir, my presentation has been sent. No, this is Dr. Arpicha. I don't know, it's not sitting on the laptop. दूसरा लगा दे।
I think he's managing somewhere.
Is it there on the laptop? It is there.
I think he's managing somewhere.
Okay. Thank you. This is the one, legal perspectives. इसके एक नीचे, हाँ जी. Yes. So artificial intelligence is the truth. It is here. And as far as the law is concerned, first the technology has come. It's in the evolving stage. Now, government has come up with a artificial intelligence governance framework, please. And first, let me have a cursory view. Okay, so who is going to move it up? Manage.
Presenter is there.
Okay. Okay. Yeah. Yeah. Got it. Yeah. Yeah. So first, what is artificial intelligence? The basic definition which is given in the framework, it is the system's ability to correctly interpret the external data. Please, I would emphasize on the word correctly, because this is something which we will touch again and again. Why? To use it to achieve specific goals and tasks through flexible adaptation. How it is possible? It is possible through complex computing algorithms and potential uses practically everything in healthcare, right from diagnosis to screening, reading of CT scans, and not only this, we have discussed almost all the topics here, drug discovery, development, as well as hospital management also, systems of accounting, systems of auditing. So AI is the reality. And one thing I can bet that everyone who is presented on this platform has used AI, including me. So I will come to the Prime Minister's vision of AI. It is to integrate inclusion, sustainability, and resilience. This is the three most important words. Inclusion, because when we bring up technology, we sometimes have the fear of losing some of the minor population groups, or the less of the ethnic, the one who are in limited number, those ethnicities may be skipped, the diagnosis may not be appropriate. Then second, sustainability. Sustainability will always come from adaptation. So here we will develop this into real-time feedback. That is the most important, that we are willing to have those real-time feedbacks, both from the developer point and as well as from the healthcare professionals. And third is resilience. The one thing which AI, I think, will really not be able to match is the human resilience, the resilience that human touch gives. This vision is led by the Honorable Prime Minister, and the vision is that AI will act as force multiplier for VIKSIT Bharat 2047, and India AI governance guidelines, they provide the framework. Okay. The most important slide, I think, which we will be developing, legal issues in AI. The first is autonomy and doctor-patient relationship. So whenever we talk of a doctor-patient relationship, it is something full of human touch. Very simple, I will example give you. A pediatrician giving a small vaccination to a small child. Vaccination to a small child. It's a routine procedure, but it's important to take the parent into confidence. It's important to take the baby into confidence. So does the anesthetist. So it is what I'm talking is that AI, we are not losing the human touch. The autonomy remains with the patient. The human decision making is with not on the machine. AI should act as force multiplier, not to stop the human touch. Second is informed consent challenges. Nothing will be done in auto mode. Suppose I give my blood sample for thalassemia research and I agree on the consent, but my blood will carry a complete profile. That profile cannot be used without my consent elsewhere. The extra data is likely to be misused. And for what time period? Third, perspective on liability. Traditionally, the perspective on liability has always been on healthcare professionals, but now it actually AI is the thing which is likely to bring the changing paradigm, whether it will sometimes physician or the institution or the developer. This question will be more described by the protocols and the written documentation. Then regulation of AI in life cycle. Life cycle means the development post-market oversight. All these three, the regulation of AI is important. Then fifth, very, very important documentation for the institutional setups, both at the developer end and for the end of healthcare professionals. We must set up committees for elaborate documentation if we are not wanting to have problems in the later end. Then patient data ownership. It's very, very important to remember that patients must own their data. They at no point it is expected that patient denies it, and there should be a provision for the patient to withdraw and delete the data whenever deemed fit. Then intellectual property rights versus transparency. This is a very important developer concern. How much of the information they will be willing to share, how much of it they will be willing to share, what algorithms they are using for the interpretation. This is the important concern. Then data privacy for the patients, data security. Data security also includes the bias of the people who are developing them. Because AI, if it is to be truly objective, we need to eliminate the biases and then the human oversight. Not to forget that human oversight is the most important. AI is supposed to facilitate us, not to replace us. This is taken from the ICMR guidelines, the ethical principles in AI. The first and the most important principle, to my mind, is autonomy. Autonomy is that healthcare decision making is not to be transferred to AI. Very, very clear on that. You may get your interpretations, whether it is for the CT scans or the mass screening, it should always, always come through human interface. And there is a model by the name of HITL model. We must use the human in the loop model to make AI more reliable. Then only it will bring trust. And the patient or the participant should have a right to refuse the consent. There should not be any kind of question from any authority once we are introducing these models. Safety and risk minimization. In this, we must ensure the dignity, the rights, and the safety and well-being of this. How we are doing it? Not by using secure systems and robust control mechanisms. And here again, the issue that the developer should put many things in the public domain. We will not place, if there's a cost benefit analysis, we will keep the patient rights above everything. Over the intellectual property rights, they must be placed and they should be tested on the ground with scientific vigor. There should be an ethical committee which should be set up to ensure that patient safety is on the highest standard. And the third principle, which I would like to say, is trustworthiness. Whatever technology we are bringing, The most important principle for that technology is trustworthiness. Unless you can trust a technology, you would never be able to implement it. Here it includes on what grounds? We have read two most important principles in the preventive and social medicine. One is the data should be valid, and the second, the data should be reliable. That is the most important, and obviously the things supposed to be lawful. Then data privacy, which is an important concern to ensure that personal and private data both are protected. And in this, I will keep coming back on the consent issue, that whenever you are taking data, first, that consent is not a one-liner consent. Earlier also it has been discussed. It is not a one-liner consent. It is a detailed human touch explanation of where the data is being used, for how long it is to be used, and representative of all the populations. And if there is some additional data, what are the provisions of deletion and how we are moving forward. This is the most important and I would say the backbone on this, that we can have this. So I have written a few points, that the user should have the control over the data, and consent should be mandatory, and there should be, because we are putting in some human biometric data, there should be absolute safety measures. Next, accountability. There's systems of audit need to be put in place, and these audit reports should also be screened rapidly over and over, because there is inherent risk of misinterpretation in the clinical setting. Yes. Then there is question of optimization of data quality. As I've mentioned repeatedly, that data should be representative of all the ethnic groups, of all the populations. If it is to be quality data, not denying to anyone, not any one population or favoring anyone, it should be a bias-free technology. Accessibility, equity, and inclusion. For the accessibility, there should be equal opportunity and access to the AI technology. This point is, less understood, less emphasized. Normally, the technology which comes is very, very urban centric, and there is a social lag phenomena. The technology will first come in the urban setting, then it will go to the rural setting. While India continues to live in villages, so there should be no accessibility gap while we are developing the technology, while we are using the technology. Otherwise, it will not be representative. I'm repeatedly emphasizing this point because AI has first make its movement in the Western world, and we are likely to not screen it before we get the technology and simply cut paste it, leading to exclusion of our groups. So it should, the technology should be providing the bias free. It should include the diverse cultural background. It should also be included in the various local languages. And this also includes a responsibility on the government to put up various infrastructure and internet connectivity, and digital divide needs to be bridged. Then the most important thing, collaboration. Collaboration, as I can see in this conference, this is a good example that where people from the engineering background, the medical background, students, developers. We recently saw a speaker before me putting mark all across the globe that you're collaborating. So this is what we need when we talk of developing good things in AI, that multiple collaborations and software, a well curated approach be adopted. The relevant laws. The first and the most relevant law is Bharatiya Nyaya Sanhita. The important sections are 106, 125, 126, 127. So most of us understand 304A of the IPC, which reads as any death caused due to rash and negligent act and not amounting to culpable homicide. So this section gives 5 years punishment, 10 years punishment in case of hit and run case, and 2 years of punishment in case of negligence by medical professions. It is now replaced by BNS 106. I want that we should go and read up, just as we do in forensic medicine, some basics, these sections we should read. The Consumer Protection Act. So for the paid services, all those who are in paid services, one who paid for the services comes under the definition of consumer. So the Consumer Protection Act will also be relevant to this. Next is Section 43A of the IT Act. And very important, Digital Personal Data Protection Act 2023, whose basic representation I'm giving in my next slide. So this is an overview of the Digital Protection Act. It applies to processing of digital personal data inside, within India and outside India, if the services are being offered in India. So anywhere across the globe, if you are doing, then you are this thing. And only that exemption is made which is for purpose of national security, and there is a protection board. And here also the main obligation of fiduciaries is to obtain consent and maintain the security of the data. And it there is a right to erasure of data. So these are the things which we have discussed in my earlier slides also. Next, we have, I broadly visualize AI under two heads. One is the SOPs for the developers and other is the SOPs for the healthcare professionals. तो ये जो developers हैं वो consent, very very important, and consent should be informed and the patient should have the right to withdraw. And in this, the data sample should not discriminate or marginalize any community if it is truly objective and representative technology. Then there should be a provision of real-time communication of both positive and false negative. So this liability is on both the side, healthcare professionals as well as the developers. Provision of the deleting data, regular auditing of the algorithm, and training of healthcare professionals should also be there. Very important, a compensation policy and should be audit and compensation policy is important. So do we have time or is it half time? Okay. So best practices in AI for healthcare professional is that we should put up sufficient awareness, whether in the institutions or while we are guiding the patient or on the website, wherever the opportunity comes. Informed consent of the patient. Documentation and reports, very very important. I have seen it from both the sides, doctor and police. Whenever we suffer our poor documentation. Medical and ethical committee at the level of institutions, a very good dispute resolution mechanism to be in place, continuous training of doctors about technology, and real-time feedback to developers. These are the All India governance guidelines. I will have a cursory view. Why I put up? Because in India, this is the vision of the government. We must see this vision so that whatever we decide for our institute, whatever the developer decide, they always have the preamble and the mantra of the government in the mind. There are 7 sutras, then 6 pillar recommendation, then short term, medium term, long term goals, and some guidelines for the industry actors. Trust people first, innovation, design safety, accountability, fairness, resilience, and sustainability. Pillars, this is on the government, infrastructure, capacity building, policy, risk mitigation, accountability, and institutions building. Short-term plan, this is very, very important. We can also borrow from the government that we will be establishing institutions at level of us, maybe committees, then developing frameworks, which are the areas where we are expecting the crowd and the litigation, then legal amendments, if there are any, real-time feedback, liable regime, expand the infrastructure awareness program, and increase awareness of the AI safety tools. These are the medium term that expand it, publish the standards, and these are the long term. Thanks, Vivek. Maybe it's taking up time. Okay, so this I will like to just share there are a few questions which are asked commonly, that what are the ethical considerations in AI? The first and the most important ethical consideration is consent, and don't dehumanize the treatment. Don't give the decision making to the machine. Then what are the, has it impacted informed consent? It is on us. Are we informing, or we are just taking the signatures? Who is liable if patient is harmed by AI in healthcare? Earlier, only doctors. Now, developers also need to be aware. What steps can we take? SOPs have been discussed. What aspects of AI can be regulated? I think all the aspects, whether it is a development and whether it's enforcement, and what are the potential risks. I think the most important risk that I see of AI is that we may be discriminatory, we may not value the human consent, and we may dehumanize treatment. Yes, AI is to make the treatment reach to the masses, but it should not make us feel a patient like a mass approach. Every patient is very dear to the doctor, and just because the numbers are more, should never, never dehumanize the treatment. So you should question everything that I have spoken, so that the learning is very, very mutual. Beyond 1 minute also we can go. If I cannot answer everything, but I can accept the questions.
Thank you, ma'am, for giving nice and fabulous lecture. So I think that is open
But,
forum for
yes.
question.
Any questions, please?
So any question, but two questions.
Yes.
As you are from the legal background, and I want to know that we are being a clinician, we're providing data to some developers. They are collecting the data of the patients and they are using in the AI. Nowadays, it is getting too much advanced in the AI. Suppose AI nowadays, you know that Anthropic and this kind of new generation advanced AI has came in the market. Suppose the AI is itself misusing the data, then who will be responsible for this? Developer, we are collecting the data, we are, or the AI itself? Is there any provision for the punishment of the AI itself as per your?
Okay, I will talk of India specific view. So in India, the law is at the development stage. So technology proceeds earlier and the law is developing. That's why I've said that there is, you would see that this presentation is slightly non-specific. Why? Because there is no law on AI. What is there is a all India governance framework, right? And what is there, that ICMR has released the guidelines, that is there. So whenever you are providing the company, first where you are practicing, please write it on the awareness class, and please take a written consent, explained consent. So your liability will then shift to the developer. If the AI is misusing it and you have taken a written consent, the liability will be on the developer. This is to my mind.
Madam, how much percentage of AI is used in cyber technology, cyber security?
A lot. A lot. Sir, numbers I don't have, because again,
No, no,
I will not.
percentage.
Sir, numbers I don't have, because I have not come across any such report. Because many times we are using AI, but not documenting it. Like I can bet on this that every user who has come has used some degree of AI in this. But are we documenting it? Even the presentations are tutored by the AI. In cyber frauds or technology, everything is AI. The websites are being made, there is fake WhatsApp. So it is rampant, but documentation generally, it is like the iceberg. In the iceberg, only small tip is visible. And from this thing, this slightly off the track, but policing point, I can tell you that technology use, whether in Jamtara or in Haryana's Nu, is not by skilled misuse. Technology misuse is not by skilled people. It is by people who are not even graduates. So this we have to understand, that whenever you are just downloading apps and you say accept all, cookies accept all, data given accept all. So as doctors, don't do that accept all. Please make it the condition whenever you are accepting the softwares.
मैडम मेरा प्रश्न तो आपसे, ऐसे आप आईपीएस हैं,
जी सर।
तो 304/A ये हम डॉक्टर्स को बहुत परेशान कर रही है। 304A में पहले जो था वो था जुर्माना या लीगल पनिशमेंट, जेल, लेकिन अब उसमें और नहीं है, अब एंड है। जुर्माना और लीगल प्लेसमेंट जेल दोनों है। जबकि छोटी जगहों में जो जजमेंट होता है, वो जो क्लाइंट है वो जज का रिलेशन भी हो सकता है। हर मरीज अपने वकील को जैसे पढ़ाता है, कभी कभी वकील भी कुछ ढंग से नहीं अपने केस को प्लीड कर पाते हैं। तो डॉक्टर्स की तो पूरी पूरी तपस्या चाहे 40 साल की हो, 1 मिनट में चली जाती है जब वो जेल में चला जाता है। हर मरीज आके कहता मुझे गलत इंजेक्शन लगा दिया। इंजेक्शन ना वो बनाता है, किताबों पढ़ के देता है, फैक्ट्री बनाती है, पर पूरी लीगल पर्सनल जो जिम्मेदारी डॉक्टर पर आ जाती है, वो जेल चला जाता है। कैसे इससे बचा जाए, क्योंकि आप दोनों फील्ड को बिलोंग करती हैं।
जी सर। सर, आपने बड़ा महत्वपूर्ण सवाल पूछा है। मैं आपको 2-3 चीज़ें अपने पर्सनल उससे बताना चाहूँगी कि आज के दिन में वो ज़माना चला गया है जब आप पेशेंट के बिहाफ़ पे डिसीज़न लेंगे। मैंने अपनी स्लाइड के दौरान एक चीज़ कही कि सबसे बड़ा जो मुझे रिस्क लगता है, वो ये है कि ट्रीटमेंट को हम डेलीगेट ना कर दें, डीह्यूमनाइज़ ना कर दें और कंसेंट को। क्यों ये बात बार-बार स्लाइड में आई है? डॉक्टर को अगर बचना है, आपने मान लीजिए कि अवेयरनेस के लिए हर जगह पे लिख रखा है कि जो ये वाला पर्टिकुलर ट्रीटमेंट है, मान लीजिए कि आप कंप्यूटेड टोमोग्राफी में ही दे रहे हैं, एआई का यूज़ कर रहे हैं, तो उसका जो फॉर्म देंगे, उस पे आप 3-4 कॉलम बना दीजिए कि ये वाला जो इंटरप्रिटेशन है, ये एआई का स्टील को यूज़ किया है, इसकी ये है और मेरे कमेंट्स ये हैं और इसका फेलियर ये है। ये एक आपका अवेयरनेस का मॉडल हो गया कि आपने अपना जो यूज़ कर रहे हैं। दूसरा, आपने सेकंड टाइम इन्फॉर्म कंसेंट दिया और लिख दिया आई हैव एक्सप्लेन्ड। थर्ड, आपने डॉक्यूमेंटेशन टाइम पे टेक्नोलॉजी को लिख दिया और फोर्थ, और जो मुझे लगता है सबसे महत्वपूर्ण है, पहले जो पेशेंट्स थे वो डॉक्टर को भगवान की तरह देखते थे। इस बात से तो काफ़ी लोग राज़ी होंगे। इसका एक छोटा-सा उदाहरण देती हूँ कि जब गायनेकोलॉजिस्ट किसी बेबी को डिलीवर, गायनेकोलॉजिस्ट के यहाँ मिठाई खत्म नहीं होती थी, ठीक है ना? और अब पेशेंट जाके क्या सोचते हैं कि यार सी सेक्शन कर रहे हैं तो पक्का पैसे बनाने के लिए कर रहे हैं, तो उनका अप्रोच बड़ा शिफ्ट हो गया। आजकल गायनेकोलॉजिस्ट क्या करते हैं, वो बताते हैं। तो आप एआई के थ्रू डिसीजन मत लीजिए, आप पेशेंट को समझा दीजिए कि भाई आपका ये रिस्क प्रोफाइल है और ये ट्रीटमेंट ऑप्शंस अवेलेबल हैं और उसे डॉक्यूमेंट कीजिए। डॉक्टर्स हों या पुलिस वाले हों, वो समय चला गया है जिसे मैं अगर अपनी भाषा में बोलूँ, तो मैं बोलती हूँ एक कैफेटेरिया अप्रोच। पुलिस में भी बहुत बारी ऐसा होता है कि जैसे कुछ झगड़ा हमारे पास दहेज का या कुछ आता है, तो हम कभी नहीं कहते बेटा बस जा, कल को लड़के फिर आ जाएँगे, हम कहेंगे खुद नहीं बच पा रही, हम ऑप्शन दे देते हैं कि देखो आप बचेंगे तो ये आपके पास लीगल राइट्स है, आप अलग होना चाहते हैं तो ये इसके इम्प्लीकेशंस है। तो डॉक्टर को भी ये 4-5 ही चीज़ें हैं, इनको आप पकड़ के रखिए। अवेयरनेस, कंसेंट, डॉक्यूमेंटेशन, अगर आप इंस्टीट्यूशन हैं तो ऑडिट कमिटी, डेवलपर के साथ पैक्ट, जितना हो सके संभव कंपनसेशन पॉलिसी, क्योंकि आप कंज्यूमर प्रोटेक्शन एक्ट में आएंगे, रेगुलर ट्रेनिंग्स और सबसे महत्वपूर्ण बात कैफेटेरिया अप्रोच। बाकी सर 100% जैसे क्या कहते हैं, हमें बचपन में सिखाया गया था, बचपन मतलब एमबीबीएस का बचपन, क्या सिखाया गया था, डॉक्टर्स ट्रीट, गॉड क्योर्स। वैसे ही मैं अपने एक्सपीरियंसेस शेयर कर सकती हूँ। 100% प्रूफ कुछ नहीं है, बट अगर आप थोड़ा-सा मेरे एक स्लाइड पे जाएँगे, जो बेसिक्स मैंने एक्ट उसमें लिखे हुए हैं, आईटी एक्ट है, डाटा प्रोटेक्शन एक्ट है और एक डॉक्यूमेंट मैंने लिखा है कि आईसीएमआर का एक एथिकल फ्रेमवर्क का डॉक्यूमेंट है, 68 पेजेज़ का, उसको आप लोग सब पढ़ें। वो मेरी प्रेज़ेंटेशन का एक कोर फ़ोकस है, उसको आप ज़रूर पढ़ें। वो एथिकल गाइडलाइंस है और हर जगह उसको एक अपने हिसाब से बना के लगाएँ।
मैम
सीएमआर का एक रिसर्च डॉक्यूमेंट है, एथिकल प्रिंसिपल्स
सर,
ऑफ यूज़ इन एआई।
इफ यू परमिट लास्ट क्वेश्चन, मैम अभी लेटेस्ट जो डीपीडीपी एक्ट आया है 2023,
डाटा।
आपको लग रहा है कि उसकी वजह से जो रिसर्च है वो अफेक्ट होगी? इतने रूल्स स्ट्रिक्ट हो गए हैं रिगार्डिंग डाटा प्राइवेसी और सिक्योरिटी, तो जो भी चाहे इंस्टीट्यूशनल लेवल पे डाटा है जिसकी वजह से रिसर्च होती थी या बड़ी बड़ी प्राइवेट कंपनीज हैं, पहला पॉइंट तो ये है। और दूसरा, अगर डीपीडीपी एक्ट में डॉक्टर रिस्पॉन्सिबल है तो उसके ऊपर क्या मतलब जैसे पनिशमेंट हो सकती है, इम्प्रिजनमेंट हो सकती है, कोई फाइनेंशियल पनिशमेंट है, क्या है इसमें? राइट।
जो डॉक्टर का एक पनिशमेंट का रूल है, वो 2 इयर्स इम्प्रिजनमेंट का है। कंज्यूमर प्रोटेक्शन में लायबिलिटी जो है वो फोरम्स डिसाइड करते हैं। ये तो लीगल बात होगी। बट मैं आपसे एक सवाल पूछती हूँ, आप लोगों में से कितने लोग सर्जिकल फील्ड से बिलॉन्ग करते हैं? हैं सर? आप सर वेटरन हैं, तो मैं आपसे एक सवाल पूछूंगी, क्या आपने हर पेशेंट जिसको ऑपरेट किया उसने आपको बताया मैं HIV पेशेंट हूँ, HIV पेशेंट हूँ, HBV कैरी कर रहा हूँ? नहीं बताते ना, कभी नहीं बताते, छुपाते हैं, होता है ना ऐसा। तो ये कुछ चीजें ऐसी हैं सर जो जो हमारे ऑक्यूपेशनल हैजार्ड्स हैं। जैसे हम लोग जाते हैं, हमें भी नहीं पता कि सामने से जा रहे हैं और अगले वाला एसिड फेंकेगा या गोली फेंकेगा, या अभी रिसेंटली आप देखेंगे एक हम मेला ड्यूटी एक इंस्पेक्टर सूरजकुंड में कर रहे थे और वो प्रिवेंट करने गए और झूला गिर गया, ही वाज ड्यू फॉर रिटायरमेंट। कुछ ऐसे रिस्क हैं जिसका कोई जवाब नहीं है, बट हम एसओपीज बेस्ट अडॉप्ट कर सकते हैं। एंड डेफिनेटली सर, जब बहुत स्ट्रिक्ट प्रोटोकॉल्स होती हैं तो थोड़ा इम्पैक्ट होता है, बट मुझे लगता है कि रिसर्च मॉडल्स में अगर हम कॉन्सेंट का रिटन प्रोसीजर्स को डॉक्यूमेंट करते हैं तो ये हमेशा ही बैटल चलता रहेगा और ये कभी एंडिंग नहीं है। प्राइवेसी का ऐसी एक दूसरा जो बैटल चलता रहेगा कि डेवलपर आपको बताएगा नहीं, ट्रांसपेरेंसी रख नहीं पाएंगे क्योंकि उनकी लिमिटेशन है, उनके इंटेलेक्चुअल प्रॉपर्टी राइट्स है, और आप चाहेंगे कि वो सारा एल्गोरिदम दे ताकि आप प्रिडिक्ट कर पाए पेशेंट को कि कितना परसेंट मेरा data appropriate hai. That is very, very relevant. That's why I'm saying that top level institutions should invest their energy in developing good SOPs and publishing and making the patient aware. और सबसे बड़ा challenge जो मैं देख पा रही हूँ वो है digital divide, urban divide and sensitization. For that I am actually acknowledging and very thankful to IMS BHU for hosting such a good conference, such a good conference, such a good
Thank
work.
you, ma'am. Thank you.
That they have acknowledged the challenge. And thank you, I have overshot my time.
No.
But I please, the phone number can also be made public so that if anyone, it's a very, very mutual learning. There are many case laws, some countries have implemented it, UK, Netherlands, they are already using it. So if anything in detail, I'm posted at Gurgaon. You can always reach out
मैम
to
हम
me.
लोगों के आप इंस्पिरेशन है, हम तो चाहते हैं कितने डॉक्टर में इतने लोग आईपीएस बने, डीएम बने, ताकि हम प्रोटेक्शन में रहें थोड़ा।
बिल्कुल रहेंगे।
AI के
मैं ये जरूर कहूंगी सर कि जैसे फोरेंसिक मेडिसिन हम पढ़ते थे खुद, मैं ये चाहती हूँ कुछ मोटे मोटे एक्स डॉक्टर्स पढ़ के रखें और जो भी बंदा प्रैक्टिस कर रहा है वो कर ले। थोड़ा सा जो बंदा अनअवेयर होता है उसको जल्दी पकड़ा जाएगा। जैसे आप हमेशा अगर डबल ग्लव लेके चलते हैं, यूनिवर्सल प्रोटेक्शन, तो सर्जन को कम रिस्क है। तो उसी तरह अगर अवेयरनेस, एसओपी, डॉक्यूमेंटेशन, कैमरा, सब चीजें इन पोजिशन है तो फिर रिस्क कम है। वही है मेरा कहना। बाकी तो वो स्लाइड आई थी सर, आईटी एक्ट सर, आईटी एक्ट, कंज्यूमर प्रोटेक्शन एक्ट, आईपीसी, आईपीसी का जो सेक्शंस हैं सर 106 जरूर पढ़ लीजिए। सेक्शन सॉरी, भारतीय न्याय संहिता का सेक्शन 106 हो गया, पहले जो 304 आईपीसी था। कंज्यूमर प्रोटेक्शन एक्ट है और एक आईटी एक्ट का सेक्शन 43A है, वो जरूर पढ़ें। ये 3-4 सेक्शन आप जरूर पढ़ लें। बाकी मेरा फोन नंबर आप स्पीड डायल पे रखें 9463049502 9463049502
फर्स्ट ईयर स्टूडेंट के लिए
9463049502। जी सर, हम बाद में भी ले सकते हैं। क्या सर?
So
सारे नंबर उठाती
just
हूँ
for
सर, मैं एक इमरजेंसी सर्विस में हूँ और मैं 100% फोन कॉल्स उठाती हूँ। ये मेरा आपको अश्योरेंस है। मैं तो वो वाले फोन कॉल्स भी उठाती हूँ जो पॉलिसी बेचने वाले होते हैं, फिर मैं उन्हें कहती हूँ मुझे लोन नहीं चाहिए। आई एम हैप्पी।
yeah, so
थैंक यू सो मच।
thank you again. Our next speaker is also IPS, Dr. R.P. Jain, who is our own alumnus, MBBS from IMS BHU. He is basically involved in policy level analysis of artificial intelligence in law enforcement, healthcare governance, and education systems with a focus on regulatory safeguards and accountability. So with that, let's welcome the speaker.
आप सभी को मेरा सादर नमस्कार। आज मैं हेल्थ केयर में एआई के प्रयोग से जुड़ी कुछ कठिन चुनौतियों पर चर्चा करूंगा, विशेष रूप से इम्प्रेसिव डेमोन्स्ट्रेशंस और सुरक्षित रियल वर्ल्ड क्लिनिकल डिप्लॉयमेंट के बीच जो अंतर है। अधिकांश क्षेत्रों में 99% एक्यूरेसी उत्कृष्ट मानी जाती है, लेकिन स्वास्थ्य सेवा में 99% एक्यूरेसी और 1% इनएक्यूरेसी हजारों रोगियों को नुकसान पहुंचा सकती है। इसलिए हेल्थ केयर एआई केवल टेक्नोलॉजी प्रोजेक्ट नहीं है, ये एक पेशेंट सेफ्टी प्रोजेक्ट भी है। इन हेल्थ केयर 99% accuracy isn't excellence, It's 10,000 dead or suffering patient per million. हेल्थ केयर अन्य डिप्लॉयमेंट डोमेन से मूलतः अलग है। बैंकिंग में गलती को सुधारा जा सकता है, ई कॉमर्स में गलत सुझाव को अनदेखा किया जा सकता है, लेकिन मेडिसिन में गलत निर्णय किसी रोगी को स्थायी नुकसान पहुंचा सकता है। यहाँ कोई रोल बैक का बटन नहीं होता। हेल्थ केयर कड़े रेगुलेटरी, लीगल और एथिकल ओवरसाइट के अंतर्गत भी संचालित होता है। यहाँ त्रुटि की स्वीकार्यता, टॉलरेंस फॉर एरर अत्यंत कम है और कम ही रहना चाहिए। टेक्नोलॉजी तेज विस्तार यानी कि रैपिड एक्सपेंशन को प्रोत्साहित करती है, जबकि मेडिकल फील्ड पहले प्रायर वैलिडेशन और प्रमाण की मांग करता है। इसी मूल अंतर के कारण एआई एडॉप्शन में सबसे बड़ा रेजिस्टेंस उत्पन्न होता है। एआई एडॉप्शन के जो चैलेंजेस हैं उनको मैंने इस स्लाइड में दिखाया है और प्रमुखतः 5 जो हैं वो प्रमुख श्रेणियां हैं। सबसे पहले तो डाटा का चैलेंज, जैसे खराब डाटा क्वालिटी है, अधूरे डाटा सेट्स हैं, स्टैंडर्डाइज्ड डाटा फॉर्मेट्स नहीं है, सबके फॉर्मेट अलग-अलग हैं, विभागों के बीच डाटा सिलोज हैं, रियल टाइम डाटा तक सीमित पहुंच है, जो रियल टाइम डाटा आ रहा है क्योंकि हर जगह रिकॉर्डिंग का टाइम भी डिफरेंट होता है, प्लस कमजोर डाटा गवर्नेंस फ्रेमवर्क्स हैं। अगर हम ऑर्गेनाइजेशन की बात करें तो ऑर्गेनाइजेशनल चैलेंजेस हैं कि जो वर्क फोर्स है उसमें कई बार रेजिस्टेंस टू चेंज होता है। जैसे अभी मेरी बाहर किसी से एआई पे डिस्कशन हो रहा था, तो अब इतना एडवांसमेंट हो रहा है, हर वीक कुछ ना कुछ नया अपडेट्स आ रहा है और वो मैंने देखा कि लोग उसको अडॉप्ट नहीं करते हैं। नई प्रॉम्प्ट इंजीनियरिंग के कोर्सेज हो रहे हैं, नए प्रॉम्प्ट आ रहे हैं। अभी चैट जीपीटी ने अपना कुछ वो किया है, बहुत अच्छे रेफरेंस आने लगे। पहले उसमें रेफरेंस नहीं होता था, वो हेलुसिनेट करता था, यानी आपने कुछ मांगा, अगर उसके पास इन्फॉर्मेशन नहीं है तो कुछ भी मन से इन्फॉर्मेशन देगा। मैं आगे बताऊंगा। तो ये सारी चीजें जो है हमको कंटिन्यूसली लर्निंग करना होगी, अपने आप को कंटिन्यूस अपडेट रखना होगा, जो भी एआई में नई चीजें आ रही हैं। स्किल गैप है और हमारे प्रोफेशन में एआई जो प्रोफेशनल ट्रेनिंग होना चाहिए, हमने मतलब उससे तो सीख लिया उसको यूज करते करते, लेकिन ट्रेनिंग हम लोग नहीं कर रहे हैं अभी भी। फिर नेतृत्व स्तर पर पर्याप्त प्रतिबद्धता नहीं है और इनोवेशन जो है उस वो भी एक हमारे यहाँ माइंडसेट बैरियर्स है कि नया इनोवेशन क्या करना है। कुछ स्ट्रेटेजिक चैलेंजेस हैं कि स्पष्ट एआई विजन और रोडमैप को लाने में कुछ कठिनाई है। रिटर्न ऑफ इन्वेस्टमेंट को लेकर अनिश्चितता है। पायलट प्रोजेक्ट्स को कैसे हम मास स्केल पर ले जाएं, वो भी हमारे यहाँ अभी इशू है। और एआई इनिशिएटिव्स और जो भी हमारे ऑर्गेनाइजेशनल गोल्स हैं उसमें भी कोहेरेंस नहीं है। फिर कुछ टेक्नोलॉजी चैलेंजेस हैं कि अभी भी हमारे यहाँ डिजिटल इंफ्रास्ट्रक्चर जो है वो अपर्याप्त है। जैसे कई जगह है हमारे रूरल सेटअप में रिकॉर्ड ही नहीं होते जो केसेस आते हैं। फिर लीगेसी सिस्टम्स चल रहे हैं, जो पुराने सॉफ्टवेयर्स हैं उन्हीं को हम यूज़ कर रहे हैं, जिनका इंटीग्रेशन करना बड़ा मुश्किल होता है, जो न्यू एआई टेक्नोलॉजीज आ रही हैं। फिर विभिन्न प्लेटफॉर्म के बीच इंटरऑपरेबिलिटी का इशू है। फिर सीमित उनकी एक्सप्लेनेबिलिटी है, ये भी मैं अभी बाद में बताऊंगा। एक ब्लैक बॉक्स प्रॉब्लम होती है और साइबर सिक्योरिटी वल्नरेबिलिटीज हैं हमेशा। एथिकल एंड रेगुलेटरी चैलेंजेस हैं जिसमें कि एलोगरिथमिक बायस है, उस पर मैं अभी डिटेल में बताऊंगा कि कैसे कुछ जो डाटा शेयर होता है वो रूरल अर्बन डिफरेंस है, उसमें अमंग द पॉपुलेशन, चाहे वो वाइट पॉपुलेशन ब्लैक पॉपुलेशन डिफरेंस है, तो वो रिजल्ट उसके अलग देता है। साथ ही अकाउंटेबिलिटी लायबिलिटी से जुड़ी समस्याएं हैं और थोड़ी सी ट्रांसपेरेंसी की कमी है एआई डिसीजन मेकिंग में। अभी एआई कॉन्फ्रेंस हो रही है दिल्ली में रिसेंटली, तो गवर्नमेंट का ये बहुत पेट प्रोजेक्ट है कि इंडिया को एआई में सबसे ज्यादा जो है आगे बढ़े। और अभी कई इंडियन स्टार्टअप्स हैं जो इवन हार्वर्ड में भी पढ़ा रहे हैं एआई, तो इंडिया इज लीडिंग इन दिस रेस। सबसे पहले अब मैं एक्यूरेसी मिथ पे आऊंगा कि हम अक्सर जो रिसर्च पेपर है उसमें बहुत उच्च एक्यूरेसी एयूईसी स्कोर्स देखते हैं, विशेषकर एआई के जो रिसर्च हो रहे हैं, लेकिन क्लिनिकल प्रैक्टिस जो है वो कोई क्यूरेटेड डाटा सेट नहीं है। डॉक्टरों को आवश्यकता होती है कि उनके अपने पेशेंट पॉपुलेशन पर परफॉर्मेंस अच्छा हो, रियल टाइम में परिणाम आए, मौजूदा क्लिनिकल वर्कफ्लो के भीतर जो अनसर्टेन कंडीशंस हैं उसमें भी वो विश्वसनीय निर्णय ले पाए। तो अक्सर जो मॉडल टर्शरी सेंटर्स के डेटा से प्रशिक्षित होते हैं वे कम्युनिटी सेटिंग या रूरल सेटिंग पे अच्छा परफॉर्मेंस नहीं कर पाते। और एक महत्वपूर्ण पैराडॉक्स है कि एआई जो है वो कई जो स्पष्ट मामले हैं यानी बहुत ऑब्वियस हैं उसमें तो बहुत बेहतर रिजल्ट देता है, लेकिन जो बहुत एक्सेप्शनल सिचुएशंस हैं उनमें अच्छा रिजल्ट वो नहीं दे पाता। तो जो प्रकाशित एक्यूरेसी और जो वास्तविक क्लिनिकल यूजफुलनेस है वो उसमें काफी डिफरेंस मिलता है। इसी तरह एक डाटा प्रॉब्लम है कि जो हेल्थ केयर डाटा अभी है इंडिया में वो उतना मशीन लर्निंग रेडी नहीं है अभी भी। जैसे हैंड रिटन नोट्स हैं या दूसरी चीजें हैं, जो हमारे इलेक्ट्रॉनिक हेल्थ रिकॉर्ड्स हैं जो हॉस्पिटल्स में, वो जनरली बिलिंग और डॉक्यूमेंटेशन के लिए बनाए गए थे, बहुत ज्यादा एआई एल्गोरिथम के लिए बने नहीं है। जो क्लिनिकल नोट्स हैं वो अधिकांशतः फ्री टेक्स्ट या हैंडराइटिंग में होते हैं और कई स्ट्रक्चरल फील्ड्स उसमें अधूरे रहते हैं, मिसिंग डाटा है बहुत सारा। और जो टाइम स्टैम्प्स हैं यानी कि किस टाइम हम एंट्री कर रहे हैं, वो भी कई ज़्यादातर अस्पताल में विलंब से दर्ज की जाती है। तो इसी प्रकार जिस डेटा सेट को एआई मॉडल देखता है, वही वास्तविकता में पूर्ण जो है उसको निर्माण करेगा अपने एआई मॉडल को। तो इसमें बड़ा इम्परफेक्ट रिकंस्ट्रक्शन है अभी। तो इसके कारण जो हमारा मॉडल है वो बड़ा फ्रेजाइल हो जाता है। इसके अतिरिक्त तो जो डाटा हम रिकॉर्ड कर रहे हैं, तो एक ही डायग्नोसिस को अलग-अलग हॉस्पिटल में अलग कोडिंग के साथ दर्ज किया जा सकता है और इसके कारण विभिन्न अस्पतालों में जो है वो डिफरेंस मिलता है, जो हम डाटा वहाँ से ले रहे हैं। इवन विभिन्न डिपार्टमेंट्स में भी उसका डिफरेंस है। जो क्लिनिकल हैबिट्स हैं हमारी, वो भी कोडिंग को प्रभावित करती हैं और जो स्ट्रक्चर्ड एंट्रीज़ हैं, वो भी हम कई बार जो बहुत न्यूसेंस हैं, जो छोटी-छोटी सूक्ष्मताएँ हैं, उनको पकड़ नहीं पाते हैं। इसी तरह जो हैंड रिटन नोट्स हैं, वो बहुत महत्वपूर्ण सिग्नल होते हैं, लेकिन उसे भी हम स्टैंडर्डाइज़ करने में जो है डिफ़िकल्टीज़ आती हैं। तो इन कारणों से मॉडल की जो क्रॉस इंस्टीट्यूशनल रिलायबिलिटी है, वो कम हो जाती है। हेल्थ केयर एआई में बायस केवल एथिकल कंसर्न नहीं है, वो सीधे तौर पर पेशेंट सेफ्टी का इशू है। डॉक्यूमेंट्री उदाहरण मौजूद है जहाँ की पल्स ऑक्सीमीटर डिवाइसेस जो हैं, वो डार्क स्किन पेशेंट्स में ऑक्सीजन स्तर की कम सटीक रीडिंग देते हैं, जिससे उपचार में देरी होती है और क्लिनिकल आउटकम भी प्रभावित होते हैं। देयर आर यूएस एफडीए स्टडीज भी हैं वहाँ पर और कई रेगुलेटरी इसमें कंप्लेंट भी आई हैं। इसी प्रकार जैसे कि कुछ सेप्सिस प्रेडिक्शन के एल्गोरिथम्स हैं, जो कि सेम फिजियोलॉजी वाले लोगों में भी व्हाइट और ब्लैक्स में उनका डिफरेंस होता है। और कई बार जो डार्क स्किन पेशेंट है, थोड़ा रिसर्च उसमें कम हुआ है, तो वो उसको राइट टाइम पे फ्लैग नहीं कर पाते हैं। तो ऐसी असमानताएं केवल टेक्निकल इश्यूज नहीं है, ये बल्कि हेल्थ डिस्पैरिटीज को भी और गहरा करती हैं, हेल्थ डिस्पैरिटीज को और वाइड करती हैं। इसलिए जो एआई बेस्ड मिटिगेशन है, वो कोई वैकल्पिक सुधार नहीं है, बल्कि एक अनिवार्य सेफ्टी सेफगार्ड है। मैं थोड़ा-सा जो अंडर रिप्रेजेंटेटिव डाटा है, उसके कई सारे जो हैं एग्ज़ाम्पल्स हैं। तो जो भी इनकम्प्लीट डाटा आता है, उसके कारण कई दिक्कतें जो हैं वो आती हैं, जैसे कि ट्रीटमेंट में देरी होना, रिस्क का गलत आकलन होना, उपचार जो है उसकी अनुरित जो है अनुचित प्रायोरिटीज़ जो हैं वो आती हैं और इसका अर्थ ये कि जो जो हमारा मॉडल है वो टेक्निकल रूप से तो काम कर रहा है, लेकिन वो प्रैक्टिकली या व्यावहारिक रूप से असमान है और अन्यायपूर्ण स्वास्थ्य सेवाएँ दे रहा है। इसलिए जो भी डाटा सेट डाइवर्सिटी है, उसको उसका डेमोग्राफिक वैलिडेशन करना बहुत ज़रूरी है और सिर्फ रिसर्च रिक्वायरमेंट नहीं, बल्कि क्लिनिकल फेयरनेस और सेफ्टी पर भी ध्यान देना ज़रूरी है। और कुछ जो बायस फाइंडिंग आई है कि जैसे डर्मेटोलॉजी के जो एआई सिस्टम्स बने हैं, वो डार्कर स्किन टोन्स पे कम एक्यूरेट हैं। इसी तरह टर्शियरी केयर सेंटर्स पे या जो वेस्टर्न मॉडल्स हैं, वो डेवलपिंग कंट्रीज़ में उतने सटीक रिजल्ट्स नहीं देते हैं। जो टर्शियरी केयर मॉडल्स हैं, वो रूरल एरिया में उतने अच्छे रिजल्ट्स नहीं दे रहे हैं। एक ग्राउंड ट्रुथ प्रॉब्लम है कि मशीन लर्निंग के लिए सही लेबल्स होना बहुत आवश्यक है, लेकिन चिकित्सा विज्ञान में अक्सर पूर्ण और निर्विवाद ग्राउंड ट्रुथ उपलब्ध नहीं हो पाता, क्योंकि विशेषज्ञों के बीच मतभेद है, क्लिनिकल गाइडलाइन समय के साथ बदलती रहती हैं, डायग्नोस्टिक डेफिनेशंस भी जो हैं वो टाइम टू टाइम विकसित होती रहती हैं। इवन कुछ स्पेशलिटीज़ में जो विशेषज्ञ हैं, उनके बीच में भी 70 टू 80% ही कंसेंट होता है किसी भी इश्यू को लेकर। तो यदि मूल लेबल्स ही अनिश्चित हैं, तो मॉडल भी उसी अनिश्चितता को सीखते हैं। और एआई सिस्टम उसी डेटा से जो है मशीन लर्निंग करते हैं और रिजल्ट्स देते हैं। तो ये विशेषज्ञों की त्रुटियां और ऐतिहासिक जो हिस्टोरिकल बायस है, वो भी अपने साथ ले लेते हैं। और इस सीमा को स्वीकार करना ही हमको हमेशा मालूम होना चाहिए कि ये इसका लिमिटेशन है एआई का। इसी तरह अगर क्रिटिकल केयर और आईसीयू सेटिंग में आए, तो कई बार वहाँ मिनटों में, सेकंड्स में हमको डिसीजन लेना होते हैं। रात को 3 बजे अगर एक थका हुआ क्लिनिशियन आता है, जिसके पास बहुत बड़ा मॉडल रीजनिंग चार्ट्स, इंपॉर्टेंट ग्राफ्स, प्रोबेबिलिटी कर्व्स हैं और उसको अगर समझने का कई बार टाइम नहीं होता, तो उसको या तो सिस्टम पे तुरंत भरोसा करना है या उसे पूरी तरीके से नज़रअंदाज करना है। तो बहुत बड़ा कई बार जो बहुत ट्रांसपेरेंट मॉडल्स हैं, जो बहुत रूल बेस्ड सिस्टम हैं, उनकी एक्यूरेसी कम हो जाती है। और कई जो बहुत एक्यूरेट डीप लर्निंग मॉडल्स हैं, वो बेहतर प्रेडिक्शन दे देते हैं, हालाँकि वो उतने रूल बेस्ड नहीं होते हैं। तो इसको ब्लैक बॉक्स फिनोमेना देते हैं कि एग्ज़ैक्टली एक्सप्लेनेबिलिटी नहीं है उस मॉडल की, बट स्टिल इट इज़ गिविंग एग्ज़ैक्ट प्रेडिक्शन और क्या जो है किसी भी क्लिनिशियन को डिसीज़न लेना है। वो हेल्थ केयर हमें सिखाता है कि केवल एक्सप्लेनेबिलिटी या केवल एक्यूरेसी पर्याप्त नहीं है, हमें ऐसा संतुलन विकसित करना है, जहाँ मॉडल क्लिनिकली वैलिडेटेड हो, रिस्क थ्रेशोल्ड स्पष्ट हो और क्लिनिशियन का जो अंतिम निर्णय है, वो सर्वोपरि हो। हमें एक सुरक्षित, समयबद्ध और विश्वसनीय डिसीजन सपोर्ट सिस्टम जो है, वो बनाना होगा। इसी तरह कई एड्स केसेस होते हैं, जो एआई होता है वो जनरली जो एवरेज पेशेंट है उसका डाटा लेता है, लेकिन वास्तविक जीवन में कोई पेशेंट आता है जिसको मल्टीपल मॉर्बिडिटीज हैं, कोई रेयर डिजीज है या कोई बहुत ही कॉम्प्लिकेटेड ड्रग कॉम्बिनेशंस वो ले रहा है या कोई कॉम्प्लेक्स क्लिनिकल प्रेजेंटेशन है, तो ये रोजमर्रा हम जो क्लिनिशियंस हैं वो देखते हैं। समस्या ये है कि जो ये रेयर डिजीज और जटिल मामलों का प्रतिनिधित्व डाटा सेट है वो बहुत कम होता है। जो स्टेटिस्टिकली रेयर है वो एल्गोरिथम के लिए लगभग जो है अदृश्य हो जाता है। इस प्रकार जो भी रेयरिटी होती है वो एल्गोरिथमिक ब्लाइंडनेस में कन्वर्ट हो जाती है, और यही परिस्थितियां हैं जहाँ पे क्लिनिशियन की सूझबूझ और अनुभव जो है वो सबसे अधिक महत्वपूर्ण होते हैं। इसलिए एआई को एवरेज केस ऑप्टिमाइजर के रूप में नहीं बल्कि सावधानी पूर्वक सीमाओं को समझते हुए एक क्लिनिकल सपोर्ट टूल के रूप में हमको देखना है। फिर मेडिकल मिस इन्फॉर्मेशन एंड हेलुसिनेशन, इसके विषय में मैंने पहले भी चर्चा की थी। तो ये एक बहुत बड़ी चुनौती है एआई की कि सिस्टम बहुत ज़्यादा आत्मविश्वास के साथ गलत उत्तर भी दे सकता है, और सामान्य उपयोग में हम ये देखते भी हैं, कई बार हम चैट जीपीटी पे कोई प्रॉम्प्ट देते हैं तो कुछ भी उसका एब्सर्ड सा जो है आंसर आता है। जैसे कि फैक्चुअल हेलुसिनेशन है कि हम कोई एक फैक्ट पूछ रहे हैं कि आइसक्रीम का टेस्ट कैसा है, वो किसी प्लैनेट के बारे में बताएगा। ये लॉजिकल हेलुसिनेशन है कि हमने 1+1 पूछा तो वो 5 बताएगा। हालाँकि अब जैसे-जैसे मशीन लर्निंग इम्प्रूव हो रही है, बेटर मॉडल्स आ रहे हैं, तो ये जो हेलुसिनेशन है वो कम हो रहा है। तो लेकिन अगर हेल्थ सेक्टर में आता है तो इसके बड़े गंभीर परिणाम हो सकते हैं, जैसे कि फ़ॉल्स रिएश्योरेंस हो गया, जो डेंजर साइंस है वो मिस्ड हो सकते हैं या रॉन्ग गाइडेंस हो सकता है क्लिनिशियंस को। तो एक आत्मविश्वासपूर्ण लेकिन गलत उत्तर एक कॉशियस बट अनसर्टेन उत्तर से कहीं अधिक खतरनाक हो सकता है। इसलिए जो भी क्लिनिकल एआई सिस्टम है, ये अनिवार्य है कि वो अपनी अनसर्टेनिटी को स्पष्ट रूप से व्यक्त करें, ना कि हर उत्तर जो है उसको पूर्ण निश्चितता के साथ प्रस्तुत करें। इसी तरह मिस इन्फॉर्मेशन के इश्यूज हैं कि गलत जानकारी प्रदान करने के अलावा पेशेंट के अनुरोध, यानी पेशेंट भी चैट जीपीटी से कुछ पूछ रहा है तो वो भी जो फाइनर चेंजेस हैं, फाइनर डिटेल्स हैं, उनको एआई बता नहीं पाता। और कई बार अनहेल्थी बिहेवियर्स, यानी केस ऐसे रिपोर्टेड है कि किसी पेशेंट को कफ था और एआई ने बता दिया कि यू आर सफरिंग फ्रॉम कैंसर। सो दीज ऑल आर रिपोर्टेड केसेस, और फिर वो अनहेल्दी बिहेवियर्स को भी प्रमोट करता है, और कई लोग सेल्फ हार्म भी, वो ओवर ट्रीटमेंट लोग शुरू कर देते हैं। जैसे आजकल बोलते हैं कि गूगल डॉक्टर बन रहा है, तो पेशेंट 10 जगह रिसर्च करके आता है, खुद ही अपना ट्रीटमेंट करता रहता है, और एआई तो हेलुसिनेट भी कर देता है, तो पता चलता है कि और ज्यादा उसका बुरा उसने जो है कर दिया। तो ये, और एक बात और है कि आप देखेंगे कि जो प्रमुख चैटबॉट्स हैं, वो अगर आप स्वास्थ्य से संबंधी उनसे प्रश्न भी पूछेंगे तो कोई डिस्क्लेमर नहीं देते। तो आज भी जो नए यूजर्स हैं वो पता चलता है कि चैट जीपीटी से पूछ रहे हैं और गलत उनका डायग्नोसिस हो रहा है, ओवर ट्रीटमेंट हो रहा है, और कई चीजें जो है वो नजरअंदाज हो रही हैं। इसी तरह एक्यूरेसी एंड सेफ्टी रिस्क हैं। ये 2026 की एक रिपोर्ट है कि एक एआई एनहांस्ड सर्जिकल डिवाइस है द 2D नेविगेशन सिस्टम। तो पिछले 4 साल में कम से कम 10 केस में उसमें बहुत ज़्यादा इंजुरीज हुई। जो एआई सिस्टम वहाँ पे सर्जिकल सारा वहाँ के डायमेंशंस प्रोवाइड करता था, उसके कारण सीवियर इंजुरी हो गई, जिससे सीएसएफ लीक हो गया, स्कल पंक्चर्स, स्ट्रोक शामिल हैं। सो दिस 10 केसेस आर रिपोर्टेड। इसी तरह जो है कई साइनस सर्जरीज में भी एआई गाइडेंस के एरर्स मिले हैं, और कई सीरियस इंजरीज के अलावा भी लगभग 100 से अधिक एडवर्स इवेंट की रिपोर्ट्स हैं, जो बहुत ज़्यादा लीथल या बहुत ज़्यादा सीरियस नहीं होंगी। सो दीज आर ऑल रिसेंटली रिपोर्टेड केसेस जो हैं। अभी जून 2020 में 22 में एफडीए ने एक रिपोर्ट में कहा था कि सोनियो डिटेक्ट सॉफ्टवेयर है जो कि फीटल स्ट्रक्चर्स को गलत लेबल करता है, गलत बॉडी पार्ट से जुड़ा दिखाता है, और अल्टीमेटली फीटल मेडिसिन में वो गलत डायग्नोसिस करता है। इसी तरह प्रीनेटल अल्ट्रासाउंड्स के भी कुछ एआई सिस्टम है जिसमें ये पाया गया कि वो भी गलत जो फीटल पार्ट्स हैं उनको आइडेंटिफाई कर रहा है और गलत उसमें फीडबैक दे रहा है। एक अभी एआई असिस्टेड हार्ट मॉनिटर है मेडट्रॉनिक्स का, तो उसके भी स्टडीज में पाया गया कि कई जो असामान्य हार्ट रिदम्स थी या पॉसेस थे उनको वो पहचानने में फेल रहा। अगला इशू आता है ट्रांसपेरेंसी, एक्सप्लेनेबिलिटी एंड ट्रस्ट का। तो कई एआई मॉडल्स विशेषकर जो बहुत डीप लर्निंग सिस्टम है वो ब्लैक बॉक्सेस की तरह कार्य करते हैं, यानी कि वो क्लिनिशियन एक्सप्लेन वो नहीं कर पाते हैं, ना क्लिनिशियन समझ पाता है कि वो क्यों कोई रिकमेंडेशन दे रहे हैं, और जिससे ट्रस्ट और अकाउंटेबिलिटी है वो कम होती है। जैसे किसी सिंपल डायग्नोसिस, जो क्लिनिकल डायग्नोसिस था, उसमें भी वो कुछ कॉम्प्लेक्स डिसीज बता देते हैं। तो रिसर्च लिटरेचर लगातार इस बात पर जोर देता है कि लेक ऑफ एक्सप्लेनेबिलिटी एडॉप्शन को धीमा कर देता है, और क्लिनिशियंस जो है वो एआई रिकमेंडेशन पर कार्य करने से पहले उसकी रीजनिंग को हमेशा समझना चाहते हैं। फिर पहले भी जैसे चर्चा हुई है कि सिक्योरिटी रिस्क एंड प्राइवेसी इश्यूज हैं, जिसमें कि डाटा ब्रीचेस, जो एआई है वो अत्यधिक मात्रा में सेंसिटिव डाटा को प्रोसेस करता है, और उस पे कभी भी हेल्थ केयर सिस्टम और साइबर अटैक्स का जोखिम रहता है। इसी तरह एआई सिस्टम हमेशा वल्नरेबल है, क्योंकि हैकर जो है वो उसमें हेरफेर कर सकते हैं और फिर कोई भी डायग्नोसिस या ट्रीटमेंट डिसीजन जो है वो गड़बड़ा सकता है। रेंसमवेयर अटैक काफ़ी कॉमन हो जाता है कई बार, जिसमें कि पूरे सिस्टम को एआई पैरालाइज कर सकता है और फिर पेशेंट केयर और क्रिटिकल केयर जो है वो बाधित हो सकती है। फिर प्राइवेसी कंसर्न्स हैं कि जो डाटा एनोनिमाइजेशन चैलेंजेस होते हैं कि जो किसी पेशेंट का पार्टिकुलर डाटा है, उसकी प्राइवेसी भी प्रभावित हो सकती है। और अगर एक आईबीएम की रिपोर्ट है कि जो डार्क वेब पे है, उस पे हेल्थ केयर का जो डाटा है, उस वो काफ़ी कॉस्ट का मिलता है, मतलब वो काफ़ी कॉस्ट का इलीगली सेल होता है। तो उसकी जो ब्लैक मार्केट में वैल्यू है वो अन्य सेक्टर्स की तुलना में बहुत ज़्यादा है। इसी तरह कंसेंट एंड डाटा ओनरशिप का इशू है कि पेशेंट अक्सर डाटा एआई डाटा यूज़ को पूरी तरह नहीं समझते और डाटा ओनरशिप की स्पष्टता बाद में जो है कानूनी समस्याओं को उत्पन्न कर सकती है। एल्गोरिथमिक बायस मैंने बताया है कि रूरल, अर्बन, डिफरेंट डेमोग्राफीज़ में जो बायस है, वो भी एआई का जो एक चैलेंज है। संक्षेप में हेल्थ केयर एआई केवल क्लिनिकल एक्यूरेसी का प्रश्न नहीं है, वो साइबर सिक्योरिटी, प्राइवेसी प्रोटेक्शन और एथिकल गवर्नेंस का भी उतना ही गंभीर विषय है। एक लायबिलिटी होती है कि अगर एआई के कारण कोई दिक्कत होती है, कोई किसी की डेथ होती है, तो उसके लिए कौन रिस्पॉन्सिबल होगा? तो ये जो अभी भी रेगुलेटरी, चाहे भले ही डाटा प्रोटेक्शन एक्ट आ गया है या अन्य चीज़ें आ रही हैं, बट काफ़ी उसमें अभी लूप होल्स हैं और रेगुलेटरी और लीगल फ्रेमवर्क अभी भी अस्पष्ट है। और जब कोई एल्गोरिथम रोगी को हानि पहुँचाने में योगदान देता है, तो फिर ज़िम्मेदारी कई पक्षों में बँट जाती है और प्रत्येक के पास अपनी ओर से जो भी है उसको बचाव करना होता है। चाहे वो क्लिनिशियन है, हॉस्पिटल एडमिनिस्ट्रेशन है या जो डेवलपर हैं, कोडर हैं या ईएचआर वेंडर हैं। तो इसको अभी जो वर्तमान लीगल प्रेसिडेंट्स हैं, वो स्पष्ट उत्तर नहीं दे पा रहे हैं। और जो भी प्रोफेशनल लाइसेंसिंग बोर्ड्स हैं, एआई ऑगमेंटेड केयर के जो पैरामीटर्स हैं, वो भी अभी उतने क्लियरली डिफाइंड नहीं हैं। तो इस लीगल लीगल एम्बिग्यूटी के कारण भी कई बार इनोवेशन स्लो हो रहा है और जो नए लोग एआई का यूज़ कर रहे हैं, उनके ऊपर डेफिनिटली मेडिको लीगल रिस्क जो है बढ़ती है। मैंने पहले भी बताया कि वर्कफोर्स का स्किल गैप है, तो उसको हमको इम्प्रूव करने की बहुत ज़्यादा आवश्यकता है। अब मैं संक्षिप्त में कुछ समाधान बताऊँगा कि जो सेफ एआई डिज़ाइन प्रिंसिपल्स हैं, उसमें हमेशा ह्यूमन इन लूप डिसीज़न होना चाहिए। आउटपुट्स जो हैं वो लॉजिकल होना चाहिए, रैशनल होना चाहिए। जो ऑडिट्स हैं उनमें क्या जो भी स्टडीज़ हो रही हैं, जो भी डाटा जा रहा है, उसका बायस ऑडिट ज़रूर होना चाहिए। उसका कंटीन्यूअस वैलिडेशन होना चाहिए और कौन-सा वर्ज़न है, क्योंकि मैंने बताया कि हर वीक अपडेशन हो रहा है, तो उसकी ट्रैकिंग बहुत ज़्यादा ज़रूरी है। और अल्टीमेट डिसीज़न जो है वो क्लिनिशियंस का होना चाहिए, उनकी ओवरराइडिंग अथॉरिटी होना चाहिए। फिर जो हमारा डाटा इंफ्रास्ट्रक्चर है, उसके लिए भी ज़रूरी है कि इंटरऑपरेबिलिटी स्टैंडर्ड्स हों, जैसे हॉस्पिटल्स टू हॉस्पिटल्स अगर डाटा शेयर हो रहा है, तो कैसे सीमलेस डाटा शेयरिंग भी हो, साथ ही डाटा सिक्रेसी का भी ध्यान रखें, उसकी सिक्योरिटी भी हो। और फेडरेटेड मॉडल की पहले किसी स्पीकर ने बात की थी कि इसमें डाटा तो शेयर होता है, कोलैबोरेटिव एआई लर्निंग तो होती है, बट जो पेशेंट की आइडेंटिटी किसी को डिस्क्लोज़ नहीं होती है। तो वो डी आइडेंटिफिकेशन प्रोटोकॉल्स होना चाहिए, प्राइवेसी को ज़रूर हमको रिस्पेक्ट करना चाहिए। फिर गवर्नेंस रिक्वायरमेंट जो हैं, अलग-अलग जो लॉज़ हैं गवर्नमेंट्स ला रही हैं और वर्ल्ड ओवर अभी इस पे नए-नए लॉज़ आ रहे हैं, इंटरपोल भी लेके आई है अभी कि ताकि डिफरेंट कंट्रीज़ के बीच में जो कोलैबोरेशन है, क्योंकि कोई भी अगर क्राइम होता है, कोई भी डाटा लीक होता है, वो पता चल रहा है कि चाइना में इंडिया का डाटा लीक हो रहा है। तो उसके लिए कॉमन इंटरनेशनल जो है जुरिसडिक्शनल इश्यूज़ को रिज़ॉल्व करने की बहुत ज़्यादा आवश्यकता है। तो वो बहुत आवश्यक है और नेशनल एआई हेल्थ स्टैंडर्ड एक तैयार होना चाहिए। सर्टिफिकेशन पाथवेज़ होना चाहिए कि कोई भी कुछ भी एआई सॉल्यूशंस ना बना दे। अब आप देखेंगे कि बहुत सारे एआई स्टार्टअप्स आ रहे हैं और एक बार डिप्लॉय हो गया तो उसका ऑडिट होना चाहिए। फिर एडैप्टिव अप्रूवल मॉडल्स होना चाहिए कि जो भी टेक्निक चेंजेस हो रही हैं, उसके अनुसार हमारी रेगुलेटरी फ्लेक्सिबिलिटी और हम उनको हम जो भी अप्रूवल देने हैं वो टाइमली दें। फिर लायबिलिटी की क्लैरिटी बहुत ज़्यादा आवश्यकता है। फिर परफॉर्मेंस कितना आउटकम वो दे रहा है, उसकी परफॉर्मेंस रिपोर्टिंग बहुत ज़्यादा आवश्यक है। जो इम्प्लीमेंटेशन मॉडल है, वो मैं मानता हूँ कि सबसे पहले विशेषकर हेल्थ केयर में, जैसे मैंने बताया कि जो टेक स्टार्टअप्स हैं, वो तो एक अपना मॉडल लाए और उसको वो सीधे फ्लोट कर देते हैं क्योंकि उनको बहुत ज़्यादा कोई बड़ा नुकसान नहीं होना है। लेकिन हेल्थ में बहुत इंपॉर्टेंट है कि छोटे स्तर पर पायलट हो, उसकी वास्तविक स्थिति क्या टेक्निक है, उसका इम्प्लीमेंटेशन में क्या बेनिफिट हो रहे हैं जो हमारे एंड यूज़र्स को हैं, वो बहुत आवश्यक है। क्लिनिकल वैलिडेशन बहुत ज़रूरी है, उसका कंटीन्यूअस ऑडिट बहुत आवश्यक
Time
है।
is up, please
फिर
wrap it. Fast.
बस सर हो गया मेरा। फिर फेज़्ड रोल आउट हो उसका और कंटीन्यूअस जो है मॉनिटरिंग हो। कैपेसिटी बिल्डिंग मैंने बताया कि वो भी बहुत ज़्यादा आवश्यकता है और हम सब कंटिन्यूअस ट्रेनिंग करते रहें, हमारी भी और अपने स्टाफ्स की भी। और मैंने वही फाइनल मैसेज मेरा यही है कि वी शुड अडॉप्ट विद एविडेंस, डिप्लॉय विद सेफगार्ड and scale with accountability. AI in healthcare is a trust project, not just a technology project. Thank you.
Yeah. Thank you very much for a wonderful lecture. We can take one or two questions.
Thank you for this wonderful presentation. It was very informative. So you talked about all the challenges and their mitigations. Sir, apart from these challenges, सर एक अभी रिसेंट एक न्यूज़ थी जो ओपन एआई के फाउंडर थे सैम अल्टमैन, उन्होंने बोला था कि जो हम लोग चैट जीपीटी में अक्रॉस द वर्ड लोग एक्स्ट्रा पोलाइट होके एक्सेस वर्ड प्रॉम्प्ट में लिखते हैं लाइक प्लीज, थैंक यू, काइंडली, उसके वजह से $10 मिलियन की इलेक्ट्रिसिटी कंज्यूम हो गई। तो सर जब आगे हम लोग एआई इन हेल्थ केयर सर लगाएंगे और इतना हैवी अमाउंट ऑफ डेटा प्रोसेसिंग होगी, तो अल्टीमेटली समवेयर इन द वर्ड इलेक्ट्रिसिटी कंज्यूम होगी एंड कीपिंग इन द माइंड कि resource in the earth are definitive. So how it is, what are the environmental risk and what is the scope of sustainability in employing this मतलब AI in healthcare, sir?
देखो इसका जो यूसेज है, और आप टेक्नोलॉजी को कभी भी डिनाई नहीं कर सकते। जैसे मोबाइल आया तो आपका कैमरा अपने आप खत्म हो गया, जो एसटीडी पीसी होते वो अपने आप खत्म हो गए, और इसकी इतनी यूटिलिटी है ना। और फिर घड़ियां आपकी खत्म हो गई, लोगों ने घड़ी पहनना बंद कर दी। तो मोबाइल इन तीनों एचएमटी की एक घड़ी की कंपनी आती थी, वो बंद हो गई, ठीक है ना। तो ये तो जितना इनका एप्लीकेबिलिटी होगा, जितना हमारे लिए यूजेबिलिटी होगा, ये अपने आप हम नेचुरली अडेप्ट करते जाएंगे। अब जो एनवायरमेंटल रिस्क है या बिजली वाली बात है, और ये सारे जो इश्यूज हैं, वो अपने आप फिर उसका कुछ ना कुछ गवर्नमेंट की कोई गाइडलाइंस आएंगी, कोई पैरामीटर्स आएंगे, और वो रिजॉल्व होगा। अगेन आई एम सेइंग कि जो टेक्नोलॉजी है उसके अडॉप्शन को आप रोक ही नहीं सकते, हम और आप। तो दीज आर डेफिनेटली नेचुरल वो हैं। और वैसे भी मतलब आई डोंट नो, प्रॉम्प्ट इंजीनियरिंग आप करेंगे तो कभी भी थैंक यू बोलना ही नहीं होता है ये मॉडल को। मतलब आप जितना उससे हार्श रहेंगे ना, उतना अच्छा रिजल्ट देता है। तो मतलब मैंने प्रॉम्प्ट इंजीनियरिंग की बातें की, वो कोर्स कर रखा है। तो वी आर यूजिंग इट इन, मतलब अब तो एआई इतना एडवांस है कि आई एम इन गुड़गांव, सो हमको अभी एक चैटबॉट बनवाना था। तो ऐसे ही हम बैठे थे, जितनी देर मैंने प्रेजेंटेशन की उतने देर में जो कोडर आया तो उन्होंने हमारा चैटबॉट बना दिया। हमारा एक पेज है, आप उस पर कुछ भी डालेंगे तो वो उसका रिप्लाई देता है। तो एक व्हाट्सएप ग्रुप है। तो इट इज ऑल एडवांसिंग, और जो भी आपके लिए यूटिलिटी का होगा ना, इट इज अल्टीमेटली यूटिलिटेरियन अप्रोच। वो अपने आप आपको भी अडॉप्ट करना होगा, बाकी चीजें अपने आप टेक केयर करेंगी उसका, आप रोक नहीं सकते उसको।
थैंक यू सर।
एक चीज है, तो डॉक्टर के लिए कुछ सेफ्टी सिक्योरिटी के लिए कुछ ऐप बना हुआ है, जैसे अचानक कुछ हुआ, या सेफ्टी जैसे ऑपरेशन थिएटर में है, HIV पेशेंट मान लो है अचानक से, तो उसके लिए कुछ ऐप बनेगा कुछ ऐसे?
सर वो तो मुझे मालूम नहीं, लेकिन जैसा मैंने बोला कि वो सर अगेन हम सेइंग कि सर जैसे फ्यूचर यूटिलिटी होगी आप तो उनको टास्क बता दो अपनी टीम को, वो कुछ देर में सर आपके लिए बना देंगे। मतलब वी प्रॉब्लम स्टेटमेंट आपको बताना। अब इतने इंडिया में भी इतने एआई स्टार्टअप्स है ना, यू जस्ट टेल देम कि ये हमारी प्रॉब्लम है, दे विल कम अप विद सॉल्यूशन। और अभी बीएचयू के एलुमनाई हैं, उन्होंने आई लिव करके एक वो लॉन्च किया है रिसेंटली, अभी हफ्ता 10 दिन पहले ही हुआ है। तो वी वर पार्ट ऑफ दैट लॉन्चिंग सेरेमनी। और वन इज कार्डियक सर्जन, अदर इज कार्डियोलॉजिस्ट। सो दे आर पुटिंग सेंसर इन योर बॉडी, और वो एफडीए अप्रूव्ड डिवाइस है, और इट विल 24 आवर वो मॉनिटरिंग करती रहेगी। और उनका एक अपना कंट्रोल सेंटर बन रहा है, अभी वो गुड़गांव शिफ्ट होना है, अभी दिल्ली में ऑलरेडी है। तो कोई भी अगर पैरामीटर्स में गड़बड़ आती है, तो उसमें एक येलो वो है उनका और एक रेड जोन है। येलो जोन में आते ही आपके पास फोन आ जाएगा कंट्रोल रूम से कि ये दवाई आपको लेना है। उनके पास सारा आपका डाटा है, मतलब कौन कौन सी बीमारी है। और रेड जोन में जैसे आएंगे, एम्बुलेंस आपके पास आ जाएगी अस्पताल ले जाने के लिए। तो जो नियरेस्ट हॉस्पिटल है, इट्स फर्स्ट ऑफ इट्स काइंड है, आई लिव करके आप नेट पे देख सकते हैं। और बोथ आर बीएचयू एलुमनाई जिन्होंने ये किया, यहीं से यहीं के डॉक्टर्स हैं वो। तो अगेन आई एम सेइंग कि सर अब इतना ज्यादा एडवांसमेंट है कि आप बस अब ये भी स्लाइड मैंने एआई से ही बनाई है ज्यादातर, कुछ मैंने एडिटिंग की होगी। तो आप बस प्रॉब्लम स्टेटमेंट बताइए एंड सॉल्यूशन इज देयर। कोडिंग भी अब एआई करने लगा है, आपकी वेबसाइट डिजाइन कर देगा वो। तो सारा वो चल रहा है अब। इतनी अच्छी अच्छी मतलब इतने हेल्दीफाई मी करके एक ऐप है सर, वो सोचिए कितना मासिव डाटा है उनके पास। और बिल्कुल मतलब स्पीड भी बहुत अच्छी है उनकी, और सारे उनके एल्गोरिथम इतने एडवांस हैं। तो वो आ सकता है, बट मैंने फिर बोला कि वो रिटर्न कंसेंट जो है एंड डॉक्यूमेंटेशन इज वेरी वेरी इंपॉर्टेंट।
डॉक्टर सेफ्टी के लिए बनाइए
सर हम तो वो तो कोई बन सकती है फ्यूचर में, तो बहुत अच्छा है। और ऐसे बहुत स्टार्टअप्स आ रहे हैं एक्चुअली, तो इस पे भी सर विचार कर लेंगे आगे। थैंक यू।
Okay, so if no more questions, let's thank Dr. Apit again. Thank you. And the session closes with this.
Thank you, speakers and respected chairpersons, for an insightful session. We request you to proceed to the selfie point for felicitation. We now arrive at the last session, which bring together discussion at intersection of the technology, healthcare delivery, and ethics. This session will explore how to reduce the overcrowding in OPD using AI and future of face with AI in maxillofacial surgeries. To guide us through the thought-provoking discussions, I have the honor of inviting our esteemed chairperson to kindly take the chair and conduct the session. Professor Akhilesh Kumar sir, Department of Dental Sciences, Oral and Maxillofacial Surgery, IMS BHU. Dr. Abhay Pandey sir, Law Officer, BHU. Professor Chandresh Jaiswara sir, Department of Dental Sciences, Oral and Maxillofacial Surgery, IMS BHU.
Hello. So for the last session, I would like to invite Dr. Arun Pandey. He is alumni of our institute, IMS BHU, graduated from MGPGI Pondicherry and post-graduation from BHU. And currently he is working in Department of Dentistry at ASMC, Kaushambi, Uttar Pradesh. The topic is Future of the Face After AI in Maxillofacial Surgery.
Very good evening to respected chairpersons and my teachers also, and respected director sir, all the respected faculty and delegates. I thank the organizing committee for giving me this opportunity. And मेरे लिए बहुत खुशी और सम्मान की बात है कि जहाँ से मैंने अपनी पढ़ाई की है और सब कुछ सीखा है, आज वहाँ पर मुझे कुछ बोलने का मौका मिल रहा है. तो जो कुछ भी है थोड़ा बहुत मैं कोशिश करूँगा कि सब अच्छे से हो जाए. Thank you. My topic is future of the face after artificial intelligence in the maxillofacial surgery. It's a branch subspecialty of dentistry. Artificial intelligence is a rapidly advancing discipline that harnesses the power of computer science and vast data sets to enhance problem solving capabilities. By mimicking human intelligence, AI systems offer multiple benefits to individuals in their daily lives. Latest algorithms are developing rapidly, and computational resources are increasing, resulting in increased efficiency, accuracy, and reliability of artificial intelligence. Artificial neural networks simulating the neural signal transmission like human brain neurons are an essential part of the AI. Little bit of history. In 1950, Alan Turing was the first person who made the world think that the machines also can, who made the world believe that machines also can think. But in 1956, John McCarthy and his colleagues in the Dartmouth conference coined the term artificial intelligence and discussed the behavior that machines also can learn intelligent behaviors. And from then onwards, from 1980, when the expert system came, and then from 1970 onwards, then 1980 machine learning, and then 1990 the era of deep learning, and the AI boom from the 2010 onwards. What we are seeing nowadays that virtual assistants, recommendation engines like Siri, Alexa, ChatGPT, etc., are now into the play. Types of AI. Broadly, AI has been classified into the based on the function, capabilities, and the function. On the based of capabilities, narrow AI or weak AI. Nowadays, what we are using is the weak AI, that it's performing single tasks, and general AI or strong AI, which is the hypothetical situation or theoretical situation where it can think like humans. It will be act or think like humans. And strong AI is purely hypothetical, where the AI is going to surpass the human behavior, human intelligence, more than the humans. And the type 2 is based on the functions like reactive machines. What we give the input, there will be an reactionary output without any memory. Limited memory, that output is based on some past memory, like what we are doing, ChatGPT, that ChatGPT is
virtual assistants, recommendation engines. Theory of mind means the AI will think like human emotions, social interactions, and it is the self-awareness, a hypothetical situation that will it will develop the self-consciousness of the human beings. The key aspects of the artificial intelligence means that machine, broadly, if in the layman term, broadly that if machine can think like humans, and they are the subsets of artificial intelligence like machine learning, neural networks, and deep learning. So that working of AI in a schematic format, that basically artificial intelligence, any technique that enables machines to solve a task in a way like humans do. Machine learning is algorithms that allow computers to learn from the examples without being explicitly programmed and learn patterns and prediction. And neural networks are the brain-inspired machines. Like there are neurons in the human brain, they work like exactly the same. And deep learning uses these artificial neural network as models to extract features which cannot be extracted by normally, and complex pattern to give the results. So some AI models like large language models understand and generate human language, performing tasks like text generation and analysis. Large vision models process visual data like images and video, while multimodality model handle diverse data type like text and images, integrating techniques tasks to involve different modalities. Artificial intelligence in healthcare. It is affecting healthcare in the diagnosis, that early diagnosis and accurate diagnosis by analyzing complex radiographs, complex scans, and early detection of abnormalities. Even minute of abnormalities can be detected, which can be missed by the human eye or manual error. Drug discovery. Drug discovery takes very longer time, almost 10 years, and billions are wasted in discovering a single drug. So by faster analysis of the chemical compounds in the million chemical compounds and their targets, that this time can be reduced and the cost efficiency also can be reduced. And also predicting the efficacy in the humans where we are going to test the drugs and streamlining its development. Predictive analytics means by electronically assessing the medical records and genetic information of any patient, we can identify the pattern of any disease, or just we can tell that this patient is going to have oral cancer by just assessing the genetic makeup or genetic susceptibility. And by analyzing the lifestyle factor and medical history, we can personalize the medicine, means customize the medicine based upon the genetic makeup of that person. And finally, help supports in the clinical decision making by real-time recommendations, integrating medical evidence, and improving the workflows. Some clinical scenarios like nowadays smartphones with embedded biosensors, smart watches, advanced AI algorithms to analyze complex medical imaging like CT scans, 3D scans, deep learning models for identification of tumors, especially in oncology, diagnosis making. And one example I will tell, that DCNN model. This was developed with 71% accuracy for the diagnosis of skin conditions such as malignant melanoma, benign nevus, keratinocyte carcinoma, and seborrheic keratitis. And it was based on the almost 130,000 images. It was based on 130,000 images. On that basis, they were able to differentiate between this malignant melanoma and benign nevus. And this was almost similar to the work done by 23 specified dermatologists, which also gets 69% of accuracy. So almost similar patterns can be observed. And now AI assistants like BotMD provide around the clock clinical support, bridging the gap between patients and healthcare providers, assisting in faster clinical decision making, which can save the time. Core functionality, data integration, that combining the images, lab results, genetics, pattern recognition, that identifying diseases specific features, risk stratification, decision support by suggesting diagnosis and treatment, multiple treatment options. These systems detect minute of correlations that humans may overlook. Applications are there in the radiology, lung nodules,
identification of lung nodules, fractures, tumors, tumor grading and cancer detection, interpretation of ECG. Sometimes in the smaller setups, doctors are not so much trained for ECG interpretation, but प्रॉब्लम ऐसी हो जाती है कि मजबूरी हो जाती है कि रेफर करना है कि नहीं करना, पता ही नहीं चल पाता कि ईसीजी का पैटर्न कैसा है। एमबीबीएस लेवल पे इतनी ट्रेनिंग नहीं है, तो एआई के सपोर्ट से उसको आसानी से ऐप के माध्यम से हम लोग डिटेक्ट कर सकते हैं और पेशेंट को सही समय पे पहुंचाया जा सकता है या रोका जा सकता है। डिफरेंशियल डायग्नोसिस, emerging developments emphasize explainable AI and hybrid clinician AI models for balanced decision making. तो ये एक इमेज है जिसमें थोड़ा सा ये मैं बताना चाहूँगा कि कैसे एआई से हम लोग जो है हेल्प ले सकते हैं। दिस इज एन पैनोरामिक रेडियोग्राफ, वी कैन सी, which has been augmented. Data has been augmented by rotating in the different direction, vertically, horizontally rotation, and then finally tooth segmentation done by artificial intelligence in two ways. One is the 3D pics, another the two-dimensional pics, and these multiple pics has been learned by the machine learning, processed by the machine learning through the neural networks, and then the prediction on what can be predicted कि caries है, कि bone loss हो रहा है, कहीं कोई fracture है, तो minute things which can be overlooked during the when we see manually, that minute features also can be taken care of through this segmentation. So coming to the specialty of maxillofacial surgery, OFS is a field of dentistry that specializes in the diagnosis and surgical treatment of disorders affecting the oral cavity, jaw, face, and skull. Maxillofacial surgeons are highly trained who conduct a variety of surgical treatments to address functional and cosmetic issues. Maxillofacial surgery blends function, aesthetics, and technology. So basically, maxillofacial surgery is the surgery of the face and dominantly is aesthetic surgery. चेहरा हम लोग के शरीर का सबसे प्रोमिनेंट हिस्सा है। सुबह उठ के सबसे पहले हम चेहरा ही देखते हैं, और अगर चेहरे पे जरा सा भी कुछ डिफरेंस है तो हमारे इमोशंस को, हमारे कॉन्फिडेंस बिल्डअप को कम करता है या बढ़ाता भी है। तो अगर कोई सर्जरी होती है चेहरे की, अगर उसके बाद कोई माइन्यूट सा भी एरर रह जाए तो वो एप्रिसिएटेड है, वो एप्रिसिएबल है, और वो पेशेंट का कॉन्फिडेंस बहुत लूज भी करा सकता है, डॉक्टर से उसका ट्रस्ट भी कम हो सकता है, और वो चूंकि दिखता है तो इट्स वेरी चैलेंजिंग फॉर द maxillofacial surgeons. So AI plays a role which can help in the improving the precision and outcome of the surgeries. I am playing a video just to tell about the domain of maxillofacial.
Good job. Facial cancer. One surgeon fixes it all. Meet oral and maxillofacial surgeons, the specialists of the face, jaws, and mouth. An oral and maxillofacial surgeon begins with 5 years of dental school, followed by 3 intense years of surgical specialization. They are specialists of the face, jaws, and mouth, from facial trauma and fractures, cosmetic facial procedures, to even hair transplantation. Many go beyond routine surgery, training in head and neck cancer surgery and complex facial reconstruction. Some specialize in craniomaxillofacial surgery, handling the most complex facial and skull conditions. This isn't just dentistry. It's surgery, trauma care, cancer treatment, and aesthetics. All in one. Oral and maxillofacial surgeons, the true architects of the human face.
So, AI, artificial intelligence, is steadily transforming the landscape of IMS, not by replacing the surgeons, but by empowering them with the smarter tools. AI will be transforming diagnosis, planning, execution, and outcomes. AI systems can analyze complex imaging data like CT scans, 3D models to aid in the preoperative assessments, virtual surgical simulation surgery, and creation of personalized treatment. Can assist surgeons in intraoperative decision making by providing real-time guidance and feedback, enhancing the surgical accuracy and reducing the complications. So these are the where we can take help of AI: diagnosis of malocclusion, radiographic image improvement, diagnosis of tumor and cyst, localization of cephalometric landmarks, which will help in the planning of orthognathic surgery, and automated update of patients' records. So these are the AI uses in our field: diagnosis, robotic surgeries, image enhancement, cephalometric detection, surgical planning, and safety. So this is the workflow. Patient, we take the image of the patient, then analysis by the artificial intelligence. According to that, we do the virtual planning and then the surgical execution and finally the outcome prediction. So this one just example how AI is detection of tumor detection from the clinical images. Like this one is the histopathological image. This is the clinical photograph and that is the radiomic data. And this data has been through the AI models small features, because this is a larger data, larger pictures. So this has been shorter image patches and feature has been specific features have been extracted like cellular mitosis, location size and texture color. And through machine learning, it has been predicted that yes, all these features predict for the oral carcinoma. What is the role in the oral oncology and reconstruction? Early detection and diagnosis, tumor assessment and staging, prognosis and risk prediction, pre-surgical planning, intraoperative and post-operative support, precision and personalization. And in orthognathic surgery, again in pre-operative assessment like analysis of cephalometric landmark detection, virtual surgical planning, and benefits are increased accuracy, reduced time, improved reproducibility, and minimizing the human error. So, and the prediction surgery, soft tissue prediction, surgical optimization, and real-time navigation support. Now I will just in fast I will tell about a case where we did the virtual surgical planning. So this is a case of facial asymmetry and this is the pre-operative image. So with the this is virtual surgical planning, computer assisted and AI assisted, where the pink portion is the maxilla and in the golden portion is the rotated mandible deviated towards the left side. And after assessment, we did the down fracture in the right side of maxilla. And then with the bilateral sagittal split osteotomy was done to check to correct the rotation of mandible and getting it forward anteriorly, and sliding genioplasty on the right side to correct the chin deviation. Now we can see the after correction we can see the results. And this is the advancement occlusal status, and this is the before and after facial simulation. This was the pre-operative, and after facial simulation we get the that this will be the final result. From the warm eye view, the chin deviation chin, that is also getting corrected to this much extent, and this is the lateral profile. So finally, I have not put the surgical pics, but this is the profile view after the surgery which we have achieved with the help of virtual surgical planning. So here plays the role of AI, which can even more personalized and better outcomes with more precisions. This is a case of mandibular reconstruction with fibula harvesting, where we can plan it preoperatively, the amount of length required, the osteotomy cuts according to the proper, so that proper alignment can be done. This is a case for implant surgery, where we can trace the nerve properly and make the splint so that the implant should bypass the nerve, and we can drill in that location only. This is also coming to the patient specific implants. We can see the lady of facial deformity. For according to that, personalized or customized implant was made, and we can see the results. Now this is a case of ankylosis, where we needed the joint replacement. For that also the maxillary down fracture was done, right side more and little bit on the left side. Then by advancement, bilateral sagittal split osteotomy, sliding genioplasty towards the left side, and then patient guiding plane for the TJR. And this is the customized or 3D printed model of joint, and after the placement of joint. So we can assess it pre-operatively, the exact location, the amount of bone to be cut, and where it will be placed. So this is the final result. This is the facial asymmetry due to the ankylosis. We have treated the asymmetry also and done the joint replacement also.
So real-time navigation and help in the orbital reconstruction, which is very challenging to restore the orbital volume. The post-operative in ophthalmos is very difficult to correct, but with the help of real-time navigation, we can interoperatively check the how correct the orbital contours and adaptation of mesh or grafts properly, so that we can easily get the aesthetics. This is the frontal bone repair case. So depression, we could from the real-time navigation and 3D analysis, we were able to we can see that proper restoration of the contour. In post-operative mining, we can check for the healing prediction models, early complication detection, telemonitoring, patient engagement. Disadvantages are over-reliance, data privacy and security concerns so much have been talked about, algorithm bias, limited generalizability, ethical concerns, and we can in the future we can have interdisciplinary collaboration with ethicists, medical scientists, explainable AI models. We can explain their answers also. Educational and training on the based on the skill labs, AI skill labs, where without live surgeries we can give them the secure platform to learn on the proper 3D anatomy. Ethical and regulatory frameworks has to be made, and integration with the robotics. It can increase the precision of robotic surgery also, where by giving real-time navigation to the robotics, which it is not understanding. Brain labs, and last slide, that AI should support rather than replacing the surgeons. Technology should enhance rather than dictating patient care. Thank you so much for the time.
Thank you, Dr. Arun. Thank you. We are not taking a question. We can do discussion later on because we have lack of time. Our respected director sir and respected dean medicine sir has came. And our next presentation. Thank you, Dr. Arun. Our next presentation is online. Eh? Oh, then we will do later on. We will start with the validatory functions. Thank you.
As we come close to the conference, we sincerely thank all our distinguished speakers, delegates, organizers, and participants for making this event insightful and engaging. Thank you to our chairpersons and our speakers for this session as well. Over these sessions, we have explored how AI is shaping the future of patient care, medical research, and learning environments. Your active participation and valuable discussions have truly enriched this conference. Thank you all for being a part of this conference. And now we will move to the valedictory session.
Good evening to all of you. Respected Director Sir, respected Dean Sir, distinguished guest, esteemed speaker, respected delegates and dedicated member of the organizing team member. On the occasion of the validatory session of 3 days conference, I extend my heartfelt gratitude to all of you. Your knowledge, experience, and active participation have made this event meaningful, inspiring, and truly memorable. I sincerely hope that this dialogue initiated here will pave the way for innovation and excellence in the future. Thank you once again. Now I would like to respectfully invite our esteemed director, sir, to share his guiding word and energize us all.
Very good evening. Thank you very much, Dr. Nilesh. I congratulate all of the team who worked hard, Dr. Nilesh, Dr. Amit, Dr. Munesh, Lalit, Dr. Naveen, Dr. Mamtaji, our respected Dean Sir, Santosh ji, Dr. Bharti, Dr. Anurag, Dr. Shruti ma'am, Amit, Dr. Meena, and all the members of the telemedicine and faculty members of our इंस्टीट्यूट डॉक्टर वंदना डॉक्टर किरण चतुर्वेदी मैम फ्रॉम द लाइब्रेरी हमारे लाइब्रेरी का भी सुपर सपोर्ट रहा थैंक यू सो मच मैम एंड इट वाज नॉट only 2-day workshop, it was a hard work being done for a month together by the organizing team and they left no stone unturned जिसे कहते कोई उन्होंने stone unturned नहीं छोड़ा to make the success of this grand event. So this has been appreciated everywhere. Even the director from the Delhi morning I saw her in the guest house. She spoke very high words for all of the organizing team. So congratulations to organizing team. तो एक बार जोरदार तालियां पूरी ऑर्गेनाइजिंग टीम के लिए. और कहा जाता है कि गुड वर्क मीन्स मोर वर्क, तो अभी और आगे आपको और कॉन्फ्रेंसेस करने के मौका मिलेगा, तो ऑर्गेनाइजिंग टीम खूब अच्छे से इसी तरह से करेगी. आप लगातार अपने प्रयास को अच्छा से अच्छा करने के लिए करते रहें. और ये जो एआई का वर्कशॉप कॉन्फ्रेंस हुआ, एवरीवेयर हाउस वाज वेरी फुल. इट shows the effort, communication, use of AI, and lot of people get enriched their knowledge by this. And you know, virtual darshan of Kashi Vishwanath was also done. About 300 people did darshan. So that was also very wonderful event which was done in this workshop and conference. So once again, I congratulate whole team, congratulate Dean sir for making this event successful. Thank you. Thank you very much. Jai Hind. Vande Mataram. कौन थे बिना? मेमेंटो भी बहुत अलग तरह का था. सर मेमेंटो देने के लिए आज. Winner of the first prize, winner of the poster presentation, Om Shivam. Second prize, Pratibha Kale. Second prize. Third prize, Sobhit Jagga.
It is also there. So second part, they were two person. Yeah, yours is also there. Please come, please come. You deserve the prize. Price of third one and over so many.
Thank you very much, Director Sir and Dean Sir. Now please come toward the stage for memorable photography. Please come. आ जाओ. अच्छा. First prize. आ जाओ. Please. आ जाओ. First prize दे दीजिए.
अरे ठीक है, नीचे खड़े हो जाएंगे नीचे. नीचे आ जाते हैं. छुप जाएंगे पीछे.
नहीं इधर पोडियम हाँ सर आई जाए
आधे लोग नीचे आए
एक और निकाल लीजिए, एक फुट और निकाल लीजिए। नहीं सर, एक पे आया, 2 लोग आए ना, फिर 2 लोग आए हैं
प्राइस वाले ना
ये तो बाकी गया चीजें
आज का लेक्चर नहीं है
मेरा नहीं ये है फुट पे नहीं दो काम पर बहुत मिला सवारी
अब आ जाए फिर
नहीं जो सोना चले तो देगा जो फोटो भी ले आए हैं तो पिक्चर हंसते चला रे तो अभी आप तो तुम लोग आए
50 वो तो क्या
कॉल पे जल्दी भाग क्या
I request all the telemedicine staff to please be on the stage. All the telemedicine staff who have worked hard for last couple of months, please come on the stage.
उसके बाद क्या बैठ जाओ पता लगे
I request now Director Sir to hand over the mementos to the last session chairpersons, Dr. Chandresh and Dr. Akhilesh.
खिंचवाएंगे हम लोग खिंचवाएंगे
आप लोग को देंगे Dr. Akhilesh. Dr. Jaiswara. The last offline speaker, Arun Pandey. We have one more session to go online, so you are the last offline speaker.
Thank you so much, sir. Thank you so much. Yes, sir. Thank you, sir. बहुत मेहनत करने लगी तो मैं तो चले जाए वीसी साहब का मुंह पे सर ठीक In last, I will Thank you all participant, and it's over now. Thank you.